Hello VTU students of the 2018 scheme, the wait is over. As I promised, today we are starting the complete structured preparation of 18MAT11, that is Engineering Mathematics 1 for the 2018 scheme of VTU. Now, if you are serious about clearing the subject, then you please stay. If you are here for time pass, if you are here for just scrolling, if you are not ready to work hard, then you can please leave now. This session is only for serious students, only for those who are tired of failing, and only for those who want to finish M1 once and for all. See my dear friends, mathematics demands a 3P formula: practice, patience and perseverance. So if you follow exactly what I say, practice sincerely, revise properly, you will clear 18MAT11 not because of luck but because of structured preparation. So now I request you to please take your book, your pen, your study materials, your question bank, whatever, your textbook, whatever you have with you, sit properly, because today we are not simply watching a video, we are building your result. And please do share this video with at least one of your friends who has M1 back. Don't let someone lose one more year just because of fear. So dear students, are you ready to clear M1? Okay, so fine. Hold tight. So first, before starting with the main session, I will just brief you about how to just pass M1, because passing here is very easy. VTU syllabus is very easy and passing is also very easy. Okay, so let's discuss it. After discussing with you or briefing you how to pass M1, we'll go in detail that 100% how we can clear M1. Okay, again I tell you, there are some videos, there are some people telling about passing packages. Don't get fooled by that. There is nothing such as passing packages. You are grown up now. Okay. See, if you write to pass, obviously you are going to fail 100%. At least if you write for 80 to 85, at least minimum 70 to 80 marks, then only you are going to get the minimum passing marks. Okay, so but I don't want you to get the minimum passing marks. I want my students who are watching this video at the end, whatever I tell you practice, I assure you that you will easily get more than 80% marks. So please stay with me. Now, briefing about, see, it's very easy to pass M1, as I say. There are 5 modules. The first module is about polar curves, evolutes and all the things. So the questions they ask here are, one is derivation in module 1. One is derivation. We'll discuss it detail. There are 2 derivations. Out of that, 1 derivation will come. So you can easily score here 6 marks. Okay. Next, angle of intersection. Angle of intersection. That is also you can score 6 marks. Then you have pedal equation. See, I am talking about easy things. In that also you can score 6 marks. Then see, 6 to 7 marks. Then there are problems on radius of curvature, evolutes and all. So I will discuss the problems with you later. So if you solve it, it's very easy, but I am showing you just how to pass. See, derivation 100%, 6 marks you can easily score. Angle of intersection also question will be easy, you can easily score 6 marks. Pedal equation of 6 marks. And there is one compulsory question which keeps on repeating for evaluate of parabola. Y square is equal to 4x is 27ay square is equal to 4x minus 2a whole cube. See, many engineering students while attempting the question paper, they leave this question because they find it confusing. Don't worry, later on I will show you this, I solve this problem in the most easiest way as possible. So if you practice it 2-3 times and write down, then you can easily attempt this. This carries 8 marks. So just imagine, there is a problem on evaluate. If they ask, and they have been repeating many times, they ask for 8 marks. So easily, easily you can, in this module, you can easily score around 8 to 14 marks. So I'll catch it, say 12 marks in this module. Say 12 marks. Anyway, so you do some mistakes because students, you are, because I've seen students always do mistakes. Why? Because they don't practice. Again, practice, patience and perseverance are the 3 P's to mathematics. If you miss any one, then you won't be able to understand it. So you have to practice more. If you practice more, then obviously you know what will happen. Next, the next module is, so in this module you can easily score 12 marks. The next module is Maclaurin series, that is series and partial differentiation and maximum minima. Okay, see, I am telling series, partial derivatives and maximum minima. In that, the important questions which can score are module 2. See, one is Maclaurin series. In Maclaurin series, sometimes they keep on repeating the question. Okay, there are some fixed question, I will solve it later, but sometimes they may give tricky question. But I expect this time paper will be very easy. It's a supplementary paper and it's a old scheme. I expect it to be around 70% easy and 30% moderate and 10% little tricky. Okay, so please take into consideration this point. Now Maclaurin series, if they ask repeat question, you can easily score here say 6 marks. Then one is L'Hospital or L'Hopital's rule. In L'Hopital rule, is a question, is a jackpot. I will discuss with that later again. That question has been always repeated in examinations. If they ask it, then please don't leave it, my advice. Okay, answer that. If they ask that, there's a 7 marks. And there's one more, extreme values. One set. In extreme values also, there are 2 questions, 2 problems. Out of the 2 problems, if they ask one problem, then done. You can easily answer the first part and easily score the full 20 marks. Or the second part is also more easy. Why easy? Because see, sometimes what happens, you may forget the things also. Why again? Because you don't practice. Fine. What happens, see, the second is module R. In module R, there is something called as chain rule. In the chain rule, every time in each and every paper, 90% of time, I have seen 2 problems repeating alternately. I will definitely discuss the problems. There are 2 problems which are repeating alternately. That means 6 marks is guaranteed. Okay, and a Jacobian problem also you find it very easy because it's nothing but partially differentiating and finding determinant. That's very easy. If they give easy question from that, then also you can get 7 marks. So anyhow, in this model also there is a problem on, I will say, chain rule, guaranteed problem, and a problem on Jacobian. Next one is Lagrange's. That is also easy only. I will show you. Even if you attend that, so this is also say 6 marks, this is 6 marks. So here also you can easily attend around say 12 marks, 12 to 13. In the least 10 marks say. Okay, done. Then module 3. See, the module 3 is thought to be difficult and many students leave it. I don't advise you to leave this module because I will solve the problems. Don't worry, I will just discuss these problems with you. If you practice again, then it's because this integration stuff is very easy here compared to other colleges, other universities. You can easily do the integration, at least triple integration and finding areas and all. But if you are not able to do it, then don't leave anything, please. There are 2 problems which keep on repeating. One is derivation of beta m comma n, and one more is a problem on gamma functions. See, this thing keep on repeating. This for 6 marks, 7 marks derivation, and this is for 7 marks. So here also, if you get both the derivation and the problem, see, there are 2 problems here. One will be definitely there, they will ask in the examination. See, if you are getting this derivation and a problem in one set, then done, jackpot. Otherwise, they may ask in R also. You can at least attend 1 question. So instead of leaving it, you can attend 1 question for 7 marks. Say you can target 6 marks. So how much? 12 plus 24, 30 marks. Now the next one is module 4. In module 4, see, you have something called as Newton's law of cooling. And I think this is the most simplest problem in engineering mathematics 1 paper. So easily here you can get around 7 marks. There are some 3 questions, they will repeat the same. They may change the values, numericals, thank you, but they will repeat the same question as it is. Okay. So you can score in this. Again, you have Newton's law of cooling, then OT. OT sometime they ask for Cartesian curve or polar curve. So if you practice the question which I give you, there also you can easily score 6 marks. Okay, and there are some questions on exact differential equations and you have linear differential equation. Students often again do find it little difficult. If you are well versed in integration and all, then you can easily do it. Okay, because see, I am again telling you, VTU question paper will be easy. It is not difficult at all. Only if you need to practice. Still you have time. If you practice, then you can get the full marks. But here I am just assuming, just in least case how you can pass. So you can attend this 6 or 7, 13. So I can say 10 marks here, because usually this module they find difficult, students find difficult. Next one is module 5. Last one is module 5. Module 5 is considered to be the most easiest module among all the engineering students, because it has simple linear algebra. But still, it's not that simple. Students fail while attempting the questions. It carries 20 marks. If you get 20 marks, done. 150% pass. 20 marks, along you write something, 150% pass. But you do mistakes here. Mistakes, you don't know how to use the calculator. You do mistakes, you don't know how the easy steps, how to solve the problems. Don't worry, I'll show you that. So this module, you can easily score 20 marks, I can tell you blindly. If you follow what I say, if you solve the problems which I say, you can easily score how much? 20 marks. So just imagine, here 20 plus 10, 30. 30 plus 6, 36. 36 and 12, 48. 48 and 12, how much? 60 marks. So 60 marks. So even if you get say out of 60 you get say 40 marks, and if you have internals, 100% pass. But there are some people who even after 40 marks, I think 40 plus extra, even if you don't have internals, you will definitely pass. For one more thing, for people who are having the internal marks properly, there is average internal marks set in VTU, then I will guarantee you at end of the session you will 100%, after going through this video and writing the exam, you will 150% clear the video. I want you to message me or comment me in the comment section. And the students who are less than that average internal marks, don't be afraid. You have to practice little extra. Do what I say, and then also I'll tell you 150% you will clear M1 this time. Don't keep it behind. Okay, so module 5 is very important. It will carry you 20 marks. Here and there, if they cut the marks, you will at least get 40 marks and you will pass. But again, this won't work, because if you write for passing marks, again you'll end up failing. Don't do that. So now we will start the main video. That is the main video that is going to change your lives, and I'll show you each and everything in detail. So again, please stay consistent till the video. Practice along with me whatever I do. Take a pen or paper, and whatever I'm doing, sit and practice. If you're feeling bored, you can pause the video, go and have some tea or something, and just last 15 minutes. Again come back, again do it. There is still time. So if you do exactly what I say, I assure you that you're 100% going to clear this paper M1 once for all. That's it. And one more thing I want to tell you. See, in my 20 plus years of experience teaching engineering mathematics to engineering colleges and other colleges, I have been students leaving engineering just because of these papers, mathematics M1, M2, so on. This is not because they were not intelligent, but these people, they gave up on M1, M2. Please don't make that mistake. One subject cannot decide your career, but your discipline can. Okay, so have a discipline, have practice, have persistence, have patience, and definitely you will clear this subject. Okay, so now let's start with the main part. So let's start this and finish M1 once for all. And I hope you are ready with your pen and paper to start practicing along with me. So I have made a complete list of all the questions which will be asked in examination. If you practice these questions, it's more than enough to pass M1. And also I'll be discussing each and everything here in detail. So please pay close attention. The module 1. From module 1, see, there are two derivations where they frequently repeat in the examination for 6 to 7 marks. Remember, this is a high scoring area. Don't miss any marks here. One derivation is derive tan phi is equal to r d theta by dr, and other one is prove that 1 by p square is equal to 1 by r square plus 1 by r raised to 4 dr by d theta, the whole square. Both derivations are very, very important, as they have been discussed many times in the question papers, and this time also definitely one problem will be there. It means your 6 marks is guaranteed. Okay, so please don't miss that. See this, both the derivation, one is for angle between radius and tangent, other is the perpendicular distance between the pole and tangent, that is the equation, Padel equation. I have already derived in the most simplest way. So please do refer those videos and write as it is. I have given an explanation in the most simplest form as possible. So please go through the video, take a pen, paper, whatever, write a derivation, watch the video, write a derivation yourself, practice 2-3 times. If you don't see, even though I am telling you it carries 6 to 7 marks and you will definitely get the marks, but still I have seen in the answer sheets that the students will get only 3 marks or 2-3 marks. Like why? Because first the diagram should be correct, it should be legible, it should be neat, all the values of r, theta, phi, the curve, everything should be neat. If not neat, they will cut 1 to 2 marks. Okay, write each and everything as I given here, and assure you 100% you get full marks. That's it. I don't want anything to say. It's up to you now. The next thing is find the angle between the curves. See this question. Find the angle between the curves r is equal to a log theta and r is equal to a by log theta. Very important question, and they can ask this time. Okay, so this also I solved. So please practice it. And one more time, please lend your ears. In this module, the formulas are one is please listen to me. Cot phi is equal to 1 by r dr by d theta. Sin theta is 2 sin theta by 2 into cos theta by 2. 1 plus cos theta is 2 cos theta by 2. 1 minus cos theta is 2 sin theta by 2. And cos plus sin by cos minus sin is tan cot pi over 4 plus theta. And also, both the cot and the tan should be, the left side is always cot phi, right side should be in terms of cot only. If left is cot phi, right is in terms of tan theta, then how do you write tan in terms of cot? Cot pi by 2 minus theta. And if the left side is cot phi and if the right side is minus tan theta, how do you write minus tan in terms of cot? Cot pi by 2 plus theta. These things you need to remember. And also the Padel equation was p is equal to r sin phi. There are two formulas. One is p is equal to r sin phi. Phi is the angle which you find, that is angle between the radius and tangent vector. The other formula is 1 by p square is equal to 1 by r square into bracket 1 plus cot square phi. Use that formula. Okay, so all the formulas and the problems and the derivations are given in the videos which I am going to discuss now. So please do refer them. Okay, they are the gateway to your success. That's it. Fine. So find angle between the curves r is equal to a log theta and r is equal to a by log theta. I already discussed it. Please refer the video and practice this, because this is the very, very important question which they frequently ask in examinations. Next, one more. I predict this question they may ask this time. The question is, show that the curves r raised to n is equal to a raised to n cosine theta and r raised to n is equal to b raised to n sine theta intersect orthogonally. Very, very important problem. One more. This problem also I discussed. Please check the video here and solve it. Okay. The next is find the angle between r is equal to sine theta plus cos theta and r is equal to 2 sine theta. One more important question. So I am giving these questions now. I am not giving the whole textbook. I am giving these questions. So there are hardly few questions are there. So if you practice this, it will help you. So please do that. Find the angle between r is equal to sine theta plus cos theta and r is equal to 2 sine theta. This question is also important. They ask this time. Okay. And one more question. See, if the paper goes to be very, very easy, and I expect the paper will be easy this time. So find the angle between the curves r is equal to a into 1 plus sine theta and r is equal to a into 1 minus sine theta. This question also is solved here. So please do refer that. And one more problem. Find the angle between the curves r is equal to a into 1 plus cos theta and r is equal to a into 1 minus cos theta. This is also very important. This question, no? Find the angle between the curves r is equal to a into 1 plus cos theta and r is equal to a into 1 minus cos theta is very easy. Apply log on both sides, differentiate, cot phi is equal to, then use the formulas which I discussed just now, and you get phi 1, phi 2, subtract it, you get the angles. But this problem, find the angle between the curves r is equal to a into 1 plus sin theta and r is equal to a into 1 minus sin theta is a little tricky. So I need you to practice that from the solution which I given here. Okay. The next is very important part, the pedal equation. Find the pedal equation for the curve r square is equal to a square secant 2 theta. Important problem. This also I solved it. Please do refer that. Next is find the pedal equation for r raised to m is equal to a raised to m cos m theta plus sin m theta. Again, please do refer the solution for it. It's very, very important. And this pedal equation is a scoring area, but you need to practice it. I know many of you fail here because you lack in basics. So one thing I guarantee you, if you refer the videos which are solved here, you will not face that difficulty at all. I guarantee you, assure you that. So please do watch the videos and rectify your basics. Find the pedal equation for the curve r is equal to m is equal to a raised to m cos m theta plus sin m. Very important. Okay. Next, there is one more problem. Find the pedal equation for r is equal to a into 1 plus cos theta. I have not solved it. Let me solve for you now. See, find the pedal equation for So before that, I'll do one thing. I'll solve a question on find the angle, show that the curves r raised to n is equal to a raised to n cos n theta and r raised to n is equal to b raised to n sin n theta intersect orthogonally, because I had doubt on this question that they may ask this question. The problem is, I write here, show that r raised to n is equal to a raised to n. Obviously, I solved this question, but I want you to again watch how to find angle of intersection, because after derivation of the polar curve, one problem 100% will be from angle of intersection between two curves. Okay. See, and many people they ask me, I have written but I did not get the step marks. See, step marks will be 100% there, but the step should be correct. If your first step is wrong, then who is going to give marks? Please understand that. It's not the fault of the evaluator, it's your fault, because you don't know the basics properly. Now see this question. Show that r raised to n is equal to a raised to n cos n theta and r raised to n is equal to b raised to n sin n theta intersect orthogonally. So how do you solve this first? We have r raised to n is equal to a raised to n cos n theta, right? So in any polar curve solution, we first apply log on both sides. Okay, so we have log of r raised to n is equal to log a raised to n into cos n theta. This is the way of writing it. Apply log on both sides, bracket. Now see, log r raised to n is equal to, see, log a into b. The three relations in logarithm are log a into b is log a plus log b, log a by b is log a minus log b, and log a raised to k is k log a. Okay. Now here, log c, this will be a raised to n into cos n, a into b. So to apply the logarithm principles correctly, log a into b is log of a raised to n plus log of cos n theta, right? Now again, log r raised to n, the very important property of logarithm, the power of logarithm which we call is log r raised to n is n log r, log r raised to k is k log r, log a raised to k is k log a, raised to power comes down. So we have log r raised to n is n log r is equal to n log a plus log of cos n theta. If you write like this, no one is going to cut marks, they are going to give just step marks. Okay. Next, we have here now differentiate. So n into differentiate with respect to theta. So n differentiation log r will be always in any problem you see 1 by r dr by d theta. And this is 0. Why? Because see, a, b, c, d, m, n, o, p, everything is 0 only. Log a is a constant 0. N as it is, log a is 0. Plus again, log chain rule, differentiation of log of x is 1 by x. Correct. So 1 by cos n theta, but instead of x it is cos n theta. Again differentiation, it's called chain rule. Again cos n theta is minus sin n theta, because differentiation of only sin x is cos x. Cos x is only minus sin x. Apart from that, again you need to differentiate. It's called a chain. Log of x is 1 by x, cos n theta is 1 by cos n theta. Again, it's not plain x in place of x or theta, it's cos n theta. Again, differential cos n theta is cos is minus sin x, minus cos, but it's not plain theta. Again, n theta is there. Again, differential n theta is into n. So n cancels here. So we have cot of phi is equal to minus sin by cos is tan of n theta. correct? Tan of n theta. Fine. Now we can write this as cot of phi is equal to what is, as I told you, left side is always cot. If the right side is minus tan, how to make it cot? Cot of pi by 2 plus theta is minus tan theta. This is simple rules of trigonometry. So now this will be cot of pi by 2 plus, in place of theta is n theta, so n theta. So cot cancel, so I get phi is equal to pi by 2 plus n theta. I will take this as say phi 1, the first angle, okay, because I will need to find the angle of intersection here. The second angle similarly is r is Tn is equal to b is Tn sin n theta. So we have n log r, I will do directly, is equal to, okay, I will apply log on both sides first. So log of r is Tn is equal to log of b is Tn into sin n theta. So now I will do it like this, n log r is equal to n log b plus log of sin n theta, right? Now differentiate n into 1 by r, dr by d theta is equal to 0 plus 1 by sin n theta. Log of sin n theta is log differential log is 1 by x, 1 by sin n theta. Again differential sin is cos n theta. Again differential n theta is into n, so n cancels here. So we have cot of phi is equal to cos by sin is cot of n theta. Cot cancels. We have phi 2 is equal to n theta. That's it. So as you find both phi and phi 2, angle of intersection is given as phi 1 minus phi 2, that is equal to pi by 2 plus n theta minus modulus, because angle is always positive, cancels, so pi by 2, that is equal to 90 degrees, and in mathematics 90 degrees means orthogonal. That's it. Understood? So like this way you can solve other problems. So each and every solution is given. Please do refer that. Okay. The next one is okay, wherever, okay, Patel equation also you can do the derivation same, the solution. Find the Patel equation for r is Tm is equal to a is Tm cos m theta plus sin, that is done. I think next is okay, find the Patel equation for r is Tn is equal to a is Tn cos m theta. Very important problem. This I think they may ask in the examination because it's repeated. Find the Patel equation for r is Tn is equal to a is Tn cos m theta. I have solved it. Please do refer that. The next is radius of curvature. See here, in radius of curvature, this given problem, find radius of curvature of the volume of Descartes x cube plus y cube is equal to 3axy at the point 3a by 2 comma 3a by 2. It's a repeated question. I don't know how many times it has been repeated. So this is also an area of scoring. So please solve this 2 to 3 times. This is a high probability question. Okay. And I have solved this problem in a very simple way. Please do refer the video, practice it so that you don't miss any marks here. Again, find a radius of curvature for r is Tn is equal to a is Tn sin n theta. Again, very important problem. Both r is Tn cos n theta and r is Tn sin n theta is solid. So please do refer the videos. And also the links are given in description below. You can refer the link and practice them. Everything I will give you ready made. Don't worry about it. And also at 7 days before the examination, I will be posting a set of 2 model question papers which have to solve it. And if possible, you can email me the solutions. I will check it myself. Okay. So that will guarantee that those model papers, if you solve, will guarantee that you will 100% clear mathematics. It's my guarantee. I will not post that. I will post 7 days before the examination or 1 week before the examination on my YouTube channel or Facebook or Instagram pages. So please stay updated. Okay. And please follow them. Next is show that for the curve r is equal to a into 1 plus cos theta, rho is constant. Rho is again the radius of curvature. Okay. So this is, I haven't solved. Let's solve this question. Okay. So now the problem on radius of curvature. Rho is radius of curvature. P is Patel equation. So Patel equation we discussed here. Radius of curvature. The problem is show that for r is equal to a into 1 plus cos theta, rho is constant. Rho is constant. Here see, rho is called as radius of curvature. Fine. So let's solve this now. So first the way to solve here is we find the pedal equation. Because there is a formula here, I will write a formula. The formula to find a radius of curvature for a polar curve. See, this curve is polar, right? Why? Because there is a radius and angle theta. So for that rho is r dr by dp. So here P is the pedal equation. So we'll use this relation, simple relation, to solve this problem. Fine. Now first r is equal to a into 1 plus cos theta. Apply log on both sides. So we have log r is equal to log of a plus log of 1 plus cos theta. Now apply differentiate both sides. We have 1 by r dr by theta is equal to 0 plus 1 plus cos theta. Again differentiation of 1 is 0, cos theta is minus sin theta. So we have cot of phi is equal to, I discussed the formulas. The formula for sin theta is nothing but 2 sin theta by 2 into cos theta by 2 upon 1 plus cos theta will be 2 cos square theta by 2. Cos and cos 2 cancels. We have minus sin by cos is minus tan theta by 2. Please verify it. Hope you are solving with me. Okay, it's correct. See, cos cancels, sin by tan. Now how do I write minus tan in terms of cot? We write it as, so that implies cot of phi is equal to cot of pi by 2 plus theta by 2. Correct. So cot cancel. So the angle between the radius and tangent vector is pi by 2 plus theta by 2. Okay, this is main. This step you will get the marks. Now for this we need to find a pedal equation. Once you know the pedal equation, we can differentiate and get the answer for ROC, radius of curvature. So we have here P is equal to r sin phi, that is the pedal, where P is the pedal. So P is equal to r into sin pi by 2 plus theta by 2. That is, what is sin 90 plus theta? It's cos theta. Sin of pi by 2 plus theta is cos theta. So it will be r cos theta by 2. Now pedal equation is always a constant. It's always what? Constant. We don't need this theta by 2, cos theta by 2. We don't need this. So where to get the value of this? From the question. So we have r is equal to a into 1 plus cos theta. As you know, 1 plus cos theta is 2 cos square theta by 2. Correct. So we have cos square theta by 2 is equal to r by 2a. So cos theta by 2 will be root of r by 2a. See, I got the value for what? Cos theta by 2. Now why do this? Tell me. Because pedal equation is always a constant. I don't need this cos theta by 2. So for that I use the question given. What's the question? R is equal to a into 1 plus cos theta, where from the basic formulas of trigonometry, which are very much required for polar curves, you can just see the videos which I discussed there. I discussed each and everything. Please go through that. So now here r is equal to a into 1 plus cos theta. R is a into what is 1 plus cos theta? 2 cos theta by 2. From here we need to find the value of cos theta by 2. So cos square theta by 2 is equal to r by 2a. So cos theta by 2 is root of r by 2a. So the pedal equation P is equal to r into root of r by 2a. That is 1 by root 2a. Okay, into r into root r. See, r into root r. R is to 1 by 2. Will be r is to 3 by 2. Fine. Am I right? R into root r, right? R into r is to 1 by 2 plus 3 by 2. Yeah, perfect. So I have the pedal equation here. So we have P is equal to 1 by root a constant, r is to 3 by 2. That implies what I do here, see, rho is equal to r dr by dp. I need what? Dr by dp. I have P. So simply what I'll do, I'll first find dp by dr. Ulta and put it here, I get rho. That's it. As simple as that. So dp by dr will be 1 by root of 2a as it is. Differential of r is to 3 by 2 is 3 by 2 r is to 3 by 2 minus 1. That will be 3 by, this will be nothing but 3 by 2 root 2a into c. Am I right? 3 by 2 minus 1 root 2a into 3 by 2 minus 1, 3 by LCM is 2, 2 minus 1, 2, 3 minus 2 is 1, r is to 1 by 2, that is root r, correct. So p is equal to, we have 3 whole divided by 2 root 2a into root of r, sorry, dp by dr is equal to dp by dr. Therefore that implies the radius of curvature rho is equal to r into dr by dp, ulta, dp by dr is 3 by 2 root 2a into numerator root r. So dr by dp will be inverted, we will get into 2 root 2a by 3, correct, and root r. Am I right? That means here r by root r is again root r only, correct. So this will be again root r, because see r I will first write it here, therefore we can write nothing but 2 root 2a by 3 and see 2 root 2a by 3 r by root r. So r by r is to 1 by 2. So r is to 1 minus 1 by 2. So r is to 1 by 2. So it is root r. Therefore we can write rho is equal to constant into root r. That's it. This is how we solve it. So the radius of curvature here is a constant. Okay. See, so that is, I think this problem, oh sorry, it's a show that for the curve r is equal to a into, okay, so rho square by r is constant, oh, sorry, it is rho square by r is constant, I show it's constant, right? Okay, fine. Now therefore we have rho square, therefore I have rho is equal to this much, that implies rho is equal to 2 root 2a by 3 root r. That implies rho square, square it, when I square it, so sorry I wrote the problem wrong here. The problem actually show that for r is equal to a into 1 plus cos theta, rho square by r is constant. So I found rho has to be 2 root 2a by 3 root r. So if I square it, I get 4, see 2 square is 4, 4 to the 8, 8a by 9 into r. That means take r down, that implies rho square by r is equal to 8a by 9, that is equal to constant. That's the solution. Interesting problem. They may repeat this question. So please practice this question and go. Okay. Apart from this, the other questions which I discussed, those also. That is, which are they? Yeah. Next is, show that the radius of curvature of r is t n is equal to a is t n cosine theta varies inversely as r is t n minus 1. This also problem, I will solve and show it now. Okay. So this problem I haven't solved, so let's solve this now. Show that radius of curvature of r is t n is equal to a is t n cosine theta varies inversely as r is t n minus 1. So I solved different questions like this. So please do refer the videos on my playlist. Everything is important in mathematics, okay? But what I am doing now are very much important, okay? Because this video is designed so that everything I have planned perfectly, so that by practicing this total video and the problem given, as I told you, each and every solution is given in description below. Also the whole PDF for this questions I am doing will also be given. So please check the description and my Facebook page and my Instagram page, okay, for further updates. So inversely as r is t n minus 1. So here the same process what we did in the previous problem. So we have r is t n is equal to a is t n cosine theta. Apply log on both sides. We have n log r. I am writing directly here is equal to n log a plus I have already discussed for this the phi in a previous question, that is show that the curves r is t n is equal to a is t n cosine theta and r is t n is equal to a is t n sin theta intersect orthogonally. The same process we do here. So n log r is equal to n log a plus log of cos of n theta, n into 1 by r dr by d theta is equal to 0 plus 1 by cos of n theta into minus sin n theta into n cancels. So we have cot of phi equals minus tan of n theta. I write it here itself. So we can write minus tan as cot of pi by 2 plus n theta. So we have phi is equal to pi by 2 plus n theta, and next after this please underline, we need to find the as you know the simple formula to find the radius of curvature for a polar curve. As this is a polar curve, r and theta is rho is equal to r dr by dp. So we need to first find Patel equation. So p is equal to r sin phi r into sine of pi by 2 plus n theta, that is equal to r cos n theta. And I think this problem is very simple. Okay, see, there is one more problem I discussed, that is I think it's find the Patel equation for r is 10 is equal to a is 10 cos n theta. That same question occurs here. See that, okay. Now p is equal to r sin phi r cos n theta. Now what I told, Patel equation is always a constant. So where to find the value of cos n theta? See, from the problem itself, from the question itself, r is 10 is equal to a is 10 cos n theta. From here we can write cos of n theta is equal to what? R is to n by a is to n. As simple as that. Simple mathematics. Okay, r is to n, and that value which you found here, we have to put it here and get a solution. So therefore p is equal to r into what is cos n theta from here, from problem, because Patel equation is always a constant, it cannot, there need not be any theta involved here. So is equal to r into what is cos n theta? R is to n by a is to n. That implies the Patel equation is p is equal to r is to n plus 1 by a. That's it. Sorry, a is to n. Okay. Now the formula for the radius of curvature rho, ROC, rho is equal to r dr by dp. It implies dp by dr is equal to 1 by a is to n, as it is. Differentiation of r is to n plus 1 is n plus 1 into r is to n plus 1 minus 1 n only. Okay. Therefore rho is equal to r into dr by dp, ulta. So a is to n by n plus 1 into r is to n, that is a is to n by n plus 1 constant as it is, and this will be 1 by r is to n minus 1. That means this is constant into 1 by r is to n minus 1. So what they are asking, show that the radius of curvature of r is to n is equal to a is to n cos theta varies inversely as r is to n minus 1. See, 1 upon r is to n minus 1 very inversely. Therefore rho varies inversely as r is to n minus 1. That's the solution. I hope you got it clear. Okay, fine. The next one is one more problem. See, sometimes no, they discuss this problem, that is find a radius of curvature of the volume of Descartes x cube plus y cube is equal to 3xy at point 3a by 2, 3a by 2 on it. I already discussed this question, the solution is there. But apart from this, there is one more question they have asked twice or thrice in the papers, that is show that the radius of curvature for the curve y square is equal to a square into a minus x by x at the point a minus, or find the radius of curvature for the curve y square is equal to a square into a minus x by x at the point a comma 0. So this I haven't solved, I will solve it for you. Fine. Find radius of curvature for y square is equal to a square into a minus x whole divided by x at a comma 0. Again a point. So let's for see, for a polar curve we discussed was different. For a Cartesian curve, the radius of curvature is always rho is equal to 1 plus dy by dx the whole square raised to 3 by 2 upon d square y by dx square. This is formula. That means we need to find dy by dx, again differentiate, find d square by d square, put here in this formula and get the solution. Let's see what happens here. So write it here, y square is equal to a cube by x minus a square. I think this will be easy for differentiation, correct? I open the bracket here, a cube by x minus a square. Now differentiate, so 2y dy by dx equals a cube as it is, differentiate 1 by x is minus 1 by x square, and a 0. So that implies we have dy by dx will be nothing but, this will be how much? Minus a cube by 2 x square y. Am I right? correct? So dy by dx will be minus a cube by 2x square y. Therefore dy by dx at the point a comma 0, at the point a comma 0 means whenever give some points order pairs, x is a and y is 0, simple, that's it. In place of x put a and y put what? 0. So that will be how much? We put a cube by, see, in place of y put 0, anything by 0 is what? Infinity. Infinity. That's the problem here. Now if this is infinity, okay, if this is infinity, then what to do? If dy by dx is infinity, right here, if dy by dx at say x comma y is equal to infinity, then we use one more formula to find the radius of curvature, that is rho is equal to 1 plus, just ulta it, infinity 1 by infinity 0, that's why d square x by dy square, sorry, dx by dy the whole square whole raised to 3 by 2 upon d square x by dy square. Use this relation. So from here that implies we have dx by dy will be, see, dy by dx is minus a cube by 2x square y, so this will be minus 2x square y by a cube. That implies dx by dy at the point a comma 0 will be, now here as I told you, anything into 2 into 0, 0, 0 by 0, anything is 0 only, okay. Again that implies d square x by dy square, that means you differentiate one more time, but here be careful, you are differentiating here with respect to y, minus 2 by a cube as it is into constant, see, you are differentiating with respect to y, so x square y will become product tool, be careful, x square as it is, differentiation of y with respect to y is 1 plus y as it is into again differentiation of x square with respect to y is 2x into dx by dy. But dx by dy, you know, it's nothing but 0. This 0, whole thing cancels. Therefore d square x by dy square at the point a comma 0 is equal to minus 2 by a cube into, as you know, this whole thing is 0, okay. X square means it is, x means in place of only x get put a, so a square into a square, that is minus 2 by a. Therefore rho is equal to 1 plus 0 raised to 3 by 2 upon, sorry, upon minus 2 by a, that is 1 upon, this will be minus a by 2. Therefore rho is equal to a by 2, because radius of curvature is always positive. Therefore you can write radius of curvature for the curve rho is equal to a by 2. That's the final solution. That's it. Please practice it. So even if it doesn't, also means you will know how to solve the problems. That's very important. So steps carries marks. So don't lose, whatever you do, I want you to solve the entire paper and come. So don't lose any marks. Okay, fine. That's so, please, and practice is very important. Understand the pattern, don't memorize anything, please do practice. Hard work is very much important, because you are at this critical juncture that you need to, it's like do or die, okay. And you have such valuable resource in front of you. I am, you know, in spite I am having some critical illness, I am going through cancer treatment, obviously I am having pain. But see, I was receiving a lot of calls, dozens of calls daily from parents and students of people who have not cleared their engineering mathematics of the 18 scheme for physical classes and online classes. So it's difficult for me to take offline classes, but what the least I can do is I can make such a video which will help you to pass. That's what I can do. So please, I am doing my work, you have to do it work. That means you need to practice, practice and practice more. That's it. Okay. So now we are done with this. Now let's move on to the next problem. See, the next problem is the high probability problem. It's the only problem from the chapter Evolute which has been discussed almost 90% times in examination. So most 90% chances of this question appearing in your this semester examination. The problem is show that the evolute of the parabola y square is equal to 4x is 27, a y square is equal to 4x minus 2a the whole cube. I haven't solved this one problem in my previous videos, but I will solve this for you now. So please watch carefully how I am solving it, and the main thing is you need to practice. Only watching me solve a problem doesn't work. You need to take a pen, put your heart into it, put your dedication into it and practice it. Then only you are going to get it. Okay. Otherwise simply after the examination you come completing the paper was big, it was hard. See, there is nothing hard or soft or big or long, nothing like that. Everything depends on practice. The more you practice, the more you become confident. And your confidence increases only when your pen moves. That's it. Okay. So let's solve this problem here. Show that the evolute of parabola, so y square is equal to 4ax, is 27ay square is equal to 4 into x minus 2a the whole cube. Interesting problem. It's a little lengthy one, but I will explain you in a very simple way so to understand. See, for a parabola, y square is equal to 4x is what? Parabola. So to find a evolute, we need the parametric equations. So for the parabola, as you know, the parametric equations are one is x is equal to 80 square, you have to memorize this, and y is equal to 280. That's it. Okay. Now to find the evolute, we need to find the center of curvature. So the center of curvature is nothing but, we can take it as x comma y, capital X comma y, where the formulas you need to memorize it here. X is equal to x minus y dash 1 plus y dash square whole divide by it is y double dash, and capital Y will be equal to y plus 1 plus y dash square divided by y double dash. These formulas you need to memorize. Okay. This is formula for center of curvature. Fine. Now what we'll do, we'll find this derivatives now. Okay. Therefore, from here we have the parametric equations. We will find the what is called as the dy by dx. So we have the parametric equations here. This is x is equal to 80 square and y is equal to 280. Okay. So as you know, dy by dx is nothing but dy by dx in parametric form is written as dy by dt by dx by dt. So we'll find first here. So x is equal to 80 square dx by dt equals 280, and we have y is equal to 280. So we have dy by dt is equal to 2a. That implies dy by dx is equal to dy by dt whole divided by dx by dt. That equals to 2a by 280 cancels, that is 1 by t. Excellent. I found that implies, and right here, what is dy by dx? Y dash equals 1 by t. So this y dash. I am finding all these values because I need to fit the curvature, center of curvature. Now d square y by dx square is equal to differentiation of 1 by t is minus 1 by t square, again with respect to x means into dt by dx. That is equal to minus 1 by t square into what is dt by dx? Dx by dt is 280, dt by dx is ulta 1 by 280, that is minus 1 by 280 cube. That implies y double dash is equal to minus 1 by 280 cube. Am I right? Okay. Please practice along with me. So once you practice along with me, later 2-3 times, then done. Everything retains here. Okay. And my words are designed to retain. Please note that. Next, therefore, we can write x, that implies x is equal to x minus, what is that? X is equal to x minus, I'll put the values here, okay. That will put the values. So we have, what is x? 80 square minus y dash is 1 by t, 1 plus y dash square, y dash square is 1 by t square, correct? No, so y dash is 1 by t, y dash square minus 1 by t square is 1 by t square upon whole divided by y double dash is this part, not whole divided by this part, minus 1 by 2at cube. Perfect. So this will be now, it implies x is equal to, now we can write this as at square. See here, when I take this now, minus and minus become plus, this goes top to become, I write directly, see this becomes now, so minus and minus become plus, so I will take the LCM here. So 1 by t into t square plus 1 by t square, and this minus 1 minus become plus, 1 by 2at cube goes up to become into 2at cube. Fine, you have to simplify it. Now if I open this bracket, so we get x is equal to at square plus, see here, this will be 2at cube by t into t square is t cube into t square plus 1, that is equal to, again we can write this as, I'll write it here, so x is equal to at square, t cube cancel, plus 2at square plus 2a, that implies, I write here, that implies the value of one x is equal to 2at square is 3at square plus 2a. This is one value for x which we have here. What's that? It's 3at square plus 2a. Okay. Next, similarly, let's find the value of y. So what's y here? So we have y is equal to, now capital Y is equal to, similarly, so this will be, see, y plus, what is y? 2at plus this is 1 plus y dash square, so 1 by t square as it is, upon y double dash is minus 1 by 2at cube. Okay, so this will be 2at minus 2at cube into 1 plus 1 by t square, 1 by t square. Perfect. Okay, 2at and this goes up, minus 2at cube into 1 plus 1 by t square. Fine, let's open the bracket. So 2at minus 2at cube minus 2at. Why? Because t cube by t square is t, cancels. So we have capital Y is equal to minus 2at cube. Am I right? Please check your answers. How much? Minus 2at cube. Okay. So this is what we have now. Now from this we need to find the evolute. So how would you find the evolute here now? Tell me. So I have center of curvature is 3at square plus 2a and y is equal to minus 2at cube. Now from here what we will do is, from x is equal to, I write here, from x is equal to 3at square plus 2a, I can write 3at square is equal to, what is that? X minus 2a. So t square will be x minus 2a whole divided by 3. Perfect. I have it here. Okay. Next, from we have y is equal to minus 2at cube, y is equal to minus 2at cube. What we can do is, we can write this as, say, y is equal to 2at cube, right? So it implies, say, let's square it. So we have y square, I'll show you why I'm doing it. If I square this, I'm going to get it as 4a square into t cube square is what? T raised to 6. Are you getting it? Okay, I'll square it here for you. So if I square this, I get minus 2a t cube square. So that will be 4a square. T cube square is t raised to 3 into 2 is 6. So t raised to 6. Perfect. So I get this much. So we can write here t raised to 6. That means I can rewrite this as, so y square is equal to 4a square into t square cube. I can take like this. Why? Because I have the t square value here. Okay. So I have to arrange the equation, so I can get this equation. It implies y square is equal to 4a square into, what is t square? X minus 2a by 3 the whole cube. That will be now y square is equal to 4a square into x minus 2a. I will split this up, x minus 2a the whole cube divided by 27. So that's what I need here, I suppose. So we have this as this much. Therefore, so it's right, what we need here is 27. Okay, I think I made a mistake. T square is equal to x minus 2a by 3a. Sorry, I forgot this 3a here. That's what I'm getting wrong. So this is 3a, so this will be 27a cube. Fine. So 27a cube. So here a and a cancels here. Fine. That means 27, take it aside, a into y square is equal to 4 into x minus 2a the whole cube. Taking capital X is equal to small x and capital Y is equal to small y, we can write 27a, this was capital Y, right? 27a y square is equal to 4 into small x minus 2a the whole cube. I think this is the evaluate. This is the evolute of the parabola. That's it. This is the answer that you get. It's correct, right? 27a y square is equal to 4a. Yeah, 100% perfect. So this is how we solve it. So I have solved it. See, there are many textbooks that discuss it in different difficult ways. I have solved it in the most easiest ways possible. Please do refer this. When you keep on practicing it 2 to 3 times, it will retain here. That's it. That's what I mean to say. Because this is a very high probability question they may ask in the examination. Okay. So I think we are done with the module 1. So again, module 1 is scoring. You need to start from module 1 itself. Then module 2, then you can go for 5th or however possible. But best is start from module 1 too. Okay. So I discussed all the questions here which are very, very important for examinations. So if you solve this perfectly, there will be obviously R options. So based upon R options, 150% all the questions from this only will come in the examination. Okay, I can assure that. So if you practice that, at least you may get 20 or minimum 15, or at the least you can get some 12 marks. So practice practice so that you get at least minimum 15 marks. That's what I mean to say. Okay, so now let's move on to the second modules. Fine. So moving on to the module 2, we have the scoring parts are Maclaurin series, L'Hopital's rule, the chain rule, Jacobians, okay, and some questions on maxima, minima. Fine. So now the first question is obtain Maclaurin series of log secant x up to x to 4 terms. I predict that this question may be asked in this term examination. The problem I solved already. Please do refer that and practice it. And the link is given in description below. Using Maclaurin series, prove that root 1 plus sin 2x is equal to 1 plus x minus x square by 2. This also is a very high probability question. It was asked last time. Depends. Okay, we cannot say. So please practice this question also. Then obtain Maclaurin series of log 1 plus cos x. This I will solve you and show it to you here. This is a very important question. I see it has been asked, I think previous year or before that on paper. So I don't expect this to be asked, but still I will solve this for you. The next problem is expand log 1 plus e raised to x up to x to 4 terms. That is that. Expand log 1 plus e raised to x up to x to 4 terms. So I will solve this for you. So we have, that is when they give simple expand, it is nothing but Maclaurin series. So expand. This is also a very important question. They may ask 1 plus e raised to x. See, the concepts is same here. Only you need to know some bit of differentiation and put in the values. So I solved this couple of questions for you here. So expand y is equal to log 1 plus e raised to x up to x to 4. So what you do is the Maclaurin series. First, please do write the Maclaurin series to get the 1 marks. Y is equal to y of 0 plus x into y1 of 0 plus x square by 2 factorial y2 of 0 plus x cube by 3 factorial y3 of 0 plus x raised to 4 by 4 factorial y4 of 0. That's what they are asking, up to 4 terms. So we need to find only y of 0, y1 0, y2 0, y3 0, y4 0, put it here and get the solution. That's it. Okay. Now let's solve this. We have y is equal to log of 1 plus e raised to x. So y of 0 will be equal to log of 1 plus e raised to 0 is 1, it is log 2. Please do underline. Okay. The second part is y1 is equal to 1 by, see, differentiation of log x is 1 by x. So log 1 plus e raised to x is 1 by 1 plus e raised to x into again derivative of e raised to x is e raised to x chain rule. Okay. So we have y1 of 0 is equal to 1 by 1 plus 0, 2. Yeah, 1 by 2. Fine. E raised to 0 is 1 and e raised to 1, so 1 plus 2. Fine. In place I put the value 0. Next we need to differentiate. So we can differentiate directly here using the quotient rule, but best is to use product rule, because using product rule is more easier than quotient rule in this series. Okay, expansions. So I will take this side, 1 plus e raised to x into y1 is equal to e raised to x or minus e raised to x is equal to 0. I hope you got it clear. I took it this side and took it this side. So minus the equation. Now let us differentiate this. So it will be product rule now. 1 plus e raised to x into y1. So let us say 1 plus e raised to x as it is. Differentiation y1 is what? y2, y1, y2, y2, y3, so on. Plus y1 as it is, because the product rule is differentiation of or derivative of first into second function is keep first function as it is, differentiate second function plus keep the second function as it is into derivative of the first function. So we have first as it is derivative of y1 is y2, y1 as it is into e raised to x minus e raised to x is equal to 0. Now put the value of x is 0. So 1 plus e raised to 1, so 2 y2 of 0 plus y1 is, as you know, 1 by 2 into 1 minus 1 is equal to 0. Fine. That implies we have 2 y2 of 0 is equal to, see, I think 1 by 2, right? Yeah, 1 by 2, because 1 by 2 minus 1 is minus 1 by 2 that side. That implies y2 of 0 will be 1 by 4. That's it. I hope I am correct. Please verify it, your answers. 2 minus it will be 1 minus 1 by 2. 1 by, perfect. Next again differentiate it. So till the fourth term, again 1 plus e raised to x as it is, differentiation of y2 is y3 plus y2 as it is, again derivative of 1 plus e raised to x is e raised to x only, again product rule for this function, y1 into e raised to x as it is plus e raised to x as it is into derivative of y1 is y2 minus e raised to x is equal to 0. Okay, correct. Now this product rule for this and this two, couple 1 plus e raised to x as it is, derivative y2 y3 plus y2 as it is into differentiation 1 is 0, e raised to x plus y1 as it is, e raised to x only, and plus e raised to x as it is into differentiation y2 minus e raised to x as it is. Now I think they add together. Okay, so we have 1 plus e raised to x into y3 plus e raised to x 2 e raised to x y2 plus y1 e raised to x minus e raised to x is equal to 0. So I can find the value of y3 of 0. Again 1 plus, in place I put 0, e raised to 0 is 1, so 2 y3 of 0 plus 2 into 1 is into what is y2? Y2 is 1 by 4. Fine. E raised to 0 1, y2 is 1 by 4, we got it, plus y1 is 1 by 2. See, y1 of 0, y1 are all same, y2 of 0, y2 are same only. So 2 into e raised to 0 1, y2 is 1 by 4, y1 is 1 by 2, again 1 minus e raised to 0 1 is equal to 0. Okay, 2 1s are 2 2s are. Now see, 1 by 2 plus 1 by 2 is 1, 1 was 0. So y3 of 0 is equal to 0. That's all. Lastly, one more time, 1 plus e raised to x as it is, derivative y3 is y4 plus y3 into e raised to x plus 2 e raised to x as it is, derivative of y2 is y3 plus y2 as it is, and 2 e raised to x as it is. Am I right? This is done. 2 e raised to x as it is, first function, differentiation y2 is y3 plus y2 as it is, again 2 e raised to x plus y1 into e raised to x plus e raised to x as it is into derivative of y1 is y2 minus e raised to x is equal to 0. That's it. Now put the values here. If you put the values, I will put directly because this is the last term. So 2y4 of 0, 2y4 of 0 plus y3 is 0 plus 0 plus what is y2? 1 by 4 into 2, y2 is 1 by 4 into 2 plus y1 is again 1 by 2 into 1 plus again y2 is 1 by 4, correct, minus 1. Again this will be, see 2 and the 2 to the 2 cancels, so only 1 by 4 remains. So y4 of 0 is equal to minus 1 by 8. Am I right? Because see 1, 2 and the 2 to the 1 by 2, 1 by 2, 1, minus 1, 0. 1 by 4 go that side, it becomes minus 1 by 4, 2 go this side, it minus 1 by 8. Therefore, log of 1 plus e raised to x in the series expansion is written as y of 0 is log 2 plus x into 1 by 2 plus y1 plus x square by 2 factorial, that is 2 factorial is 2 itself, alright, as it is 2 into y2 of 0 is 1 by 4, correct, plus 0 because alright, x cube by 3 factorial, x cube by 3 factorial 6 into 0 because y3 is 0, and lastly plus x raised to 4 by 4 factorial is 24, correct, into y4 of 0 is minus 1 by 8, so on, correct. So this is the answer what we get. If you further simplify it, this will be log of 2 plus x by 2 plus x square by 8 minus x raised to 4 by 8 4 the 32 192. That's the answer, correct. 8 4 the 32 into 60 90. Yeah, that's the answer. Okay, so I don't expect them to ask this question, but anyhow you practice this, it will help you. Other questions, no, log secant x I doubt they may ask this time, or root of 1 plus sin 2x, fine. One more is find a Maclaurin series of tan x after 64 is of question paper, goes to be very easy. They can ask this question, they ask this once, so I'll just this question also I'll write it for you, then we'll move on to the L'Hopital. Find Maclaurin series for y is equal to tan x. Okay, so very simple question up to x64. Fine. So again we have y is equal to y of 0 plus x into y1 of 0 plus x squared by 2 factorial y2 of 0 plus x cubed by 3 factorial y3 of 0 plus x raised to 4 by 4 factorial y4 of 0. Done. Now let's solve this. We have y is equal to tan x, that means y of 0 is equal to 0 because tan 0 is 0. Then we have y1 is equal to tan x is secant square x, so little bit of differentiation you need to know. Okay, simple differentiation is required here. So we have secant square x, so y1 of 0 is equal to secant 0 is obviously 1 because cos 0 is 1. Now remember one thing, when you are doing for log secant x also you can refer to the example. Here also see secant square x, always when you are differentiating 3 to 4 times more, when they give secant square x, simple trick is what, write secant square x, 1 plus tan square is secant square, sin square plus cos square is 1, 1 plus tan square is secant square, 1 plus cos square is cos secant square. So secant square is 1 plus tan square. Why I am doing it? Because see tan x is y, so I can simply write y1 is equal to 1 plus y square. This will become more easier for me. I have y of 0, I have y1 of 0. Now y2 will be very easy for me. Differential 1 is 0, differential y square is 2y into y1. So y2 of 0 will be what? So it becomes so easy. All the otherwise again different secant square will be 2 secant x into again secant x tan x, secant square tan x. It will be very confusing differentiation. This makes it easy. Y square is 2y into y1, that's all. Okay, so y2 of 0 will be 2 into y is how much? 0 into y1 is, so that will be 0 only. Again differentiate, y3 is equal to it will be now product rule. So what is the product rule now? It will be 2y into derivative y1 is y2 plus y1 into 2y1. So y3 will be equal to 2y y2 plus 2y1 square. That means y3 of 0 will be 2, obviously y0. What is y1? 1, so it is 2. So it is equal to 2. That's it. Okay, and the last differentiation now is y4. So y4 is equal to 2y into y3. See 2y as it is, product rule for this. Derivative y2 is y3 plus y2 as it is, derivative of 2y is 2y1 plus differential of 2y is carried to the 4y1 into y2. Okay, that means y4 of 0 will be equal to, where y is there, it will be 0 only, plus 2y2 is again, see y2 is 0, so 0 only, plus 4y1 into y2, again 0, that is equal to 0. That means tan x is equal to y of 0, 0 plus x into 1 plus x square by 2 factorial is 2 into y2 of 0 is 0 plus x cube by 3 factorial is 6, 3 factorial 6, right, into 2 plus x is to 4 by 4 factorial is 24 into 0. That means I can write tan x as equal to x plus x cube by 2 in the 2 3s are. This is the series up to 4 terms. That's how we expand it. I hope you clearly understood the solution here. But please practice the other problems also, like secant x, log secant x and root 1 plus sin 2x. Very, very important for examination. Okay, so let's move ahead with the next problem now. See, the next problem is on L'Hopital's rule. Simple questions, okay, but still student make mistake. The first problem is evaluate limit of x raised to 0, a raised to x plus b raised to x plus c raised to x upon 3 raised to 1 by x is equal to, find a solution. See, this problem, I imagine, I don't know, since I am teaching from past 20 years, how many times they have been asked in the examination. And I think previous also paper they asked the same question, and this time also they might repeat the same question. It is limit of x change to 0, a raised to x plus b raised to x plus c raised to x upon 3 raised to 1 by x. I solved this question already, so please do refer that. And I will show you one more question like this, taking upon 4. See here, it is a raised to x plus b raised to x, c raised to x upon 3. I take plus d raised to x and show you. So please watch carefully. Very, very important solution. Might be they ask the same question this time. Okay. So practice along with me. So we have evaluate limit of its as x tending to 0, a raised to x plus b raised to x plus c raised to x upon 3 whole raised to 1 by x. Okay. Now, when there is a power to a limit, what to do? We apply log on both sides. So first, we apply assign k is equal to, always in any limits assign k step by step. A raised to x plus b. So okay, I take this question as, since this problem already solved, I take it as plus d raised to x upon 4 whole raised to 1 by x. Okay. Plus b raised to x plus c raised to x plus d raised to x whole divided by 4 whole raised to 1 by x. Now, always when I apply limit to it, it will be a raised to 1 plus 1 4 by 4. So 1 raised to 1 by 0 is infinity. Whenever we have the type as 1 raised to infinity or 0 raised to infinity, infinity to infinity, we apply log on both sides. So log of k equals limit as x tends to 0, log of a raised to x plus b raised to x plus c raised to x plus d raised to x upon 4 whole raised to 1 by x. Now when I apply this log, see there is a property of logarithm. Log a raised to k is k log a. Log a raised to k is k log a. That means this will be log k is equal to limit of x tending to 0, 1 by x into it is log a raised to x plus b raised to x plus c raised to x plus d raised to x upon 4 into 1 by x, it will be upon x. Because to solve any L'Hopital rule, the problem should be a fraction, numerator by denominator. Now, here if you see, okay, now here if you see, when I apply the limits here, again it will be same. So see, a raised to x, it will be log a raised to x plus a raised to 0 is 1, b raised to 0 is 1, c raised to 0 and d raised to 1. So 1 4 by 4 is 1, log 1 is 0, so 0 by 0. So let's apply the L'Hopital's rule here now. Now how do you apply L'Hopital's? Differentiate numerator separately, differentiate denominator separately. So we have log of k equals limit as x tending to 0. Okay. So differentiation of, see this whole thing separate, log, understand this clearly, okay, this whole and this separate. Differentiation of log of x, what's that? 1 by x, am I right? So it will be 1 by x, that means this will be 1 whole divided by a raised to x plus b raised to x plus c raised to x plus d raised to x by 4. 1 by. Again into chain rule, it's not plain x, only differential log x is 1 by x. So log of this thing is 1 by x into again differentiation of upon 4 as it is, differentiation of a raised to x is. See, this is a very standard differentiation which we miss out to memorize. Yes, this is differential, right? Derivative of a raised to x is always a raised to x log a. Listen carefully. Derivative of a raised to x is a raised to x log a. Remember it always. It's used only in this problem. So it will be a raised to x log a plus b raised to x log b plus c raised to x log c plus d raised to x log d upon 4. Okay, whole divided by differential x is what? 1. Done. Now this will be, I think I can apply the limits over now here. So when I apply the limits here, okay, we'll get, so that implies log of k is equal to, so when I apply the limit, this limit goes, so let's apply limit everywhere 0, because we cannot differentiate anything, differential x is 1, again 1 is 0, so it's end. So when I apply the limits now, this will be, see, 0, a is 0 is 1, so log of a plus b raised to 0 is in place x put 0, applying the limit means wherever x is there put 0, b raised to 0 is 1 plus b raised to 0 1 log b plus c raised to 0 1 log c plus log d whole divided by 4, and this again 1 by, okay, 4, and this will be again, see, and apply here 4 by 4, correct now. So a raised to 0 1 4, this will be upon 1 only, because this will be again 1 divided by, so this is bracket 1 divided by 4 by 4. Why? Because see, a raised to 0 1, b raised to 0 1, c raised to 0 1, d raised to 0 1, 1 plus 1 plus 1 plus 1, 4 by 4, 1 cancels. This is what you get. So that implies log of k is equal to, see, log a into b is log a plus log b. It is log a plus log b is log a into b. So log a plus log b plus log a, c d is nothing but log of a b c d into 1 by 4. Again, I can apply the property here. Which property? Log a raised to k is k log a. See here, right here. Log a raised to k is equal to k log a. So based on that property here, this will be nothing but log of k is equal to log of a b c d raised to 1 by 4. Am I right? Therefore, this log and log cancel. The value of k is a b c d raised to 1 by 4. This is the final answer. Beautiful. This is how to solve. So for if the problem is 3 terms a b c, then it will be a b c raised to 1 by 3. That's how we do it. Okay. I hope you clearly understood. Very important question. They can ask this or that question. They may ask this type D, because past 2 years no, they haven't asked 4 terms. They may ask this time. So please practice it and go. It's a high probability question. Please practice it. Fine. Next, see, VTU keeps on rotating the questions many times in the examination. That is a plus point for you. One more L'Hopital rule which I haven't solved it. It is question number 7th. First one is limit as x tends to 1, x raised to 1 by 1 minus x. Again, if I apply k to it, k is equal to limit as x tends to 1, x raised to 1 by 1 minus x. So this means 1 raised to infinity. Again 1 raised to infinity. So we'll apply log on both sides. We have log k is equal to limit as x tending to 1, log of x raised to 1 by 1 minus x. Okay. That will be now again limit as x tending to 1, log x by x 1 minus x, because the property applies log a raised to k is k log a. So write clearly here, log x raised to 1 by 1 minus x. Okay. So log a raised to k is k log a. So it comes down 1 by 1 minus x comes down. So again log will be 0 by 0 only. So I can apply the L'Hopital's rule. So we have log of k equals, differentiate this. Differential log x is limit x tends to 1. See, x is tending to 1 here, log x is 1 by x upon 1 minus minus 1. Why? Because derivative of 1 is 0, differential x is minus minus 1. So we have this, so we have therefore put value here. So log of k is equal to minus 1. So k is equal to e raised to minus 1. That implies k will be 1 by e. That's all. Okay. They asked like this couple of questions for 7 marks. This will carry around 3 to 4 marks. So the next problem here is evaluate one more problem on L'Hopital's. Limit as x tending to 0 cos x raised to 1 by x square. Okay. So let's solve this. So we have k is equal to limit as x tending to 0 cos x raised to 1 by x square. So apply log on both sides because the limit here will be 1 raised to infinity. So we have log k is equal to limit as x tending to infinity log of cos x raised to 1 by x square. As I told you that when I apply log a raised to k is k log a. So this will be now log k is equal to limit as x tending to 0 log of cos x divided by x square. Now again cos raised to 1 log is, so it will be 0 by 0. So I can apply the L'Hopital's rule here. So we have log of k is equal to limit as x tending to 0. Differentiation of cos log cos x is 1 by cos x into minus sin x whole divided by 2x. That would be limit as x tending to 0 minus tan x divided by 2x. Okay. Now there is an interesting thing here. You see, there is a limit, right? The limit says that limit as tan x by x as x tends to 0 is equal to what? 1. Using that limit, see x is tending to 0 here and tan x. So we can rewrite this as, this is nothing but log of k is equal to limit as x tending to 0 minus 1 by 2 into tan x by x. And obviously according to formula tan x by x is equal to 1. Therefore log k is equal to minus 1 by 2 implies log k is equal to minus 1 by 2. So k is equal to e raised to minus 1 by 2 is the answer, or it is equal to 1 upon root of e. That's it. That's how it is done. Okay, this is a solution for it. Fine. So one more problem we will solve here. A last problem in L'Hopital's. So I'll solve it here itself. I hope you're taken on this. If not, then please rewind the video back and write it down. I'll solve it here. So the next problem here is, it says evaluate limit as x tends to pi by 2, limit as x tending to pi by 2, 90 degrees, pi by 2, secant x whole raised to cot x. Okay, let's solve this question. So again, if you apply the limits here, we have, this will be, see secant pi by 2, cos pi by 2 is 0, so secant pi by 2 will be infinity. Tan pi by 2 is infinity, so secant pi by 2 is 0. So we apply log on both sides here. So first apply k is equal to limit as x tending to pi by 2, secant x raised to cot x. So apply log on both sides. Log of k is equal to limit as x tending to pi by 2, log of secant x raised to cot x. Now as you know, log a raised to k is k log a. So we can write limit as x tending to pi by 2 cot x into log of secant x. Now the condition for L'Hopital's is the given question should be fraction. So it's very simple. I can write cot x as 1 by tan x. That's it. So let's see what happens here. So log k is equal to limit as x tends to, and see the limit here. What takes place? Log of secant x by tan x. Fine. Secant see cos 0 is 1, secant cos pi by 2 is 0, secant by infinity, so it will be tan, so it will be okay. I can apply it, the L'Hopital's rule here. So now apply the L'Hopital's rule here. This becomes, that implies we can write log k is equal to limit as x tending to pi by 2. Am I right? This will be now differentiated. Differential log secant x is 1 by secant x into secant x tan x whole divided by tan x is secant square x. Secant cancels. So we get this much again. So we have log of k is equal to limit as x tending to pi by 2 and tan x upon secant square x. Am I right? Please check it. So I have the question problem here. This problem has been asked one time in an examination. We check the limit. We apply log on both sides. So log k is equal to limit x into pi by 2 log secant x is to cot x. Log e raised to k log a, it came down, and since it should be fraction, I wrote it as log secant x upon tan x. Okay. So we have this. So 0 by this thing. Now log k is equal to, we apply the L'Hopital's rule here, 1 by secant x into secant x tan x, secant cancels upon differentiation of tan x secant square x. Again let's differentiate this. We have this as, again it implies, so again this becomes infinity by infinity. So what we can do here is, I will rewrite this as, see what I am doing here, I will rewrite this as log k is equal to solve this problem, limit as x tending to pi by 2, tan x is sin x by cos x, correct, and 1 by secant square x is cos square x. So cos and cos cancels. Again this becomes log k is equal to limit as x tends to pi by 2 sin x into cos x. So what I'll simply do, so wherever we get sin x cos x, this formula, sin into cos, this formula, sin 2x is 2 sin x cos x, correct. So I'll multiply by 2 and divide by 2. So this becomes, that implies log k is equal to limit as x tending to pi by 2 1 by 2 into, what is that, sin 2x. Now we put the value, so in place of x put pi by 2, sin pi is 0, so log k is 0. It implies, I write here, log k is equal to 0, so k is equal to e raised to 0, that is equal to 1. That's the answer. What's k? Okay, so k is equal to e raised to 0, that is equal to 1. That's the solution for this problem. That's all. I hope you understood it clearly. So these are the problems from L'Hopital's rule. So please practice them. But the most important is that this one, a raised to x plus b raised to x. There are 3 terms or 4 terms that may be asked in the examination. So please, I am again telling you, this is a high probability question. Please practice it and don't lose any single marks in it. Okay. So let's move on to the next question now. Now see, the next problem is, there are set of 2 problems are there, very interesting and highest probability problems. If u is equal to f of x minus y, y minus z, z minus x, show that dou u by dou x plus dou u by dou y plus dou u by dou z is equal to 0. And if u is equal to f of x by y, comma y by z, comma x z by x, show that x ux plus y uy plus z uz is equal to 0. Out of these 2 questions, 1 question may be asked in the examination. So I solved this question, so please practice them. The link is given in the description below. The next one is from Jacobians. Jacobians is, the first one is very simple question. If u is equal to x square plus y square plus z square, comma v is equal to xy plus yz plus zx, w is equal to x plus y plus z, find dou u by w by dou x y z. This is also a very simple question. I solved it, and Jacobian is considered to be simple. See this question 12. They might ask this question. It's a nice interesting question. If u is equal to x plus 3y square minus z cube, v is equal to 4xyz, and w is equal to 2z square minus y, find dou uvw by dou xyz at 1 minus 1 0. Very very important question. They can repeat this question in the examination. Solve this also I solved it, so you can find a link in the description below. So refer my solutions. I solve it in a very simple way. Even if you don't know the basics, you can easily understand it. Okay, fine. Next one is okay, Jacobian. One more problem, that is these two questions are there. If u is equal to yz by x, v is equal to zx by y, and w is equal to xy by z, show that dou uvw by dou xyz is equal to 4. Interesting question. They get repeat the same question in the examination. One more is, this also I solved. Please refer the link or find a link in the description. If x plus y by z is equal to u, y plus z is equal to v, z is equal to uvw, show that dou xyz upon dou uvw is equal to uv. This problem has not been asked since a while, so you can expect this to come in this examination, so prepare for it. Anyway, Jacobian questions are very easy. It's nothing but finding determinant. So if you practice these problems, no, see 1, 2, 3, 4, one more is there. One will be asked in the examination definitely. So there is a full chance of scoring around 6 to 7 marks. Okay, remember it. Fine. Don't miss this question, please. This and this question and the which is a chain rule. It will fetch you around 12 to 13 marks guaranteed. Fine. There is one more problem here, that is if x is equal to r sin theta cos phi, y is equal to r sin theta sin phi, and z is equal to r cos theta, show that dou xyz upon dou r theta phi is equal to r square sin theta. Very very important question. There might be a probability they may ask this question if the question is little bit moderate. Okay, if the question paper is easy, no, then they may ask simply this question, which is these first two questions, x square y square z square, or x plus 3y square minus z cube, find the value of 1 minus 0. They can ask. If the question is little moderate, then they may ask these two questions: u is equal to yz by x, z by x by y, or show that dou uv by dou x y is equal to 4, or this one, if x is equal to r sin theta cos phi, y is equal to r sin theta sin phi, and z is equal to r cos theta, show that dou xyz by dou r theta phi is equal to r square sin theta. So better I'll solve this problem for you. Who knows, this same may be asked in examination. Fine. Now, question here is, if x is equal to r sin theta cos phi, y is equal to r sin theta sin phi, and z is equal to r cos theta, show that dou xyz upon dou r theta phi is equal to r square sin theta. Okay. Now, first let's write the spherical coordinates that are given here. So we have here x is equal to r sin theta cos phi. Then we have y is equal to, easy. So let's do everything step by step, into cos phi, and lastly z is equal to r cos theta. Fine. Now we need to find dou of z by dou of r theta phi. Okay. So j, that is Jacobian, is equal to dou of x y z over r theta phi, and that will be equal to. So we have done a lot of problems here, so please refer the playlist for such problems. Now the Jacobian or dou xyz with respect to dou r theta phi will be very simple. Pay close attention here. See, dou x with respect to all r theta phi. Okay, that is dou x by dou r. Dou x with respect to all r theta phi means dou x by dou r, dou x by dou theta, and dou x by dou phi. So dou x by dou theta and dou x by dou phi. That's it. Then y with respect to all. So dou y by dou r, dou y by dou theta, and dou y by dou phi. Right. Lastly, dou z by dou r, dou z by dou theta, and dou z by dou phi. This is the determinant. Now we need to find all the partial derivatives here. Okay, and put in the determinant and find the value of determinant and see if the value comes to be r square sin theta. So let's do it now. First, see, dou x by dou r. Here we are partially differentiating x only with respect to r. See, r is multiplied. That means, how we do it? See, determinant of, watch carefully, dou x by dou r sin theta cos phi as it is. It's very easy, so please pay close attention. Sin theta cos phi as it is. Derivative of r with respect to r is 1. Next, dou x by dou theta. See again, r cos phi as it is. See here, we are differentiating with respect to theta. So r cos phi as it is, differentiation of sin theta with respect to theta is nothing but cos theta. That's it. And lastly, dou x by dou phi, here r sin theta as it is, derivative of cos phi, because see here we are differentiating only with respect to phi. Phi is only here, correct? That means r sin theta, don't touch it as it is. Differentiation of cos phi is minus sin phi. I hope it's clear. Now the next row, dou y by dou r, again r is here, sin theta cos phi as it is, sin theta, oh sorry, this is sin theta sin phi, sorry. Okay, so we have sin theta sin phi as it is. Okay, differentiation of r is 1. Dou y by dou theta. So here see, we are differentiating with respect to theta here, correct? That means r sin phi will be as it is, don't touch it. Derivative of theta, sin theta is cos theta, that's it. Okay, fine. I hope you remember in the previous problems I explained the concept of partial differentiation. That is, if I here if they say apple, banana and a grape, say if r is apple, theta is banana and phi is grape, then they ask dou x by dou r, then only the apple, keep the banana and grapes as it is. That is how the partial differentiation works. So here again see, I show you dou y by dou phi. Here dou y by dou phi, y is in the basket, r sin theta cos phi. There is apple, theta is grape, and r is apple, theta is banana and grapes. Now dou y by dou phi, we need to eat only the grapes here. So r sin theta, don't touch it, that is apple and banana, don't touch it. Differentiation of sin phi is nothing but cos phi, as simple as that. Understood? Similarly here, okay, because many students confuse this partial differentiation. Okay, here we need to differentiate only what they have mentioned, the denominator, that's all. See, dou z by dou r, z is here, r, that means here only apple and banana, no grapes, phi is absent. So dou z by dou r, so cos theta as it is, don't touch the banana. Differentiation of r with respect to r is 1. Dou z by dou theta, so r as it is, banana. Derivative of cos theta is what? Theta, theta. Derivative of cos theta is minus sin theta. Perfect. And the last one is dou z by dou phi. We need to eat banana, but what is that? The basket is only apple and dou z by dou phi, we need to eat only grapes, but the basket here has apple and banana, no grapes. So obviously cannot eat anything. So constant. So derivative of constant is what? 0. That's it. Finish. Now how do you solve it? Say I can take plus minus plus here, but the most easiest way is to start from down. Okay, to find cofactor down. So plus minus plus. Why? Because series element is 0. So everything into 0 becomes 0. So the thing becomes small. Okay, the solution becomes compact. Now first, how to solve it? That implies first plus into cos theta. We are finding for cos theta here, cos theta into square bracket. So plus into cos theta. When you take for this cos theta, see, watch carefully. We leave this column including having cos theta and leave this row including cos theta. Then we have this into this and this, because if you go wrong here in the multiplication, then you'll keep on struggling to get the answer. Fine. Now see, cos theta, I left this column and left this row, this into this, so r square sin theta cos theta into cos phi is cos square phi. Am I right? Fine. Minus, see here, minus r into r square, but there is this, how the determinant was, this into this, minus of this into this. So minus, there is one more minus here. So minus into minus becomes what? Plus. Be careful. So plus r into r is r square. Sin theta into cos theta as it is. Okay. Next. Minus. Okay, done. Fine. Close the bracket. Am I right? Sorry, one more thing remaining. Sine phi into sine phi is sine square phi. Then close the bracket. Okay, next, minus of, what's the component here? Minus r sin theta. Minus into minus r sin theta is what? Plus r sin theta. Write it legibly so you won't go wrong anywhere. So now when you're taking for minus plus r sin theta, we leave this column, leave this row. Now it will be, the operation will be between these two elements. I'll show you this into this. Correct now? Because I'm leaving this column including minus r sin theta, I'm leaving this row including that. So what remains? This into this. So r into sine is sine square theta into cos into cos phi, cos square phi, minus again minus r. So minus r is there, minus of minus r plus r into sine square theta into sine square phi. I hope it's clear. Sine theta, sine square theta, sine phi, sine square phi. Done. So we are done with the determinant here. Now let's evaluate this. So that implies we have cos theta into, see here, if you see here, r square sine theta and r square sine theta is common. So if you take it common here, we get r square sine theta cos theta into bracket cos square phi plus sine square phi. Okay, and here plus r sine theta into, here if you see r sine square theta and r sine square theta is common. Okay, so we have r sine square theta is common here. Inside is cos square phi plus sine square phi. Done. Now as you know, this is 1, this is 1 because sine square plus cos square theta is 1, the trigonometric identity. That means this will be open a bracket, r square sine theta cos square theta plus r square sine cube theta. Now here again see, r square sine theta is common here if you see, because r cube sine theta is common and sine is here. And what remains here? Cos square theta plus sine into sine square, sine cube theta, so sine square theta. Again sine square plus cos square is 1. So this will be now r square sine square theta. I hope we have reached what they are asking the question, that is r square sine theta. Therefore that implies the Jacobians are dou of x, y, z with respect to dou of r theta phi equals r square sine theta. A very, very beautiful solution. That's it. Okay, I hope you understood the solution clearly here. But again, such questions have the probability to be asked in the examination. This is a high probability question, so please practice it 2 to 3 times till you become perfect. Okay, I hope you'll do it. So I hope the question is clear. Now moving on to the next problem, a problem on extreme values of the function. Okay, it says find the extreme values of the function f of xy is equal to x cube plus y cube minus 3x minus 12y plus 20. Very, very important question. Again I am telling you, this question, there are 2 problems like this. One is this one, and one more is find the maximum and minimum values of f of xy is equal to x cube plus 3xy square minus 15x square minus 15y square plus 72x. Both are very important. The first one is very, very important. They discuss it in this time question paper. So don't miss it. Okay, please practice it. If this comes, you should not miss a single marks in the examination. So which one I am telling more to do? Practice. F of xy is equal to x cube plus y cube minus 3x minus 12y plus 20 has a more probability of coming in the examination. Okay, so the videos here, the link is given in the description. To please watch the video and practice it. I explain in a very simple way, a simple partial differentiation because there is no complex terms here, and a simple table. You will clearly understand, don't worry, but you need to practice. Okay, the next one is a very important problem on maxima minima, that is Lagrange's multipliers. See this problem, I think last year's question paper, it was not discussed. I just checked the paper. So this time the paper which you are writing, there is a high probability of this question appearing. A rectangular box open at the top is to have volume 32 cubic feet. Find the dimension of the box requiring least material for construction. It's a simple solution. I'll solve it now in the most simplest way. So please go through the solution and practice it. And again, this is very, very important. Okay. So please don't miss the question. So I hope you clearly understood the problem on rectangular box. Very important problem. The next one is one more problem from the Lagrange multipliers. This problem has been discussed around, I think, 3 times in the 2018 scheme question paper. So I'm solving it because I don't want to leave any loophole left. Okay. I want you to clear the paper this time. I think for many people this might be the last chance. Although I don't know exactly. So, but this time you have to clear it. Fine. And one more time I'm telling you, if you practice exactly the same thing what I'm solving here and what questions are given here, nobody is going to stop you from passing this time. Okay. So please practice it. And be honest. Okay. Practice. Don't just watch. So the next problem here is, I'll discuss here now. Find the stationary values of x square plus y square plus z square subject to condition So the condition here is the next problem here is find the stationary values of x square plus y square plus z square subject to condition. The condition here is xy plus yz plus zx equals 3a square. A problem from Lagrange is made of multipliers, because see, in any problem on Lagrange is multipliers they will give function and condition. Condition is something equal to, in a previous problem rectangle the condition was volume is equal to 32, xyz is equal to 32. Okay. Now here see, the condition here is xy plus yz plus zx is equal to 3 square. So the function here is now x square plus y square plus z square. See, I am solving this in the most easy way. So please don't skip such questions. Even see, sometimes if you practice this question the way I am teaching here, I am showing the most easiest way possible. So if you practice the same question, if the concept will be retained here. That means make the courage. If any other question is asked, to solve that question using the same concept. If you make the courage, then only you will get the answer. Okay? Simply sitting idly with your pen, nothing happens. Confidence comes only when your pen moves. Remember it. Now, x square plus y square z square, and condition is what? We have xy plus yz plus zx is equal to 3a square. This is the condition. Now, the auxiliary function capital X is nothing but function plus lambda into condition. The function here is x square plus y square plus z square plus lambda into, what's the condition? xy plus yz plus zx. See, you can take this sign minus 3a square if you want, but I don't think it's required, because anyway when you are partially differentiating 3a square becomes 0. So now the main, what you need to do here is, first see here, simply fx is equal to 0. Fx means partial differentiation with respect to x. Then fy is equal to 0 and fz is equal to 0. So fx is equal to 0 means partial differentiation with respect to x. It means here see, y square z square 0, so it's only 2x plus lambda into, see, x is here, y as it is, x is 1 plus z as it is differentiation x is 1 is equal to what? 0. Then fy is equal to 0 means partially differentiate with respect to y. So it is what? 2y x at 0 constant plus lambda into, now see, y is here, so x as it is y is 1 plus z as it is y is 1 equals 0. Lastly fz is equal to 0 means z square is 2z plus lambda into zz, okay, y plus x is equal to 0. Now let's equate everything in terms of lambda. It means lambda will be equal to, so what do you do? Equate everything in terms of lambda. Getting it? Get x, see, x keep as it is, get y and z in terms of x, put in the condition, then we will be able to get a stationary parts. And that decides the maximum or minimum value of the function. So let's do it here now. See, first lambda is equal to, take this side. So we have minus 2x by y plus z, simple equation handling. Next, lambda is equal to minus 2y by x plus z. And here lambda is equal to minus 2z by y plus x. Fine. Now let's equate this. So first what I'll do is, I'll make it simple, don't worry. I will equate this and this. So when I equate this both, see lambda, both are equating. See minus 2 and minus 2 cancels. Here only I'll do. So what remains? X divided by x over y plus z is equal to y over x plus z. Okay, nothing cancels here. So let's cross multiply and see what happens. So we have x square plus xz is equal to y square plus zy. Now nothing is cancelling, so if it doesn't, then we'll take all this term this side. X square minus y square plus xz minus zy is equal to 0. See, what is x square minus y square? A square minus b square is a plus b into m minus b. Use simple identities here to solve the equations. So x plus y into x minus y plus z is common into x minus y equals 0. Now here if you see, x minus y is common, bracket x plus y plus z is equal to 0. So x plus y plus z is 0 is no use to us, we cannot find value. So x minus y equals to 0 implies x equals y. See, very important, I got. Was x equal to y from this. Now that means y is equal to x. X as it is, y is equal to x. Now let's, this and this. Equate the lambdas of this and this. So minus 2 cancels. We have y by x plus z equals z by y plus x. So again the same circus. So we have y square plus xy minus xz minus z square equals 0. Now y square minus x square will be y plus, y square minus z square is y plus z into y minus z plus x into y minus z equals 0. Here y minus z is common, so y plus z plus x equal to 0. So again y minus z is equal to 0, so y equals z. That's it. That means we have x equals to y and y is equal to z. That's it. These are the points. Okay. Now let's find all the stationary point. How? That's value of x, y, z. Putting here in the condition. So the condition here is xy plus yz plus zx equals 3a square. So x as it is, y is equal to x. Okay. Y is equal to x and z is equal to x. As you know here, x is equal to z, clear cut. Plus z is x, again into x is equal to 3a square. Now this will be x square plus x square plus x square is equal to 3a square. That is 3x square is equal to 3a square. So x square is equal to a square implies x is equal to plus or minus a. So I'll take x is equal to a here. That means y is also equal to a, and z is equal to a. These are all the stationary values. X is equal to a, y is equal to a, z is equal to a are all stationary values. Okay. So I'll do one thing. We'll find the maximum or minimum also for it. Therefore, the extreme values of the function of x square plus y square plus z square will be nothing but, what's that? In place of x put a, y put a, z put a. So we have a square plus a square plus a square. That's also nothing but 3a square. That's the answer. Beautiful. That's how it is solved. Hope you understood it clearly. Okay, fine. But it looks simple. Main thing is practice. So as I told you, the concept is same for our questions. So if they might give x plus y plus z is equal to a square also. So you can try with that. So once you know the concept, you can easily solve any questions like this in the examination if it comes. Okay. This, since I told this is repeated, this might come. But because in VTU the thing is the cycle keeps repeating. But they might give other question also. So please try to do it. Okay. I hope you'll do it. The next one is last question here. This is, they haven't asked, but I don't want to leave any loophole. It's a matter of your career. See, one more problem. If u is equal to log of x cube plus y cube plus z cube minus 3xyz, prove that dou e by dou x plus dou e by dou y plus dou e by dou z is equal to 3 by x plus y plus z. Show that dou by dou x plus dou by dou y plus dou by dou z the whole square into u is equal to minus 9 by x plus y plus z the whole square. This problem also they ask in normal partial differential questions. So the solution is here. Please find a link in the description. All the links are given, and this PDF format of all questions are given in the description. So please refer that. Okay, please do that. Those questions which I am doing now will definitely save your life. So please do it. Listen to me. Okay, fine. So we are done with the module 2. Now let's move on with module 3. Now coming to the module 3. The module 3 is integration. Your favorite topic. Okay. I know that in my years of engineering, teaching engineering students, I've seen when it comes to integration, the students panic. And more than 80% to 70% students, they leave this topic. So please don't do that. Okay. See, since you are failing so many times, so I'll tell you some questions here. If you do that, that is enough. So I'm not in from here. I have 14 questions, but from 14 also, no, I will be telling some 4 to 5 questions. You do that and go. Okay. At least instead of losing entire 20 marks, you can easily get 6-7 marks or 10-12 marks. That will help boost your marks. Okay. The first question is evaluate minus c to c triple integration minus c to c minus b to b minus a to a x square plus y square plus z square into dx dy dz. Simple question. This has been asked many times from triple integration. So the solution is here. Please try it. So the given problem is evaluate triple integration minus c to c minus b to b minus a to a x square plus y square plus z square dx dy dz. Okay, as you see in the question, there is no definite Cartesian limits given here. So we can take randomly this as say x is equal to, this as y is equal to, and this as z is equal to. So top also will be z, this will be y is equal to, and this will be x is equal to. Okay, so now the inside is we have taken z. That means we have to integrate with respect to z first, always. Okay, now let's integrate first with respect to z. The outer limit remains, that is x is equal to minus c to x is equal to c. We have y is equal to minus b to y is equal to b. When I integrate with respect to z, this integral goes. Now, as I told you, integration of 1 dx is x, 1 dy is y, 1 dz is z. Okay, don't put 0 and all. So here we need to integrate with respect to z. So x square is there, x square as it is. Integration of 1 is z plus y square as it is. Integration of 1 is z plus z square exists. So integration of x is to n is x is to n plus 1 by n plus 1. That is integration of z square will be z is to 2 plus 1 z cube by 3. And the limits are top limit is a, bottom limit is minus a. What remains? We have already integrated to respect to dz. So dx dy remains. Fine. So putting the top limit and the bottom limit a and minus a, the outside will be as it is, x is equal to minus c2, x is equal to c, and we have y is equal to minus b2, y is equal to b. Now in place of z put a, minus in place of z put minus a. So we'll do that. So we have this as x square a plus y square a plus a cube by 3. In place of z you are putting a, minus, see when you are applying minus side always put a bracket, it's recommended. Okay, now in place of z put minus a, so this becomes minus x square a, again minus a, minus y square a, minus a cube, it will be minus a cube whole divided by 3 into dx into dy. Am I right? Now if you see here, see we will do it here only, x square a, this minus into minus become plus, again minus into minus plus and plus. That means x square a plus x square a will become 2x square a, right? Y square a plus y square a will become 2y square a, okay? And a cube by 3 minus minus plus a cube by 3 will become 2a cube by 3. So everything is twice. So I will take the constant 2 outside here and write it as x is equal to minus c2, x is equal to c. Fine. And let's simplify this. Y is equal to minus b2, y is equal to b. So as I taken 2 outside, inside is x square a plus y square a plus a cube by 3 dx into dy. Fine. Now the limit is inside is y. That means we need to integrate with respect to what? Y. So that will be again 2 as it is, x is equal to minus c2, x is equal to c. And when I integrate this to y, this integration sign goes. What remains? X square a, integration of 1, c, x square a as it is, integration of 1 divides y into y. Y square is here, integration of y square is what? Y cube by 3 into a. Again a cube by 3 as it is, integration 1 is y. And since we are done with integrated with y, dy goes. What remains? Dx, and the top limit is b, bottom limit is minus b. Okay. Now we will again put the top limit and bottom limit and simplify. Fine. So we get this as 2 x is equal to minus c2, x is equal to plus c. And if you put the limits here, so in place of y, first you are putting b, let's put it here, x square ab plus b cube a by 3 plus a cube b by 3 minus, again put a bracket, in place of y put minus b. So minus x square ab minus b cube a by 3 minus a cube b by 3. Okay. Closed into dx. Again, as we are done here, same thing happens here also. X square ab minus into minus plus x square ab, b cube a by 3 minus into minus plus b cube a by 3. Okay. A cube b by 3 minus into minus plus a cube b by 3. That is 2a cube. We have 2x square ab, 2b cube a by 3 and 2a cube b by 3. I hope you understood that. Simple simplification. Now again twice 2 comes outside, 2 into 2 becomes 4, integration of x will minus c2 is c. So since I have taken 2 outside, 2 to the 4, this will be as it is, x square ab plus b cube a by 3 plus a cube b by 3 whole into dx. Okay, so we are done till here. Finally, the last integration remaining is what? X. So we'll integrate with respect to x, put the top and bottom limit and see what the answer is. Okay, so we have again 4. Now when we integrate with respect to x, the sign goes, we are integrating here with respect to x dx. That means integration x square is x cube by 3 ab plus b cube a by 3 as it is. Integration 1 is x plus a cube b by 3 as it is. Integration 1 is x and the top limit is c, bottom is minus c. Now let's put the limits. We have 4. See, in place of x put a. So, sorry, in place of x put c here. C is there. So put here you get c cube ab by 3 plus b cube ac by 3. Am I right? Next, see, a cube b into c by 3 minus again bracket. In place of x put minus c. So this will be minus c cube ab by 3 minus b cube ac by 3 and minus a cube bc by 3. That's it. Okay, so we have it here now. Now again, c cube ab by 3 minus into minus c cube ab by 3 will become 2 c cube ab by 3. So minus into minus become plus when you open bracket. Again, b cube ac by 3 minus into minus b cube ac by 3 will become 2 b cube ac by 3. And finally, a cube bc by 3 minus into minus a3 b cube by 3 bc by 3 will become 2 a cube bc by 3. That means again 2 is a constant. Let's take it outside. So when you take it outside, 4 2 is 8. We get 8 into c cube ab by 3. Fine. So we are getting twice. So 2 we take it outside, 4 2 is 8 plus b cube ac by 3 plus a cube bc by 3. So what we can do is, to simplify this, we can take 8 by 3 outside. So again there is ABC common here. So this will be 8 ABC is common by 3 into c square plus b square plus a square. So finally we can rewrite this answer as 8 ABC by 3 into a square plus b square plus c square. And this is the answer. That's it. I hope you understood clearly how to solve the triple integration question. Fine. Evaluate triple integral minus 1 to 1, 0 to z, x minus z to x plus z, x plus y plus z, dy dx dz. Fine. So now if you see the Cartesian limits, there is x and z, so this will be y, and there is z here. So since this is y, this will be x, and this will be finally z. Okay, so y, x and z are the limits here. Fine. Now that means first you need to integrate with respect to what? Y here. Getting it? See, there is x and z, so what remains? Y. Okay, so we cannot take y here again, so you cannot take z here, z is there, so remaining x, so x is equal to z, 0 to z. So finally x is over, what remains? Z. Z is equal to minus 1 to z is equal to 1. So these are the Cartesian limits. Now let's solve this triple integration in a systematic way. You see here, what is inside first? It's y. That means we need to integrate with respect to what? Y. So this becomes z is equal to minus 1 to z is equal to 1, and x is equal to 0 to x is equal to z. When we integrate with respect to y, the integral sign goes, and see we are integrating here with respect to y first. So x as it is, integration 1 is y, plus integration of y is, there's y square by 2, plus z as it is, integration 1 dy is y, and the top limit is x plus z, bottom limit is x minus z into d. So since we are done with dy, what remains? Dx into dz. The next thing is put the top limit and the bottom limit and simplify. We have z is equal to minus 1 to z is equal to 1, x is equal to 0 to x is equal to z. Now top limit is x plus z, that means in place of y put x into x plus z plus x plus z the whole square whole divided by 2, fine, plus z into x plus z minus bracket, minus, put a bracket always. Now in place of y, what's the bottom limit? X minus z. It's very simple. So x into x minus z plus x minus z the whole square whole divided by 2, and finally z into x minus z plus z into x minus z, and what remains? Dx dz. This is what we got. Now we need to simplify this whole thing. Okay, so let's simplify this here entire. So I'm going to solve the whole problem here. The LCM is 2. What is LCM here? 2. So when I take the LCM 2, the 2 will multiply the whole thing. Okay, and I'll take 2 outside. So this will be 1 by 2. Z is equal to minus 1 to z is equal to 1. X is equal to 0 to x is equal to z. Now let's simplify. See, I have taken 1 by 2 here outside. So when I take 1 by 2 outside, the 2 is there. So this will be multiplied. See, I am doing it directly here. Carefully pay attention. X into x is x square plus xz. So multiply by 2. I am taking the LCM here. There is 2 here. There is no 2. So 2 needs to be multiplied. I have taken it outside. So this will be 2x square plus 2xz. And here there is 2 is there, so not required. What is a plus b the whole square? A square plus b square plus 2ab. Apply it here. X square plus 2xz plus z square. Fine. And here again there is no 2. So multiply by 2 plus 2zx minus plus 2z square. Fine. 2zx, z into z square, 2z square. Done. Now this minus bracket. Again the LCM is 2 here. So 2x square minus 2xz, what, right, plus x square plus z square. Fine. X square plus z square minus 2xz. Okay, minus 2xz. Then finally here also the LCM is 2. 2zx minus 2z square into dx into dz. I hope you understood this clearly how I simplified. Now, so opening a bracket here, this becomes 1 by 2, z is minus 1 to z is equal to 1, and x is equal to 0 to x is equal to z remains as it is. Now we have 2x square plus 2xz plus x square plus 2xz plus z square plus 2zx plus 2z square. See here, minus, when I open the bracket, minus into plus become minus 2x square, minus into minus is plus, plus 2xz. Fine. Now minus into plus is minus, minus x square minus z square plus 2xz minus 2zx. Lastly minus into plus is plus, minus into minus, sorry, is plus 2z square. I put a bracket here into dx into dz. Simplified carefully. Now let's see what all cancels here and how much we can reduce it. Okay. So be careful. See, we have here 2xz and 2xz cancels. Then we have here z square and z square cancels. See, there is x square here, x square cancels. And then yeah, 2x square cancels. I hope we are done. So finally, what we get? 1 by 2, z equals minus 1 to 1, x equals to 0 to x equal to z. See, 1, 2, 3, 4, 8xz, plus anything else remaining, yeah, 2z square plus 2z square is 4z square into dx dz. Now what remains? We have done with z and we have followed such a huge simplification to get the result here. Okay, now who remains? X remains and z. So first, since x is inside, first we'll integrate with respect to what? X now. Okay, now 1 by 2, the outside limit as it is, z equals minus 1 to 1. When we are integrating with respect to x, this integral sign goes, dx goes. So integration of x is 8 as it is, x is x square by 2 into z plus again 4z square x as it is, z square as it is, integration of 1 is x with respect to dx. Again the limits are 0 to z, finally dz. So let's again put the top and the bottom limits now. So here we will just simplify here, 2 1s are 2 4s are. Okay, so 1 by 2 z is equal to minus 1 to z is equal to 1. Now when you put in place of, we are done with x, in place of x put z minus 0, 0 to its value is 0. So you simply put in place of x z here, see z square into z, 4 z cube, fine. Again z square into x as z plus 4z cube. Dz. I hope you got it clear. Now 4 plus 4 is 8. So we have 1 by 2. I take 8 outside. Okay. So z is equal to minus 1 to 1 z cube dz. So now let's finally integrate with respect to z, which is a very simple integration. As you know, integration of x to n is x to n plus 1 by n plus 1. So integration z cube will be z raised to 4 by 4. So 2 1s are, 2 4s are cancels here. So this will be 4 into this. When I integrate with respect to z dz, the sign goes, dz goes. What remains? Z is to 4 by 4 and minus 1 to 1 are the limits. 4 4 cancels. When you put the top and bottom limits, we get 1 minus 1. That is how much? 0. So the final solution for this problem is 0. Hope you understood how to solve this problem. But main thing is, this can be asked in the examination. You need to practice at least 2 to 3 times to get the perfect answer. I hope you understood it. Okay. Now, the next problem is very, very important. I've seen that they asked this question many times in the question paper of all the schemes. But I think last time this question hasn't appeared. But so that is, there is a probability that this time they may give this question. So even if you are not able to understand, see the method which I showed here, no, you can easily understand anything. Even if you are new to integration, you will understand, because there is no hi-fi, integration here in engineering. A very simple thing. Like integration x is x to n is x to n plus 1 by n plus 1. So integration x is x square by 2, x cube is x to 4 by 4, sin x is minus cos x, cos is minus and so on, and nothing else. Okay, so you can do it, no problem. So this question is also, I have solved it, so please go through the question and solve it. So I should not say this, but if you are not able to solve it, at least write 4 to 5 times and see that you are able to memorize it. Okay, I should not say that as a lecturer, but it's for you to pass. I don't need nothing from it. Okay. Now, the third question is evaluate double integration of xy into x plus y dy dx taken over the area between y is equal to x square and y is equal to x. This problem also I solved, so please do solve it. So now when I'm watching this video, I know there are 2 types of questions. There are 2 types of students. One is you are listening to me and okay, so I think some of you might have just scrolled ahead for the next module. Some of you want to listen to me and at least try it. So please give it a try. Okay. The next problem is, this is also very important. Find an area bounded by the ellipse x square. Okay. Before that, there is one problem. Find by double integration the area between the parabolas y square is equal to 4x and x square is equal to 4ay. One more very high probability problem. So let me solve this for you here. The next question here is evaluate double integration xy bracket x plus y dx dy taken over area between y is equal to x square and y is equal to x. So how to solve this? So first, as I tell you, always see the graphs. Now these are very easy graphs. I hope by now you might have memorized all the graphs. So we have one graph, one equation as y is equal to x square, that is a parabola, even parts of x, and other is y is equal to x, that is a straight line passing to the x-axis. So now what I told, play with them both. Play with both the equation to find a point of intersection first. Okay, so y both are same. We have x square is equal to x, so x is equal to 1. So y is equal to x, so y is also equal to 1. So the point of intersection is 1, 1. That is the point of what? Intersection. So one work is over. Now the next thing is to draw the graphs. So let's draw the graphs now. So we have the graph here. See, one was y is equal to x, that is a straight line passing to the origin, y is equal to x. Other is y is equal to x square, parabola, even parts of x, so it is symmetrical about the x-axis. This red color, that is y is equal to x square, is this parabola. Now the point of intersection is 1, 1. So these curves meet here at this point 1, 1. So if you drop along x-axis, it becomes 1, 0. Along the y-axis is nothing but it is 0, 1. Okay, that means we need to find which region. This is the region which we need to find. Okay, now it will be very easy if you go along the x-axis. So I have here double integration of xy into x plus y dx dy. So let's give them the coordinate, the points. Okay, so first, as I told you, x, we start with x, we go like this. So from where to where do we go again? X is 0 to 1. So we have x is equal to 0 to x is equal to 1 here, and outside is a constant. What is the rule? Outside is a constant, outside integral is constant. Inside, if x is constant, inside equation is a integral is equation of y in terms of x. So that we have to find from the graph. When I go like this, it's a very simple thing. When I go like this is what comes down and this is what comes top. Okay, see very carefully. When I go like this, walk like this, what I see? Imagine you are going to a vegetable market in a rainy day. Okay, it has rained. So when you go to the vegetable market, they will have some pillar type bamboo pillars, and they will put a tarpaulin on top. If it has rained, then water will be stored under tarpaulin. So when you stand down and see top, you see that curve, hanging curve like parabola. That is what you see with your eyes. But the layer of water which is straight line, you cannot see. That is, it covers the region. That is what's happening here. When you walk like this, you see this red parabola. That is y is equal to x square. Okay, y is equal to x square here. And what you see top, what is covering top is the line y is equal to x. So y is equal to x comes here. That's it, as simple as that. Am I right? So one more time, when I go along the x-axis, what I see is a down equation with my eyes. It is y is x square, and who covers is the line y is equal to x. Now you can easily integrate this. So we have this as x is equal to 0 to, so I rewrite this as x is equal to 0 to x is equal to 1, y is equal to x square to y is equal to x. Let's open a bracket for easier integration. So this will be x square into y plus xy square dx dy. Fine. So that will be now, first we will integrate respect to x. First we will integrate respect to y, since y is inside. So we have the x is equal to 0 to x is equal to 1 outside. This integral goes. So x square as it is, integration of y is y square by 2 plus x as it is, integration of y square will be y cube by 3, because integration of y raised to n is y raised to n plus 1 by n plus 1. I keep on repeating this so that it goes into a system. Okay, so y cube by 3 and the limits are down limit is x square, top limit is x into dx remains. Now in place of y, put the top limit minus the bottom limit. So this will be x is equal to 0 to x is equal to 1. Now in place of y, put x square into x square by 2 plus in place of y again put x into x cube by 3 minus, when there is a minus sign, when you are taking the next down limit, always put a bracket, it will be helpful. In place of y, put x square, so this will be x square into x raised to 4 by 2. Why? Because in place of y you are putting x square is x raised to 4, again plus x into, in place of y put x square, so x square cube, the powers multiply, x square in place of y put x square cube, 3 to the 6, so x is to 6 by 3, done. So now again simplify this, x is 0 to x is equal to 1, x raised to 4 by 2 plus x raised to 4 by 3 minus x raised to 6 by 2 minus x raised to 7 by divided by 3 dx. Now finally integrate with respect to x and get the answer. So when I integrate with respect to x, the sign goes, so bracket. Integration of x raised to 4 is what? X raised to n is, again integration of x raised to n is x raised to n plus 1 by n plus 1. So integration x raised to 4 will be x raised to 4 plus 1, 5 by 5. But here is 3, 5 2s are 10. So this will be now x raised to 5 by 5 2s are 10 plus again x raised to 4 will be x raised to 5 divided by 5 3s are 15 minus x raised to 6 will be x raised to 6 plus 1, 7 by 7, 7 2s are 14 minus again x raised to 7 is x 7 plus 1, 8 by 8 3s are 24. When limit top limit 1 minus 0. Finally 0 we don't need it, simply put the top limit x and get the answer. So here this will be 1 by 10 minus plus 1 by 15 minus 1 by 14 minus 1 by 24. So after simplification the answer becomes, you can use a, better if you use a calculator over here, okay, to get a correct answer, is equal to 3 by 56. That's the correct answer which we need here. That's it. That's how it is solved. Okay, so please practice the previous problem, that is parabolas y square equal to 4x and x square equal to 4ay 2-3 times. And here in while solving integration problems, the diagram is important. So if you draw a diagram correctly and write some equations, then also you'll get some 2 marks. Okay, please keep in mind. Then find the area bounded by the ellipse x square by s square by y square by b square is equal to 1. One more simple questions. I think it is 6 to 7 line question with a simple graph. I show it here. Please pay close attention and solve along with me. Okay. The formula for finding area. See, the formula to find area of a Cartesian curve using double integration is A is equal to double integration of over the region dx into dy. Very simple formula. So we will better understand this by solving the problems. Now find the area of ellipse x square by s square plus y square by b square is equal to 1 by double integration. So let's solve this problem now and understand how it works. So before solving the problem, if you are new to this channel, then please hit the subscribe button right now, and because that is the only motivation that will keep me going on. Okay, now area for a Cartesian curve is given as double integral with the region R dx dy, and this ellipse is a Cartesian curve given by x square by s square plus y square b square is equal to 1. The graph of this Cartesian curve I had drew it here. Now this is the Cartesian curve we have, x square by s square plus y square by b square is equal to 1 with intercepts a comma 0 on the x axis and the intercept 0 comma b on the y axis, and this is the origin 0 comma 0. Now they are asking to find the area. Area means see the whole figure. So for simplicity, I can take one quadrant here. It's easy to understand. I can take this one quadrant. That means all quadrants are equal for the ellipse symmetrical. So that means the area will be nothing but 4 times this one quadrant. Okay, and then you have to apply from the graph the limits of Cartesian form of the order and then integrate it. Okay, so this we can write it as area is equal to how much now? 1, 2, 3, 4. 4 times the quadrant, 4 times double integration of dx dy. Now, what are the limits? See, in double integration, outside is the constant, inside is equation. So as we are not changing any order here, it will be very easy if you apply x first. Okay, go along the x direction, then y. Fine, walk, then climb. Fine. Now, when I go from x direction, I can write x is equal to 0 to what? Where do I go? 0 to a. See this point a. Limit is a. 0 to a. 0 to a. Same as what we did in problems for double integration, specified regions and change of order. Okay. Now when you go, I'm walking. Now what? The second is equation of y in terms of x. When I go like this, I go here, from here, y is equal to 0. Y is equal to 0 to, now who is covering the region? This red color graph. What is this red color graph? It's an ellipse. X square by x square plus y square b square is 1. So this equation we have to write in terms of what? Y. So let's see what equation we get. So we have ellipse equation is x square by x square plus y square by b square is equal to 1. Now y square by b square is equal to 1 minus x square by s square, or y square is equal to b square into, let's take LCM, a square minus x square by s square. Therefore y is equal to, remove the square, we get b by a root of a square minus x square. That's it. We get b by a root of a square minus x square. Fine. So that we'll put here. B by a root of a square minus x square. Okay. That is outside is the constant in terms of x, inside is the equation in terms of y. Now we got the limits of double integration. Let's solve it and see what answer we get. Now that implies we have x 4 times x is equal to 0 to x is equal to a. Now inside we need to integrate respect to what? Y. Because the inside integral is y. So we have to integrate respect to y. So y goes, this integral sign goes, and integration of 1 dy is what? It's y. Integration of 1 dy is y. So y, and the limit is, top limit is b by a root a square minus x square, and the bottom limit is 0. What remains? Dx. So let's put a limit here. So we get 4, 0 to a, b by a root of a square minus x square dx. So that means 4b by a is constant, always take it outside, and inside is x is equal to 0 to x is equal to a root of a square minus x square dx. Now tell me, we have been solving problems as such, and I told you there is a very important formula in integration. That formula is, so I will write that formula here now. Integration of root of a square minus x square dx is equal to x root of a square minus x square by 2 plus a square by 2 sin inverse x pi. A very, very important formula to be memorized. Okay. So we have a very standard formula here. So let's write the same here because it's the same, a root of a square minus x square. Okay. A is as it is. So write the same thing here. So this will become 4b by a. When I integrate respect to x, this integral sign goes and dx also goes. We get x root of a square minus x square by 2. Fine. Next, plus a square by 2 sin inverse x by a, and the limits are 0 to, what's the limit? 0 to a. Okay. So top limit is a, bottom is 0. Put the limit here. So we get 4b by a outside. See, in place of just put a minus 0, a square minus a square will be 0 only. So this will become 0 plus a square by 2 as it is. Now sin inverse xy, in place of x put a, sin inverse a by sin inverse 1 minus 0. So what is sin inverse 1? Sin 90 is 1, sin pi by 2 is 1, so sin inverse 1 is pi by 2. Fine. So we get it as 4b by a into a square by 2 into sin inverse 1 is pi by 2. So now here if you see 2 cancels, 4, 2 to the 4 cancels, a cancels. So the answer for this question is pi ab. So the area of the ellipse x square by a square plus y square by b square is equal to 1 is nothing but pi ab. That's it. But I again keep on repeating, this formula is very important. You need to memorize this formula to solve just such problems. Okay. The next problem here is change the order of integration and evaluate. I'll solve it here. The problem is change the order of integration, that is change order of integration and evaluate 0 to infinity x to infinity e raised to minus y by y dy dx. Now if you see here the limits given, see one is 0 to infinity, other is x to infinity e raised to minus y by y dy dx. Now if you see here, see inside limit is x, so this is double integration, change of order. So obviously there is to be x and y. See this is x, so this will obviously be y is equal to, and this also y is equal to. So outer limit is x is equal to x is equal to. Change of order means simply this x should come here and this y should come here. That means here in this problem the outer limit is x and inner limit is y. Change of order means outer limit should be y and inner limit should be equation of x in terms of y. That's it. So let's draw the graph here so that you understand it clearly. Let me take the graph like this. I'll draw the graph. Okay. So we have double integration. So the x-axis and the y-axis. Now since they are given here, y is equal to x. See only one equation, y is equal to x. And as you know, y is equal to x is the equation of line passing through the origin. This is y is equal to x. Fine. When this is y is equal to x, then x is equal to 0. This is the line along the y-axis, x is equal to 0. And this is y is equal to 0. That means since they are, see x-axis going like this. In the question, they are covering this area. That means now in the solution, change of order, we need to go from y. That means we need to cover this area. Getting clear? Up to infinity it goes. Fine. So let's write the limit here now. Now, how to write a limit here from change of order? That implies we have change of order. Changing order according to the graph. Okay. So first, so see, y will be from see 0 to where? Infinity. I don't know where. 0 to infinity. And x will be from where to where? X is equal to 0 to where? 0 to from here. See whose boundary is coming inside, y is equal to x. So y is equal to x means what? X is equal to y. Equation of x in terms of y inside. And this is e raised to minus y by y dy dx as it is. Now the integration is simple here. See first we are integrating with respect to the inside limit x. It means outside limit y is equal to 0 to y is equal to infinity as it is. Now we are integrating with respect to what? X here. So e raised to minus y by y is constant, don't touch it. Always we are integrating with respect to x. Integration of x is what? Integration of 1 is 1 dx is what? X only. So x and the limits are, so when you integrate the sign goes 0 to y. And what remains? Dy. Now this will be again y is equal to 0 to infinity, and e raised to minus y by y into, in place of x put y minus 0, so it will be obviously y into dy. Y cancels. Simple integration. Integration e raised to minus e raised to x is e raised to x by x, but e raised to minus x is e raised to minus x by minus 1. So integration of e raised to minus y will be e raised to minus y by differential minus y is minus 1 and limit from 0 to infinity. Okay, so this will be now minus e raised to minus y 0 to infinity, so minus e raised to infinity 0 minus e raised to 0, that will be minus 0 minus 1, so answer is nothing but 1. That's all. So the answer is 1. Very simple integration question. Okay, so integration is also simple, you can remember the limits also. Fine, I hope you clearly understood this. Okay, we'll move to the next question now. That is also change of order of integration. The next problem here is again change of order of integration and evaluate double integral, that is integral 0 to 1, then inside integral 0 to root 1 minus x square y square dx dy, change of order. So please check how I solve it and practice it. Okay, evaluate double integral 0 to 1 0 to root 1 minus x square y square dx dy by changing the order of integration. Okay, so before solving this problem, please hit the subscribe button now to keep me motivated, helping you by giving such videos. So now coming back to the problem, see, we have here, as I told you, I will write down this one more time. We have 0 to 1, 0 to root of 1 minus x square y square dx dy. Fine. Now if you see, there is x inside, so obviously this will be y is equal to and y is equal to, right, and the outer limit will be x is equal to, that is constant, x is equal to. Now here, as discussed, the change of order means, as this is given x outside and y inside, change of order means the constant y should be outside and x in equation in terms of y should be inside. That is done by drawing the graph. And this, if you see here the equations, I have the equation, one is y is equal to 0 and y is equal to root of 1 minus x square. Again remove the root, square it, we have y square is equal to 1 minus x square, that means x square plus y square is equal to 1. This is nothing but a circle. Okay, this is a circle, and the graph of the circle x square plus y square is equal to 1 with the radius 1, I had drawn it here. Okay, so this is graph. So obviously the point of intersections are, since the radius is 1, it will intersect 1, 0 on the x-axis and 0, 1 on the y-axis. Okay, so this is the, and this is my origin. So since they mentioned 0 to 1, so we take the first quadrant. So this is the graph which we are interested in, the first quadrant. Okay, now we have to change the order for this problem using this graph. So how to do it now? See, first this is written as y, since these people are walking, right, and then climbing, am I right, along the x, then climbing. Now we need to climb, we need to go like this from y, then walk. So when we go like this from y, so where to where we go along the circle? See, the y-axis, y coordinate, y 0 to 1. So y will be 0 to y is equal to 1. And when we go, okay, so what I see first? You see first x is equal to 0. See, this line is x is equal to 0, and who covers a part, a quadrant, a part of the circle, this red. So this circle is, this is a circle, x square plus y square is equal to 1. So the circle covers that region. This is down I am seeing, and this is the top part which is covering the region. That means the top part is the circle. So in terms of x, so we have x square plus y square is equal to 1. So we need to write in terms of x. It means x square is equal to 1 minus y square. So what is x is equal to? Root of 1 minus y square. And that's it. So we write it here. X is equal to root of 1 minus y square into dx dy. right? Now we need to integrate this to get the answer. So outside limit as it is, y is equal to 0 to y is equal to 1. Integrate with respect to x. So y square will be as it is. See, there is no x, 1 is there. So as I did in the previous videos integral, I mentioned 1 has a value. Differentiation of x is dx is 1. So integration of 1 is x. So we are integrating with respect to x. So integration 1 is x, and the limits are 0 to root of 1 minus y square into dy. So now in place of x put limit, top limit root 1 minus y square and bottom as 0. So we get this as y is equal to 0 to y is equal to 1, y square into root of 1 minus y square dy. Now we need to solve this integration. So how can we solve it? See, this can be easily solved. So wherever in integral you have things like 1 minus x square, 1 minus y square, because here you know the formula trigonometry, sin square theta plus cos square theta is equal to 1. So this is widely used here, is equal to 1. That means we can write what? 1 minus sin square theta is equal to what? Cos square theta, right? So wherever in integration substitution works in a very easy way. We simply put let y is equal to sin theta. Am I right? So what is dy becomes? Dy is equal to sin theta d theta. Differentiate, right? Sorry, y is equal to sin theta. So here we substitute y is equal to sin theta. So that implies what is dy? So everything will be substituted in terms of theta now. So I have to find dy now, everything. So y you know is sin theta. What is dy? Sin theta, dy is equal to different sin theta is cos theta into d theta, right? Therefore we have everything in terms of theta. So the limits will also change. Okay. So when y is equal to 0, theta is also equal to 0. Am I right? Because sin 0, when y is equal to 0, sin theta is 0, theta is 0. But when y is equal to 1, sin theta is equal to what? 1. So what is theta is equal to? Pi by 2, 90, because sin 90 is 1. So the limit changes like, so we have here this as everything changes to theta. Okay, so y theta changes to theta is equal to limits are 0 to theta is equal to what? Pi by 2, right? Now here see, 0 to theta is equal to 0 to pi by 2. Y, what is y? Y is sin theta. So y square will become sin square theta into root 1 minus y square. What is y? Sin theta. Root of 1 minus sin square is root cos square, becomes cos theta into cos theta, and lastly remains dy. When we take y sin theta, what is dy? Cos theta d theta. Cos theta d theta. So this becomes, we have it as theta is equal to 0 to pi by 2 sin square theta into cos square theta d theta. Now how to solve this integration? So integration as such with higher powers like power like 4, 5, 6, so on, mixed integral, can be easily solved using reduction formula. I hope you have learned this reduction formula in your 12th class. Okay, if you forgot it, I read the formula. It's a very simple formula. So the formula says reduction formula. So reduction formula says integration of 0 to pi by 2. See, the reduction formula is applicable, 0 to pi by 2, and here also there is 0 to pi by 2 here. So you can easily apply here. Sin raised to m theta into cos raised to n theta d theta is equal to bracket. There are two powers, m and n. They can be even or odd, whatever. Now, this is equal to bracket m minus all odds, m minus 1, m minus 3, so on, into bracket m minus 1, m minus 3, m minus 5, so on, into bracket n minus all odds, n minus 1, n minus 3, so on, upon m plus n minus all evens. Add the powers minus all evens. What are evens? M plus n minus 0, then m plus n minus 2, m plus n minus 4, so on, into a factor k. K is equal to 1 if k is equal to 1 if m or n is odd and k will be equal to pi by 2 is m and n both are even. Okay, so substitute here, see what we get. We get this as 2 minus 1, yeah, 2 minus 1, again 2 minus 3, if it's negative or 0, stop it there only, okay, then stop, 2 minus 3, negative, stop. The next for n is 2, again 2 minus 1 upon 2 plus 2, 4 into 4 minus 2 into, both are even, so it will be how much? Pi by 2. Okay, so if we simplify this, the final answer comes around pi by 16. That's all. So this is the answer. So the answer for this question is pi by 16. That's it. Now the next problem here is evaluate by changing to polar coordinates. There are two questions like this. One may be asked. You can practice it. The first question here is evaluate. I saw it here. Evaluate double integral minus a to a 0 to root of a square minus x square root of x square plus y square dx into dy, changing to polar. A very simple question if you can understand it. Okay, so let me solve it here. So now see first, you see the problem here. This is x is there, so this will be y is equal to and y is equal to, and this will be x is equal to x is equal to, right? And you see the inside equation minus a to a, then inside is what? Y is equal to root of a square minus x square. A Cartesian equation, if you square it, we get y square is equal to a square minus x square, or x square plus y square is equal to a square. This is circle with radius a. Okay, that means if I draw the diagram like this here, this is x and this is y. Okay, and x and y for circle. So now first I'll write x and y. Next, the circle will be like this. Okay, that means if I take this polar for the circle, now I am changing to polar now. To change to polar, the simple concept is what? Remember, see, even if you write this small things, so you will get marks. Getting it? If you write nothing, you write simple, some waste something, then no one is going to give marks. Write what is required. See, for changing to polar, the concept here is always write x is equal to r sin r cos theta, y is always r sin theta always. It means x square plus y square will be r square, and dx into dy while changing to polar will be r dr into d theta. Fine. Now minus a to a, so this is what? A comma 0, and this also minus a comma 0. Correct. See, now the area is between this to this point. That means from here to here, whole region. When I change to polar, Cartesian is x and y. Polar is radius and angle theta. So outside is a constant, that is what? Theta is equal to where to where? 0 to, this is pi by 2 and this is pi. See, the whole region is covered. Simple understanding, simple logic here. Circle minus a to a. If they are given, say, in case from 0 to a, then only have the circle from 0 to pi by 2. But here minus a to a means 0 to pi. Getting clear? If say one more time, if they give say 0 to a, this minus is not 0 to a. That means this is 0 to 0, 0 comma 0. Only quadrant. So what is the angle? 0 to pi by 2. But here, since minus a to a, from here to here semicircle, theta is 0 to pi, and radius is what? This is what? Radius is equal to a, given already. X square plus y square is equal to a square. So this is circle, x square plus y square is equal to a square. So radius is what? A. That's all. Okay. So r is equal to 0 to a. Such a simple problem. And inside, change everything to r and theta. So what is that? Root x square y square is what? Root of r square into r into. Why? Because dx into dy is what? R dr d theta. Dr. Don't miss that. So now again, let's simplify this. We have theta is equal to 0 to pi and r is equal to 0 to a. R into r square dr d theta. So first tell me, inside limit is r. That means we are going to integrate respect to r. So theta is equal to 0 to pi. Integration r square is r cube by 3, because simple integration x is to n is x is to n plus 1 by n plus 1. So integration x square x cube by 3, r square is r cube by 2 plus 1 3. So r cube by 3. And when I remove this limit, when I integrate, this limit goes, and what remains? 0 to a into d theta. Fine. So now I'll take 1 by 3 outside, that is equal to theta is equal to 0 to pi. In place of r put a minus 0, so it is a cube into d theta. Again a cube by 3 outside. Integration of theta is equal to 0 to pi d theta. And as you know, integration of 1 dx is x with respect to theta. Integration of 1 d theta is theta. So a cube by 3 into theta, and the limit from 0 to pi. So the final solution is nothing but pi a cube by 3. That's all. Beautiful. That's the solution. Okay, I hope you clearly understood this. Very simple question. So if they ask question like this, please do attempt it. Don't miss it. You already seen solution is so simple, because you're grown up now. These things will easily enter your brain, but take the courage to go through it and practice it. Next is evaluate 0 to infinity. Again, inside limit 0 to infinity e raised to minus x square plus y square dx dy by changing to polar. Very simple question. I already solved it, and I suspect the question they might ask this time in the exam. So please do practice it. I am telling it between the questions, so please mark this question again while during the last, while concluding the video. Once again, I will brief you some questions that you should do and go from all these questions. Please stay till the end. And also, as I told, I will be publishing a week before examination the set of model question papers that you need to practice. That is going to 100% help you to pass the examination. That will do it later. So please stay updated on my YouTube channel, my Facebook page, and my Instagram page. Next is, so for this question, the link is given description. Please go refer the link. Refer the description. Every question is given along with the links. Okay. Now moving on to the last question. That is okay. I hope you'll solve the changing to polar problems on yourself. Now the next problem is find a volume of solid bounded by the planes x is equal to 0, y is equal to 0, z is equal to 0, and x plus y plus z is equal to 1. A very high probability question on application of integrals. It looks like volume and all these coordinates some difficult, but it's very easy, believe me. So let's solve this question. I'll show you how to solve it here. So please pay close attention and practice along with me. Okay. So be honest. Are you practicing or watching? So please practice it. Fine. Now the problem here is find volume of solid bounded by the planes x is equal to 0, y is equal to 0, z is equal to 0, and x plus y plus z is equal to 1. Okay, very interesting and important problem from application of triple integration. A very easy problem. Let's see how I solve it. Now in triple integration, see x plus y plus z is a Cartesian curve basically, and the basic logic is what? if I draw the, I'll just show you here briefly. See, if I have, you know, the x-axis, the y and the z-axis here, and x and y. So basically, you know, if we know that in the 2D equation form, so I'll just, you know, leave the axis here. Okay, let's make it simple. So if I, in the basic 2D form, this is simply intercept form, that is x plus y, or x by a plus y by b is equal to 1. Correct. Now this is the 3D form, that is x plus y is equal to 1. Here see, a and b is 1 here, because intercept form is x by a plus y by b is equal to 1. So here, if I take 2D form, x plus y is equal to 1 means x by 1 plus y by 1 is equal to 1, or x plus y is equal to 1. The 3D form will be like this. That's all. This is a 3D form. Okay, that is x plus y plus z is equal to 1. That's it. That means when I talk about the triple integration here, see, volume is given as triple integration of dx, dy, dz. That means you simply find the limits here, and it's so easy. So volume is equal to triple integration of, see, x is equal to 0 to, so when I, you know, as I discussed here, I can write this x plus y plus z plus as x plus y plus z is equal to 1 as x by 1 plus y by 1 plus z by 1. It's simple intercept form. Okay, tetrahedron. Now x is 0 to where? 1, because outside is the size constant, inside is a 2D equation. 2D is what? This intercept form. X plus y plus z, 2D is what? Intercept form. Okay, so if I take this as, say, x plus y plus z is equal to 1, then here it's 1D, this is 1D, and this whole is 2D, x plus y. X plus y is what? 2D. So 2D is x plus y is equal to 1, leave z, because outside is a constant, inside is 2D. So x plus y, that is y is equal to what? 0 to x plus y is 1, x plus y is equal to 1. So what is y is equal to? 1 minus x. That's it. So y is equal to what? 1 minus x. Single D, 2D, now 3D, z is 3D. So z is equal to, this is how to write the limits. What is that 3D? 3D means all. This whole thing 3D. 3D means what? X plus y plus z is equal to 1. So z is equal to 1 minus x minus y. That's it, as simple as that. So we have here z is equal to 1 minus x minus y dx dy dz. So first we need to integrate respect towards z. There is as you know, there is no z term here, integration 1 is z. So this outside to integral will be as it is, x is equal to 0 to 1, y is equal to 0 to x, integration 1 dz is z, and the limit from 0 to 1 minus x minus y dy dz. Am I right? dy, yeah, dy dx or dxt, whatever. So this will be again now, z is gone. Now in place z put the limits. So x is equal to 0 to, x is equal to 1, y is equal to 0 to 1 minus x, 1 minus x minus y into dy dx. Now we need to integrate respect to what? Inside is y. Write clearly, yeah, y. So that again now, x is equal to 0 to, x is equal to 1. Integrate respect to y. Integration of 1 dy is y minus x as it is. Again integration of 1 is y minus integration of y is y square by 2. Simple, 0 to 1 minus x dx. Now again this will be x is equal to 0 to 1. Now in place of y put 1 minus x minus 0. So it will be 1 minus x minus x into 1 minus x minus 1 minus x the whole square by 2 dx. So better let's simplify this. Okay, so when I simplify this now, this will be 0 to 1, x is equal to 1 minus x minus x plus x square minus 1 by 2 into 1 plus x square minus 2x dx. Fine. This will be again now 0 to 1, 1 minus 2x plus x square. Am I right? Just check it once again. 1 minus x minus plus x square minus 1 by 2. Okay, as it is. This will be minus 1 by 2 minus x square by 2 plus x. Okay, into dx. So one more time, let's simplify this, or if you don't, it's okay, you can do directly also. So if you simplify this, this will be integral 0 to 1, x is equal to, now see carefully here, 1 minus 1 by 2 is 1 by 2, correct, and minus 2x plus x is minus x and plus x square by 2, am I right? 2x square minus x square by 2 dx. So let's finally integrate with respect to x here. As you know, we are integrating with respect to x here, so 1 by 2 as it is, integration of 1 is x minus integration x is x square by 2 and integration x square is what? X cube by 3 2s are 6. 0 to 1. So the LCM is 6 here, I'll take the LCM 6. 0 to 1. This will be 3x minus, as LCM is 6 here, 3x square plus x cube. Okay, now let's put the value in place. X put 1, so 3 minus 3 0 and 1, so answer is volume is equal to 1 by 6. That's all. This is how you get it, simple. Okay, so very high probability question, but please practice it 2 to 3 times. So if you practice some 2-3 times, you will definitely get the answer, no doubt. Still there is time for you to practice. Fill in how many notebooks you can, empty how many refills you can, how many pens you can, but please practice. Okay, so this only 1 or 2 papers cannot hold your engineering back, so you have to do engineering once you join it. So please listen what I say, please practice it. Okay, see, I have nothing to do with it. See, I am, as you know, I am going through cancer treatment. Still I am having pain. It's, I think it's night now 3:15. I am doing this because full morning I was sleeping, I was having pain, I was taking medicine, sleeping. I am here only for you because I am getting so many calls, you know, from parents, and I don't think 18 scheme many people are not taking the classes here. Even if they're taking classes, they're charging high amount of fees like 25,000-30,000. So students of VTU, they're not able to, you know, afford that much. So for you students, I am here. So please, for my sake, please do the thing what I am telling you, practice everything well, and I am guarantee you that you will definitely clear the paper. Okay, so now let's move on to the next problem. See, the next problem is, you know, I don't know how many times they ask these problems in the VTU examinations, whatever scheme it is, and I guarantee you, and if you have left this module, I am telling you, if you left this module like this only, not solid, and when you see me solve here, you will find it so easy that you will just, you know, think, why I haven't done this question. It's so easy, and 100% 7 marks guaranteed. Okay, very high probability question. They keep on asking the examination whatever it is, fine, and they repeatedly keep on asking this. So this time also there is 90% chance this may come. Okay, so see how I am solving it. Okay, now question is evaluate 0 to pi by 2 d theta by root of sine theta into 0 to pi by 2, that is theta is equal to 0 to pi by 2, theta is equal to root of sine theta d theta, or they may sometimes show that this is equal to pi. Okay, or they might ask or show that is equal to pi. 7 marks question, a very simple one. Okay, if you practice 2 times, done. Now see, in beta gamma function is not only about integration and all those things, there are some simple things also here, formulas. So there is a very simple formula in beta gamma function. The formula is, you know, 0 to pi by 2, theta is equal to 0 to pi by 2. sine raised to p theta into cos raised to q theta d theta is equal to half beta. This symbol is called beta. You all know beta. P plus 1 by 2 comma q plus 1 by 2. Very important relations. On this they ask many questions. Okay, I'll underline this. This is a relation you need to memorize. Using this relation, it solves this. That means you have to write in terms of this. Find p and q, put here and get the answer. That's all. Okay, so let's see how to do it. So now we have, first see, 0 to pi by 2, I can write d theta by root of sine theta. I can write it as 0 to pi by 2. What is roots? 1 by root. Root means sine raised to 1 by 2. So 1 by root means sine raised to, when the root goes top, it becomes sine raised to minus 1 by 2 theta. Correct now? But I need only cos also. So there is no cos. So I simply write cos raised to 0 theta because cos 0 is 1. Done. Into 0 to pi by 2 root of sine theta d theta is nothing but, again write in this form, 0 to pi by 2, again root sign is up, so it will be sine raised to 1 by 2 into cos raised to 0 theta d theta. If you see here clearly, see this PQ, P, Q, P, Q. Here P is equal to minus 1 by 2, Q is equal to 0, P is equal to plus 1 by 2, Q is equal to 0. So simple. I am not doing integration anything here, just putting the formula, matching the formula and finding P and Q and putting it here. Therefore that implies I know that half beta, see, P in first case, what's that? So I write it here better, okay, because I don't want to confuse you. So right here, so it is half beta, what's the formula? P plus 1 by 2 minus 1 by 2 plus 1 by 2 comma 0 plus 1 by 2 into, again for this, half beta 1 by 2 plus 1 by 2 comma 0 plus 1 by 2. That's it. So this will be now 1 by 4, 1 by 2, 1 by 2, 1 by 4, beta of 2 1s are 2, 1 by 4 comma 1 by 2, 1 by 4 comma 1 by 2 into beta of 2 1s are 2, 3, 3 by 4 comma 1 by 2. Am I right? Okay. Now see, there is one more very standard formula for beta gamma. It says beta m comma n, right, so right, beta m comma n is equal to gamma m into gamma n whole divided by gamma of m plus n. The symbol is gamma. Okay, underline it. This is the formula for beta gamma function. Okay, now using this formula, see, 1 by 4, what is it? This is m, n, getting it? Gamma 1 by 4 into, see, mn, gamma 1 by 4 into gamma 1 by 2 upon gamma 1 by 4 plus 1 by 2 into, again, gamma 3 by 4 into gamma 1 by 2 upon gamma 3 by 4 plus 1 by 2. Getting it? Very simple thing. This is mn. See, gamma n, 3 by 4 gamma into gamma n upon gamma, this thing. Now see, one more thing what happens, this will be 1 by 4. Gamma 1 by 4 keep as it is, don't touch it. Now, in beta gamma function, always very important thing, see, one is this and one more is, remember, gamma 1 by 2 is always root pi. Very important. What is gamma 1 by 2? Gamma 1 by 2 is always what? Root pi. Always gamma 1 by 2 is root pi. So we have 1 by 4 into root pi into gamma 3 by 4 into root pi whole divided by, this will be 2 to the 4, gamma 3 by 4 into gamma 2 to the 5 by 4. Correct? So this and this cancels. So what remains? 1 by 4 into pi into gamma 1 by 4 small atom as it is upon. See, this is one more formula, right? If n is positive, I write here, gamma n is written as, see, if n is positive, gamma, I write here, if n is positive, then gamma n is nothing but n minus 1 into gamma. One more this simple formula. If n is positive, then gamma n is what? N minus 1, gamma n minus 1. So if we apply the formula here, this formula required. So now apply the formulas here now. All numbers, okay. What is gamma 5 by 4? So gamma 5 by 4 will be equal to 5 by 4 minus 1 into gamma 5 by 4 minus 1. So what is that? 1 by 4 into gamma 1 by 4. Getting it? So it will be upon gamma 1 by 4 into, sorry, 1 by 4 into gamma 1 by 4. 1 by 4 into gamma 1 by 4. So this cancel, answer is pi. Therefore, there is nothing but equal to what? Pi. That's it. That's what they are asking to show it. Simple, right? So what is there in that? A very, very simple question with a simple to more simple solution. Anyone can do it. Nothing, just use this relation, memorize it. It's very simple. 0 to pi by 2, sin p into cos q theta is equal to half beta p percent by 2 comma q percent by 2. Arrange this given thing in p and q, find p and q from here, put here, you get this much. Then use the formula, very simple, from beta m comma n is equal to gamma n into gamma n by gamma m plus 1, where gamma n by 2 is root pi, put here, and use these relations, find a value. And they are going to definitely, they are not going to change anything. They'll ask their 150, 190%, they'll ask same question. No change in that. That's it. So please, my request is practice it 2-3 times, you'll 100% get it. Don't say easy and all, and don't just watch the question and practice, just write one time. It will not happen. Again in examination you'll say I forgot it. When you practice, you will never forget. That's what the higher scorers do. Okay, please do practice it. Fine. Okay, now there is one more similar question, that is evaluate 0 to pi by 2 root of cot theta d theta. See this, I want you to practice yourselves. Nothing, simply take this as cot as what? Cos by sine, root, and you find p and q and put the solution. That is cos, root cos by root sine will be cos raised to 1 by 2 into sine raised to minus 1 by 2. P is 1 by 2, q is minus 1 by 2. The solution is given. Please verify your answers. I want you to try this. Okay, now leave this. The very important thing is there are 2 derivations which they compulsory ask in each and every paper. So this is sure shot, 7 marks in your hands. But I have seen students, apart from telling them this question is important, they still they get they saw it and tell I had done it, but in examination correcting they'll get only 2-3 marks. Why? Because simply they write whatever comes in their mind. See, this is not a way of writing a paper. The examiner will have blueprint, so what if the solution matches the blueprint, then only you'll get marks, otherwise no. So this derivation is very important. I am telling you, if this comes, you shouldn't lose even a single marks, promise me. For that you have to practice it 2-3 times. I thought that I will let it to you to see from textbook, but I want to give a simple derivation. Please practice this derivation, and I'm sure if you practice 2-3 times, you will clearly get how to solve it. Okay. Beta m comma n is equal to gamma m, this is symbol for gamma, into gamma n upon gamma m plus n. Very important derivation from beta gamma functions. Repeat questions in examinations. So let's solve it in a simplest way as possible. Please pay close attention and better practice along with me. Okay, so that you should not lose even a single marks here. Fine. Now, see, first how to start. See, there are formulas for beta and gamma. We need beta m comma n. The formula for beta m comma n is 0 to pi by 2 integral 0 to theta is equal to 0 to pi by 2 sine raised to 2m minus 1 theta into cos raised to 2n minus 1 theta d theta. Then we need gamma m and gamma n. Okay, I'll take gamma m as equal to, there are two formulas, I'll use a simple formula here. So the gamma n is equal to 0 to infinity e raised to minus x square into x raised to 2m minus 1 dx. Similarly, what I'll do, I'll take gamma n is equal to, so I have taken this as x, I'll take this as y. 0 to infinity e raised to minus y square, y raised to, I have taken m, I have taken n here, 2n minus 1 dy. Fine. Now, what I need, gamma m into n by gamma m plus 1. So what I'll do, first I'll find gamma m plus n. So here based upon this, gamma m plus n is equal to, gamma m plus n will be equal to, so see if I add this now, 2 to they remain the same, 2 0 to infinity e raised to, see I can write directly here, e raised to minus of x square by s square is always r square, I'll show you that. So minus r square into, this will be r raised to 2 into m plus n 2m plus 1 minus 1 into dr. Okay. Now what we need here, we need gamma m into gamma n. See, we found gamma n plus n, we need gamma m into gamma n. So multiply this and this. It means that implies gamma m into gamma n is equal to, so when I multiply this, this becomes 2 to the 4, 0 to, so when I multiply both integrals will be 0 to infinity and this also what? 0 to infinity. Correct. And this will become e raised to minus, so when I multiply it, this will be e raised to minus c. This and this, correct? E raised to minus of x square plus y square, correct? No, e raised to, because e raised to a into e raised to b is e raised to a plus b, e raised to e into e, 2 to the 4, double integral x square y square, and this is x raised to 2m minus 1 into y raised to 2n minus 1 dx dy. Now I can better solve this using polar coordinates. Why? Because we have beta m common in polar. So for converting to polar, always x is equal to r cos theta and y is equal to r sin theta. Then dx into dy will be r dr d theta, and also x square plus y square will be what? R square. Why? Because x square is plus y square is r square, cos square theta plus r square sin square theta is nothing but r square into 1. That's why. Okay, so we have this now. Therefore, we can write gamma m into n is equal to gamma m. Therefore, gamma m into gamma n is equal to, this will be now 4 double integration. See, when I change the, for this was obviously x is equal to y is equal to, so when I change to polar, the x and y will change to r and theta. So this will be theta is equal to, and this will be r is equal to, correct? Now r and theta. So that means theta will be from what? See, x square plus x circle, it will be 0 to pi by 2. Always 0 to pi by 2, and r is equal to 0 to where? Infinity only. Fine, as it is. Therefore, now what you can do is, this becomes e raised to minus r square, because x square plus x is r square. What is x? R cos theta raised to 2m minus 1 into y is r sin theta raised to 2n minus 1 into, see, dx into dy is what? R dr d theta. I hope it's clear. Now let's solve this. This will be equal to now 4 theta is equal to 0 to pi by 2, r is equal to 0 to infinity, e raised to minus r square into r raised to, it is, see, let's open a bracket, 2m minus 1 into cos raised to 2m minus 1 theta, r raised to 2n minus 1 to cos raised to 2n minus 1 theta into r into dr into d theta. That's it. Now this will be 4, again simplified, theta is equal to 0 to pi by 2, r is equal to 0 to infinity, e raised to minus r square as it is. Now this will be, now see, r raised to 2m minus 1 plus 2n minus 1 plus 1. Because see, R, there is one more R is to 1, don't forget it. So this one cancels here, into cos raised to 2m minus 1 theta into sin raised to 2n minus 1, so this is sin that here, yeah, sin raised to 2n minus 1 theta dr d theta. This is what I have now. So this will be now again 4 theta is equal to 0 to pi by 2, r is equal to 0 to infinity, e raised to minus, you can write directly also, but I am solving it for you. This will be r raised to 2m plus 2n minus 1, correct, into cos raised to 2m minus 1 theta into sin raised to 2n minus 1 theta dr d theta. Now what I'll do, I will separate both the r and theta's components. That implies I can write gamma m into gamma n is equal to, so 4 twice now, so I'll separate as it is. So 2 times first theta then r. Theta is equal to 0 to, or I'll take r first. How you take? I'll take r first, okay. R is equal to 0 to infinity. What are the r terms here? E raised to minus r square, r is to, this will be 2 into m plus n minus 1 into dr, into again bracket 2 into theta is equal to 0 to pi by 2 minus theta. What are theta terms? Cos raised to 2m minus 1 theta into sin raised to 2n minus 1 theta d theta. The same. Therefore, that implies gamma m into gamma n equals, what is 2 0 to infinity e to minus r square r is to 2m plus n minus 1? It's nothing but, it's gamma m plus 1, correct, here. So gamma m plus n, and what is 2 0 to pi by 2 cos to m minus 1 into sin to n minus 1? It's nothing but, it's beta m comma n, that is sin to m minus 1 into cos to n minus theta. See, it's same only, both are, okay. Even if I take this n, nothing matters, same only. This is nothing but beta m comma n, beta m comma n. Therefore from this, therefore that implies beta m comma n is equal to gamma m into gamma n upon gamma m plus n. That's the solution for this, and a beautiful derivation, a guaranteed question for 7 marks. So I think I explained it in the most simplest as possible, so that if you practice it, you will understand. Simply memorizing, you know what happens, you will write 2-3 steps and everything will forget here. For R you will write something, you will keep on writing, then who is going to give marks? They will not give marks, because the main thing is it should be correct and legible, okay. So they will see this step, they will see the gamma m plus n, they will see gamma m into n, this step and this step, full marks. Something is wrong, they find, they will not give marks, okay. So evaluators are experienced people, by seeing the pattern only they will come to know it's correct or wrong. So please practice 3 to 4 times so that this derivation become perfect and you don't lose even a single marks here, okay. So please practice it. Fine. Okay, see, there is one more derivation here. Show that gamma 1 by 2 is equal to root of pi. One more important derivation. They asked this 2-3 times, but the first one is beta m comma n, that is beta m comma, show that beta m comma n is equal to gamma m into gamma n upon gamma n plus n is very, very important. Please practice that. This also will do it. Okay. So see, we have one formula is beta m comma n is equal to 2 0 to infinity pi by 2 sin raised to 2m minus 1 or 2n minus 1 theta, whatever it is, because beta m comma n is nothing but equal to beta n comma n, both are same, into cos of 2n minus 1 theta d theta. Okay. Here what I'll do, put m is equal to n is equal to 1 by 2. That implies beta 1 by 2 comma 1 by 2 is equal to 2 0 to pi by 2 sin raised to 1 by 2 0, it becomes 0 theta into cos raised to 0 theta, cos sin raised to 0 theta into cos raised to 0 theta d theta. Obviously it's 1, correct? So this will be 2 0 to pi by 2 d theta. So if I evaluate it, so we get beta 1 by 2 comma 1 by 2 is equal to 2. Integration of 1 is theta 0 to pi by 2. It is 2 into pi by 2, that is pi. I'll take this as say number 1. Okay. Next I have one more relation. It is beta m comma n is equal to gamma m into gamma n upon gamma m plus n, which we have derived a while ago. So here also I'll put m is equal to 1 by 2 and n is equal to 1 by 2. It implies beta 1 by 2 comma 1 by 2 equals gamma 1 by 2 into gamma 1 by 2 upon gamma 1 by 2 plus 1 by 2. So that will be gamma 1 by 2 whole square, because gamma 1 by 2 plus 1 by 1, gamma 1 is 1 only, whole square. So 2. From 2 and 1 we can say that it implies now from 1 and 2 gamma 1 by 2 the whole square is equal to pi. That implies simply gamma 1 by 2 is equal to root of pi. That's it, a simple derivation which can be asked again for 7 marks. That's how it is done. Okay, so we are done with this module now. Again, don't leave this module simply because it is integration. At least do the beta gamma derivation and those problems they give, root of sine theta into whatever, root 0 to pi by 2, d theta by root sine theta into 0 to pi by 2, root sine theta d theta 0 to pi, that one, and this derivations. So instead of losing 20 marks, you can still get some 7 marks or at 7 or say 12 or some 14 marks somewhat. If you do whatever I given, so definitely the questions will be repeated from there. You can easily score around 14 to 20 marks if possible. It's your wish. So please practice it. So we'll move on to the next module, module 4. So module 4 is all about first order differential equations and applications. In module 1, the most important repeat question which students find very easy but still lose marks is Newton's law of cooling. 150% question. Okay, peace of mind, you can get the full marks. I'll solve some 2 questions here. The first question is, if air is maintained at 30 degrees Celsius and a metal ball cools from 100 degrees Celsius to 70 degrees Celsius in 15 minutes, find, just a second, sorry for it, find how long it will take for the metal ball to reach a temperature of 40 degrees Celsius. A very interesting problem. I already solved this problem, so please do refer the link given in description below. Okay, next one problem solve here for you using the calculator. Fine. The problem is a body in air at 80 degrees Celsius cools down to 60 degrees Celsius in 20 minutes. The temperature of air being, I'm writing short form, so full question you can find in the fresh model question. This important questions I made a PDF and shared it in the description. Please find it. Okay. the temperature of air being 40 degrees Celsius, what will be the temperature? What will be the temperature of body after 40 minutes? So the first thing is, the previous question also you can refer to that. Here they are asking how long it will take time, and here it is the what is final temperature after a given time. So both question one may be asked. They may change the values and give. So if you practice this both questions, that's more than enough. Okay. First question, do it. Okay, I guess the video is there. The link is given in description. Please do refer that. This also I'm solving it here. See. Now the major formula, very simple formula. My formula to find this is T is equal to T1 plus T2 plus T1 minus T2 into e raised to minus kt. Again, one more time say it. T is final temperature after cooling, right here. Final temperature after cooling. T2 is temperature of medium. T1 is initial temperature before cooling, and T is the time, and K is a constant. We will find K. Okay. So I'll solve this problem step by step. Now see, analyze the question. A body in air at 80 degrees Celsius cooled down to 60. That means initial temperature of body is what? T1 is equal to 80 degrees Celsius. Cools down to 60 T. After cooling, final temperature is 60 degrees Celsius. In 20 minutes, T is equal to 20 minutes. The temperature of air being, air is a medium, a body in air is a medium. Medium is T2. T2 is equal to what? Medium, that is, understand like this, 40 degrees Celsius. So we have data here, put it here. So we have 60 is equal to 40 plus 80 minus 40 into e raised to minus times 20. So let's solve this. 60 minus 40 is 20 is equal to 40 e raised to minus 20. Okay. That means e raised to minus, see the simplification, 20k is equal to 20 by 40, 1 by 2. I have to find k value. See how I am doing it once again. E raised to minus 20k is 1 by 2. That implies e raised to plus 20k will be 2 by 1. Correct. That means apply log on both sides. So if I apply log on both sides, log e raised to 20k is equal to log of 2 implies 20k. I am doing everything step by step. Log e equals log of 2 is actually is natural logarithm. You can write log or ln. Okay, both same. So log is 1. 20k is equal to log of 2. So k will be equal to log 2 by 20. So let's solve this using calculator. So remember, as the old semester students, I know you are using this FX 991 ES plus. So further also the module 5 matrices I will do with this calculator only. Stay tuned. Now see mode. As I told you, LOG log, there is no base given. So all logs are natural logs. So always press what? ln here. ln. Don't, because many people know they lose marks. They press log. It's not LOG log, it's natural log, ln. Unless until the base is given, then only take log. Log to the base 10 is LOG. But any LOG is always ln only. So we have ln of 2 divided by 20 is equal to 0.0346. So it is 0.0346. So k is equal to how much? 0.0346. So please underline it. You are going to get marks for it. Okay, so the value of k you need to underline. So let's underline it here. So I found k here as 0.0346. Okay, now therefore t after 40 minutes will be what? Nothing but after time t till 40 minutes is t is equal to, what is that? Put here as same 40 plus 80 minus 40 into e raised to, what is that? Minus kt. K is 0.0346 into what's time now? 40 minutes. For 40 minutes you have to find. That's all. So I am using this fx 919 s plus here. See how I do it. I do it from here again. So you found k as what? Log 2 by 20, correct? As I told you, use always ln. See, ln 2 divided by 20 is equal to, I got it 0.03465 somewhat. So to get an exact answer, what you do? Simply multiply by 40. See, into I'll do minus 40 is equal to. So again this stuff, what is that? Minus 1.38629, whatever is stored in the answer. So first always solve for this, then multiply. Okay, so this will be now 40 plus 40 into e raised to minus 0.0346 into 40, whatever. Okay, so first I have this in the answer. So what I'll do? See, shift e raised to answer is equal to into 40 is equal to 10. So this is 40 plus 10. So plus 40 is equal to 50. How much? 50. That's the solution. Therefore, t after 40 minutes is equal to 50 degree Celsius. That's the solution. That's all. I hope you understood this. So both the problems you practice, you can easily solve any problem where you changed. Okay, so please do practice it. Fine. Only once you practice, you will be becoming perfect. So I don't want you to lose a single marks here. Again, I'm telling you, please do practice both the questions. 100% you will get the marks, and it's very easy. Only understand how to use a calculator, and I have given a simulation. Please refer the video and the earlier video also. Both two if you refer now, that's more than enough. Okay, so that's all. So let's move to the second question now. There's one more question. See, a body in air at 25 degrees Celsius cools from 100 degrees 75 in 1 minute. Find the temperature of the body at end of 3 minutes. This also question now, same as this only. So I given it for you. So please practice it. Okay. This question you'll find in the important question PDF. Please practice the same question and verify the answers. Next one is problem on orthogonal trajectories. One more very important repeated questions. Find the orthogonal trajectories of the family of curves x square by s square plus y square b square is equal to 1 where lambda is parameter. A little lengthy question. I'll solve it for you here. Please sit, but it's very important. They keep on asking this question for Cartesian curve for orthogonal trajectories. So please check how I do it and practice along with me. If you practice 2-3 times, you'll be able to clear this question also. Okay, fine. In the orthogonal trajectories, I write in short form OT of x square by a square plus y square by b square plus lambda is equal to 1. This is the question, and here given lambda is parameter. That means you have to eliminate lambda. Correct? So as the theory of the orthogonal trajectory for Cartesian curve, we first differentiate to eliminate lambda and then replace dy by dx by minus dx by dy. So let's see how can I solve this question now. So we have the problem here. So let's take it as say x square by a square plus y square by b square plus lambda is equal to 1. So I'll take this as one side. Okay. Now let's differentiate this. So first thing is to differentiate to remove lambda if possible. 2x by a square plus differentiation of y square is I write 2y into y1 by b square plus lambda is equal to 0. Here y1 I take it as dy by dx. Simple. Fine. That implies here now that implies x by a square. So what's that? X by a square plus y into y1 by b square plus lambda is equal to 0. This is what we have. Fine. Okay, the lambda is not eliminated here. So what I do? Now what I do, I rewrite this as, say, x by a square is equal to, I take that side, minus y1 by b square plus lambda. I'll take this as, say, 2. Okay. And again, okay, what I'll do is the question, the given question here to find a solution. So from the question, it is 1. From the question, what I can write? See, I can write a square, see this, x square by a square minus 1. Correct? No? X square by a square, take 1, this side minus 1 equals minus y square by b square plus lambda. Fine. This is what I have here, x square. Or that again implies, take the LCM here, x square minus a square by a square is equal to minus y square by b square plus lambda. I take this as, say, number 3. So see, I did this, okay, I took the help of the question. Why I did this? Because if I divide this 2 by 3, so 2 divided by 3 implies, if you divide it, so what do I get? See, x by a square whole divided by x square minus a square by a square equals minus y1 by b square plus lambda. What is that? Minus y1 by b square plus lambda whole divided by minus y square by b square plus lambda. So here if you see clearly, a square cancels, and here I think y and y also cancels, and b square plus lambda also cancels. So that implies now, see, this cancels, what I get? X by x square minus a square equals to, minus minus also cancels, y1 by y. This is what I get. Am I right? So y also cancels, right? Yeah. Okay. Now the theory of orthogonal trajectories for Cartesian curves says that replace, or I can write this as I write it. 1 by y, I'll take y1 as now dy by dx. It will be easy to solve. Okay. The theory of the Cartesian curve, that is finding the OT for Cartesian curve, says replace dy by dx by minus dx by dy. Very important condition. So let's replace it here. So it implies we have x by x square minus a square equals 1 by y into minus dx by dy. This is what I have here. Now we need to solve this or integrate this. The solution is we need to separate the variables, x one side and y one side. So if you do that, see, it becomes, if you take this side, see, y dy, take this side. So this will lead to y dy, okay, equals to minus, I'll take this side. See, when minus goes this down, it becomes minus x square minus a square by x into dx. This is what I get now. So let's integrate this now. So the integration will be, the solution will be integration of y dy plus integration of x square minus a square by x dx is equal to c. That again implies right here. So let's separate this. Integration of y dy plus, see here, x square minus a square by x, like a plus b by c is a by c plus b by c. It will be x square by x will be x only. This will be x dx. And here minus a square by x minus a square by x dx is equal to, I'll take c. Okay. I think simple integration. So integration of y dy is y square by 2 plus x square by 2. So what is integration x? Integration x will be x square by 2. Fine. And a square as it is, minus a square. What is integration of 1 by x? Integration of 1 by x is log x. Log x is equal to c. So that's the solution. Again, I can rewrite the solution as c. 2 is common here. I'll take the solution, and that implies solution is x square plus y square minus take the LCM, 2a square log x, 2a square log x equals to 2c. See 2c, c, k, what its constant only. So I take it as simply c. That's all. So that's the solution. This problem is very, very important, as this has been asked many times in the VTU papers of previous semester also. So, but it needs a lot of practice to understand the question. But I request you to practice 3 to 4 times. This question may be asked in the examination. Okay. See, the next problem is, show that a family of curves y square is equal to 4a into x plus a is self-orthogonal. One more damn sure question for the examination. Either the previous question x square plus y square b square plus lambda, or this question out of this one will be asked in examination. Okay. This also I solve this for you. So please refer how I solve it, and then we solve the next question. Okay. Or show that the family of parabolas y square is equal to 4a into x plus a is self-orthogonal. Okay. Question from orthogonal trajectories of Cartesian curves. Okay, so what we do, first we differentiate to remove a. If you differentiate, we get 2y into y1, or divided by x, it is y1 is equal to, it's 4a, correct. So we are not able to eliminate a. So what I will do here is, what I will do simply first, say, I will write the question here, okay, best to solve this, okay. I write it here. So y square is equal to 4a into x plus a. Let me take this as 1. Fine. Now here, when I differentiate this, I get 2y into divided by x, that is y1 is equal to 4a, correct? Definition x is 1. But I am not able to eliminate a here. So what I will do here, that implies a is equal to 2y y1 divided by 4. That is y1 by 2. Fine. Now this value of a I will put in the question. So put a in 1. So y square is equal to 4 into y1 by 2 into x plus a, that is equal to 2y y1. Okay, oh sorry, again this will be what? Forgot here. So into 4 is y1 by 2 plus x plus y1 by 2, and that will be equal to 2y y1 into else if you take here, it will be y1 by 2, right? So x plus y1 by 2. Fine. Am I right? Okay. Now let's open the bracket. So y square is equal to 2x y1 plus 2 cancels, plus, so you multiply here, 2 cancels, it will be y square into y1 square. Fine. Now see, I can remove y from both sides. That implies y is equal to 2x y1 plus y into y1 square. This is what we have now. Okay. Now we can, to find the orthogonal trajectory for Cartesian curve, what is the condition, what is the process? We, after removing the constant a, or whatever constant given, we replace dy by dx by minus dx by dy. So right here, so replace dy, I'll take this as second, say, okay, this is second. So replace dy by dx by minus dx by dy. That means I taken y1 here, no? So here y1 is equal to dy by dx, right? Okay. That means, that implies y1 is equal to minus 1 by y1. Oh sorry, y1 is minus 1 by 1. So put it here now. That implies, so y is equal to 2x into minus 1 by y1, right? Plus y into minus 1 by y1 square is 1 by y1 square as it is. Okay, am I right? So y is equal to 2x into, in place of y input, minus 1 by 1, and we have y into y1 square. So this will be now again minus 2x by y1 plus y by y1 square, correct? Now let's take the LCM of it. So we have y is equal to minus 2x plus there is y1 square. Okay, 2x LCM is y1 square. Fine, LCM is y1 square. So this will be 2x y1 plus y. Okay. Now what you can do is, that implies y into y1 square is equal to minus 2x y1 plus y, and that implies y is equal to, what is y, tell me? Y is equal to, take it this side, so 2x y1 plus y into y1 square. That's it. Am I right? So y is equal to 2x y1 plus y into y1 square. Now I take this as say 3. Now see, we got a differential equation in 2s, y is equal to 2x y1 plus y1 square. For that, to find the orthogonal trajectories, we replace dy by dx with minus, by applying the process here, minus 1 by, or minus dx by dy, or minus 1 by y1. When we apply it, we get the same equation, see both. So both 2 and 3 are same. Therefore, we can write the parabola y square is equal to 4a into x plus a is self orthogonal. That's it. This is how it's done. I hope you clearly understood how to find the orthogonal trajectories for both Cartesian curves, the important questions. Next is the OT for polar curves. First one is find the OT for r is equal to a into, so in Cartesian curve what we do? We differentiate to remove the constant, and afterwards we replace dr by d theta by dx by dy by minus dy by dx by minus dx by dy. In polar, we again differentiate and again we replace dr by d theta by minus r square d theta by dr. That's all. Okay. So next is polar curves. Find the orthogonal trajectories for r is equal to a into 1 minus cos theta. I already solved this. Please refer the link in the description and practice it. Very important question. One more damn sure question. This they repeatedly ask in examination. This or the next one. Find the OT for r is to n is equal to a is to n cos and theta. This time also they can ask. I am telling you. High probability question. They can ask it, so practice it 3 to 4 times. This is OT for polar is a scoring area. They repeat the question many times. Okay. So I have solved it. Please find the link. And one more question. Find the OT for r is to n is equal to a is to n sin and theta. I haven't solved. So let me try it here. So find the OT for r is to n is equal to a is to n sin n theta. Let me try it. So for polar curve, we apply log on both sides first. Log r is to n is equal to log a is to n, as we had done in first module, same thing. So we write directly log r is to n is equal to log n log r is equal to n log a plus log sin n theta. Recall it. We have solved the previous first module polar curve problems like this. So differentiate n into 1 by r dr by d theta equal to 0 plus 1 by sin n theta, and derivative of sin n theta is cos n theta into n. So n cancels. So we have this. So we have it as 1 by r dr by d theta is equal to cot of n theta. Fine. Now in orthogonal trajectories of polar curves, what we do? Replace dr by d theta by minus r square d theta by dr. That is standard process. So 1 by r into minus r square d theta by dr is equal to cot of n theta. Okay. That means it implies minus r d theta by dr is equal to cot of n theta. Now what to do? We separate the theta and r and integrate. That's the solution. Fine. How you do it? So we get dr by r. See, dr r goes this side. We separate again. Dr r goes d theta minus become plus. I take r first, then theta as a standard form. Minus is there, so equal to, so minus plus. This will be cot of n theta. This will be d theta by, correct now. So dr r goes and d theta cot comes down. So simple, d theta by cot of n theta is equal to 0. So solution is integration of dr by r plus integration of tan n theta d theta is equal to say k. Okay. Now integration of 1 by r is log r plus. What is the integration of tan n theta? So this will be, see, integration of tan of theta is log secant theta. So integration tan n theta will be log of secant n theta. Again there is n here. So divided by differential n theta is upon n is equal to k. Okay. That means we can write n, we can, take this as, I can take this as n log of r. See, I can take LCM, n log of r plus log of secant n theta is equal to nk. I take this as log of c. Okay, nk is a constant. I'll take it as say log of c. Now again, n log r will be log of r is to n plus log of secant n theta is equal to log c. Now log a plus log b is log ab. So log of, that implies log of r is to n into secant n theta is equal to log c. So log cancels. That implies c is equal to r is to n secant n theta. See, I want in this form, right? So what I can do, this will be r is to n by cos of n theta. Am I right? Correct, no? So c is equal to r is to n by cos theta. Therefore, the orthogonal trajectories is r is to n is equal to c into cos of n theta. That's it, as it is. Okay, this is the answer. This is how we solve it. Fine, that's the orthogonal trajectories. So 3 problems are solved. One is orthogonal trajectories for a into 1 minus cos theta. Other is r is to n is a is to n cos theta, very high probability question. Another is this one. So please practice these 2-3 questions. One may be asked in the examination. That's all. Okay. Now let's move to the next problem on linear differential equations. See, I have this one problem from Bernoulli, that is linear differential, is Bernoulli differential equation, which have been frequently asked in examination. This time there is a high probability of asking this question. The question is solve dy by dx plus y tan x is equal to y square secant x. So it's a Bernoulli's differential equation. Why Bernoulli's? Because there is y square here. Y is to something. So what I do, simply divide by y square. See, simple. So we get 1 by y square dy by dx plus y square y is 1 by y tan of x is equal to secant x. Now the concept here is always this is differential of this. Always. Okay. So we put 1 by y is equal to t. That implies minus 1 by y square dy by dx is equal to dt by dx. Now I want to replace 1 by y square divided by dx by t. That implies 1 by y square dy by dx will be minus dt by dx. As simple as that. So whatever in place of 1 by y square divided by dx, put minus dt by dx. So it implies everything we try to make it linear to t and solve it. That's the solution. Okay. So minus dt by dx plus this is tan x into t is equal to secant x. So I'll try to make it linear. What is linear in y means? See, dy by dx plus pi is equal to q. So I'll take minus this side. That implies dt by dx plus minus tan x into t equals minus secant x. So this is what? Linear in t. Linear in t. See here, t. Okay, like for a linear in y, right here, linear in y, it is dy by dx plus py is equal to q. See, y dt. Solution is y into e raised to integration of p dy is equal to whole q into integration of p dy of dy plus c. That's the solution. So here, since it's linear in what? T, the solution will be t into e raised to integration of, see, this is p here. P is what? Tan x. This is p and this is q. Okay. So p is tan x q is minus tan x q is minus secant x. So e raised to minus tan x dx is equal to whole minus secant x into e raised to minus tan x dx of dx plus c. That's the solution. Now I will do it separately. E raised to integration of minus tan x dx will be e raised to minus log of secant x, because integration of tan x is log secant x. So that will be now e raised to I'll write log of secant raised to x raised to minus 1. Why I am taking? Because e raised to log of something is something. So what happens? This e and this log vanishes according to important result. E raised to log of something is something. E raised to log of x is x only. E raised to log of this thing is nothing but 1 by secant x. Secant x raised to minus 1 is 1 by secant x. So I'll put it here. That implies t. What is t here? T is what? 1 by y, write in y terms, x and y terms. E raised to minus integration of tan x is nothing but 1 by secant x, correct, is equal to minus secant x into again 1 by secant x dx plus c. Therefore secant cancel, integration 1 is x. So this will be now 1 by y into, see what is 1 by secant x? 1 by secant is nothing but cos x is equal to minus integration of secant by secant is 1, integration of 1 dx is x plus c. That's the answer. Or I can write, it implies the solution is cos x by y is equal to minus x plus c. That's the final solution. I hope you clearly understood this. It's a very easy question. Please practice it. Okay. So if you practice it, you will get the solution. Sometime now, instead of y square, they give y cube also. You can practice with that also. Okay, but this is a high probability question. Please don't miss it. They can ask in the examination. Please do it and go. There's one more problem here. Solve x square plus y square plus x dx plus xy dx. Xy dx is 0. I think this is reducible to exact form. So the solution I solved already. Please check the link in the description below and solve it. That's an easy question. See, there is one more problem here that is solvable for p. It says solve xy dy by dx the whole square minus bracket x square plus y square dy by dx plus xy is equal to 0. So here see dy by dx when solve for p, dy by dx nothing but p. So we rewrite this as xy p square minus x square plus y square into p plus xy is equal to 0. So obviously this will be the solution will be a quadratic equation form. Okay. So here p square is treated as x here. So I will write for you ax square plus bx plus c. Solution is x is equal to minus b plus or minus root of b square minus 4ac by 2a. So let's apply the solution here now. When I apply the solution, so we get x will be equal to minus b, so minus plus c, b is x square plus y square plus or minus root of x square plus y square the whole square, b square minus 4ac. So 4ac means it is 4x square y square, 4x square y square, correct, upon, am I right? 4ac means a is xy, c is xy, x square y square upon 2a, 2xy. That means x will be x square plus y square plus, see this will be, I will do it here, okay. X raised to 4 plus y raised to 4 plus 2x square y square minus 4x square y square divided by 2xy, and this will be x raised to 4 plus y raised to 4 minus 2x square y square, x minus x square minus y square the whole square. Getting it? See, plus 2x, this is x square will be this much. So 2x square y square minus 4x square y square is how much? Minus 2x square y square. So x raised to 4 plus y raised to 4 minus 2x square y square is nothing but x square minus y square the whole square. That is x square plus y square plus or minus x square minus y square upon 2xy. Correct now? Root of x square minus y square the whole square, root goes and this remains. We get this. Okay. This is we are solving for, p is equal to, correct? P is equal to. Okay, fine. Not x, p is equal to. Therefore, one value of p, that implies p is equal to x square plus y square plus x square minus y square by 2xy. Here y square cancels, this will be 2x square by 2 cancels, this will be x by y. 1p. Other p is x square plus y square. First I taken minus here, now I take plus here, now I take minus. So minus x square plus y square by 2xy cancels, 2x square y cancels, so 2 cancels, so y by x. So one is p is equal to x by y, other is p is equal to y by x. What is p? dy by dx is equal to x by y. dy by dx is equal to y by x. Now solution is integration. I take this term this side, so x dx minus y dy is equal to 0. Here also dx by x minus, separated, dx comes here, y comes here, is equal to dy by y. So minus dy by y, or this I write it. Okay, x dx is equal to y dy, and here dx by x will be equal to dy by y. So solution is integration of x dx minus y dy is equal to, I'll take this as k, say k, and here also integration of dx by x minus dy by y is equal to k. Okay, that's it. Now let's solve for this. So integration x is x square by 2 minus y square by 2 is equal to k, or x square minus y square is equal to 2k. I will take this as, say, c, because 2k is a constant, c is a constant, for simplification. Okay, so one solution is nothing but x square minus y square. So one solution is x square minus y square minus c is equal to 0, and the other solution will be 1 by x is log x minus log of y. I'll take it as k. Now I'll take it as log of c. That's it. Or log k, yeah, whatever. Okay, because k log c both are same constant. So what will happen here is log a minus b is log a by b. So log x by y is equal to log of c. Log and log cancels, so c is equal to x by y. Okay, or x minus yc is equal to 0 is one more solution. Fine. Therefore the solution for this is nothing but x square minus y square minus c into x minus yc is equal to 0. That's the solution. That's how it is done. That's it. I hope you clearly understood the solution. It's a very important question, so please don't miss it. They can ask the same problem in the examination, as this has been repeated many times. So solution is simple only, but you need to practice here. And integration also is very simple. There is nothing high-fi. So please practice it. Okay, because when you practice, you get confident, and confidence only happen when your pen moves always. Okay. See, there is one more problem like the previous one. Only difference here is everything is same. Only this is x minus 1. Okay. This also has been repeatedly asked question. We will solve this now. And here difference is x y p square plus x minus y into p. It is different question, minus x is equal to 0. So I can rewrite this as x. This is y. Okay, y. So I can rewrite this as what? Y p square plus x minus y into p minus x is equal to 0. Again, this will be like ax square bx plus c. So solution is x is equal to, or here p is equal to minus b minus x minus y plus or minus root of b square minus 4ac, so minus plus 4xy upon 2y. So this will be minus x minus y plus or minus root of, this will become x square plus y square minus 2xy plus 4xy 2y. So p is equal to minus of x minus y plus or minus, so write directly here. So x square y square plus 4xy minus 2xy to plus 2xy, so x plus y the whole square, so it will be x plus y. Simple, right? Upon 2y. So p is equal to minus x plus y plus x plus y upon 2y. Here x and x cancels, so this will be 1 by 2. Am I right? Y cancels, 2y, no, I think, yeah, 2y upon 2y. So yes, 1. So p is equal to 1. Simple. Next here, p is again equal to minus x plus y. Now it's minus. So minus x minus y divided by 2y. So here I think y cancels. So this will be minus x by y. So p is equal to minus x by y. Fine. What is p here? As I did earlier, dy by dx is equal to 1 and dy by dx will be equal to minus x by y. So dy by dx is 1 means y is equal to integration of 1 dx plus c. So y is equal to x plus c is one solution, or y minus x minus c is equal to 0 is the solution. And here if I cross multiply we get x dx plus y dy is equal to 0, or integration of x dx plus y dy, I'll take this as equal to say k. So integration x is again x square by 2 plus y square by 2 is equal to k. So x square plus y square is equal to 2k. I'll take this as c, because 2k is a constant, c is a constant. Make it simple, okay? Therefore we have x square plus y square minus c is equal to 0. So the solution for this will be y minus x minus c into x square plus y square minus c is equal to 0. That's the solution. That's all. It's easy only. Both the previous one and this one are important, so please practice it. It will be very helpful. Next is a very important repeated question from Clairaut's equation. Solve. This has been asked many times in examination. Listen. Solve px minus y into py plus x equal to 2p by reducing to Clairaut's form, taking the substitution capital X is equal to x square and y is equal to y square. Very important question. Okay, practice it 4 to 5 times, you'll get correct. So I solved it for you here. So please check how I solve it and please do practice it. Solve the equation that is px minus y into py plus x equals 2p by reducing to Clairaut's form, and you are using a substitutions here. U is equal to x square and v is equal to y square. Okay, so they again use x square, v is equal to y square. So what we do first, we have to write everything in terms of u and y and solve. Make it to Clairaut's form. Okay, so du by dx will be now 2x here and dv by dy will be 2y. Fine. So my small p is nothing but I have to write small p in terms of u and v. So small p is dy by dx. Now dy by dx as a chain rule in terms of u and v can be written as dy by dv into dv by du into du by dx. See, this term dv cancel and what will dv cancel, dy by dx reverse. But we get in form of u and v. That is nothing but again, see, what is dy by dv? See, dv by dy is 2y. That is 1 upon 2y. What I'll do, this dv by du, the factors for substitution, I will take this as capital P into this again 2x. That will be 2 cancels. We will get this as p into x by y. So therefore small p is equal to capital P into x by y, small x by small y. That implies small p is equal to capital P into what is x? U is equal to x square. Fine. So u is equal to x square means what is x? X is equal to root of u divided by y, root of v. See, I have got in terms of u and v now. So let's put this in place of small p. We'll put this here. Where are p is that put? So it implies now we can write p, right? P is capital P into root of u by root of v into x. See here, into x. Again, what is x? So I'll write here better. That implies x is equal to root of v and y is equal to root of v. Okay, better. Fine. So p into what is p? Capital P root u by root u by root v. X is root u minus y is root v into bracket again. P is root u by capital P root u by root v into y is root v plus root u, because x is root u, equals 2 into p into root u by root v. Now here take the LCM. See, u into u is u, so p into u minus, take the LCM, root v small v upon root v into, see this v and v cancels. See what remains? P root u plus root u. So root u is common here into capital P plus 1 is equal to 2p root u by root v. Again here compare both, is multiplied, so u v cancels. So we have capital P into u minus v into p plus 1 equals 2p. Fine. That implies now we can write p u minus v is equal to 2p by p plus 1. Fine. So again I can write this equation in v form as this, because v is basically y, uv. So v form as nothing but, we can rewrite this v form as pu, capital Pu minus 2p by p plus 1. Now this is all capital, okay, p capital. Now this is what? Clairaut's. This is Clairaut's. And the Clairaut's equation, general form is y is equal to px plus f of p. And the solution for Clairaut's is y is equal to cx plus f of c. That means when you identify it as Clairaut's, px plus f of p, function f of p, what we do is you simply replace in place of p put c. That's all. So here therefore this is Clairaut's. So this becomes Clairaut's equation now. This is Clairaut's. So once it is Clairaut's, so what we do? The solution is v is equal to pu p c. What solution? In place of p put c. So it will be what? I'll take capital Cu, c into u, okay, minus 2c by c plus 1. So I will write in the standard form, because here they are given v as y square and u as x square. So the solution here will be now for Clairaut's v. What is v? Y square is equal to c into x square minus 2c by c plus 1. That's the general solution for this question. Okay, a very important question, so please practice it 3 to 4 times so that you will be able to write in the examination. So very important. Okay, they may repeat the same question this time, as it has been repeated many times in the previous exam paper. Now the next question is solve dy by x plus y cos x plus sin y plus y upon sin x plus x cos y plus x is 0. I don't know, I just, it's not, I think it has asked only one time, so but it's easy question only. Solution I solve it, so please refer it. And one more question from Bernoulli. This also they might ask, because they haven't discussed it all these years. They might ask, as we solve one, right? Y square secant x, same on that line. Dy by dx plus y by x is equal to y square secant x. So please find a link in description below and please do solve it. So that's all for the module 4. module 3 and module 4 are like, you can score the marks, no problem. Module 4 also, if you are luck, if you get the Clairaut's method and if you get question like this and one Newton's law of cooling, you can easily score full 20 marks, or at least you can score at least 14 to 15 marks, no doubt. Okay, provided you follow what I say, exactly what I do and what I am doing. Please do that. Okay, this is a long video, so it's not that long because you have so much time left. You can simply give 3 hours of a time to this. Around, I don't know how much time to take. One more module is left. Around 3 or more hours of your time to this video, and practice the same for 2-3 times. Then obviously every day if you practice little, you will be easily able to clear it, no doubt. Okay, please. So now let's move on to the final and the last and the scoring module, which I'll do it seriously for you. I'll solve the problems. So please, you can stop here, go get a calculator which you're using. I think you're using the FX991 ES Plus. If you're using any older editions or FX991 EMS and all those things, don't use that, please. Because use only FX991 ES Plus or some other calculator. Okay, don't use the diploma calculators. I think it's FX old edition 991 MX, I don't know, or 85 something. Okay, don't use that. Only use FX991 ES or ES Plus second edition. So please get your pen, your papers and the calculator ready and sit tight. We are going to score full 20 marks in matrices from this video. Fine then. Okay, let's move on. Starting with the module 5, the most easiest module in Engineering Mathematics 1 for VTU 18MAT11, and there are many repeat questions which are asked. So this module I will solve it completely. So please pay close attention while I solve it, and I sincerely request you to follow me, take your pen, your notebook and practice along with me. Okay, because my methods are a little different from the other methods and they're easier. If you practice it, then you'll be able to solve within the limited constraint of time. Otherwise, please don't tell the paper was lengthy. Okay, I'll show you the most easiest to solve these problems. And remember, again, one more thing is that don't attempt matrices first. Okay, first try the first module, then second, then you can attempt third or fourth. You can go with matrices. And if you get full 20 marks in matrices, then easily 150% no one is going to stop you from clearing the 18MAT11, guaranteed. Okay, but you have to follow what I say and practice. That's very, very important. See, ranks looks easier here and there. So first topic, ranks looks easier here and there, subtracting and making 0, but it's not like that. You should follow a correct approach. So stop what you are doing now all these years. Follow my method, it will be easy for you. So the first question is find the rank of the matrix. Okay, the problem is find rank of A is equal to 2, 3, 2, 3, minus 1, minus 1, then 1, minus 1, minus 2, minus 4, 3, 1, 3, minus 2, and 6, 3, 0, minus 7. Fine. So one more thing, while taking down the problem from the question paper, please verify it twice. If you miss any numerical or any value, then obviously your whole efforts are going to waste. So 2, 3, minus 1, minus 1, 1, minus 1, minus 2, minus 4, 3, 1, 3, minus 2, and 6, 3, 0, 7. So what I'll do, first I'll write A is equal to here. So A is equal to 2, 3, minus 1, minus 1, 1, minus 1, minus 2, minus 4, 3, 1, 3, minus 2, 6, 3, 0, minus 7. So first thing what I'll do is, see the concept here is, if you have been following my videos, earlier videos, that I explained very simple way. So the main concept is here, this 2 is like a first husband, he has 3 wives. So all the 3 wives have to go to the first husband only. Similarly, go along the columns, first column first, second column second, third column third. That means first column first husband, 3 wives, second column this is minus 1 second husband, 2 wives, then third column 3, 1 wife. And last is a bachelor, first year engineering student. Okay, so he's got a back. Now, after you clear the back, you may get married. Okay, now making use of this 2, make all below 0. Simple concept. Make 6, 3 and 1, 0 making use of 2. How? See, 6, how to make 0 making use of 2? See, this done should be 0. Operation is done. Make 6, 0 making use of 2. So, this should be 6. So, simply multiply here by 3. See how I am writing it. When I go like this, no. So, 100% chances of getting the exact answer. You will not go wrong. Okay. See, 6 minus 6, no. So, multiply whole row by 3. 3 2s are 6, 3 3s are 9, 3 1s are 3, 3 1s are 3. So, what is the operation to make 6, 0? R1, R2, R3, R4. So, R4 minus 3, R1. And that will be equal to now 2, 3, minus 1 as it is. Because the concept is any row or column is multiplied with the same scalar, the matrix remains same. Then 1 goes step by step, minus 2, minus 4 as I do. 3, I hope you are practicing along with me. 3 minus 2 now. See, this minus this. I'll show it here too. See, this minus this. Then this minus this. Then this minus this. And this minus this. Be correct about the operations here. Okay, we are going to make this 6, 0. So obviously 6 minus 6, 0. 3 minus 9, minus 6. 3 minus 9, minus 6. 0 minus a minus plus 3. Then minus 7. See here, you are operating minus 7 minus of minus 3. So minus 7 plus 3 is how much? Minus 4. Be very careful here. Done. Now we need to make 3, 0 making use of again 2. So how can I make 3, 0 making use of 2? Again, I have to make this 3, 0 making use of this 2. First, because below this 2 I have to make all 0. This work done. First, the last wave. Second wave, 3. I have to make 3, 0 making use of 2. What is the LCM? 3 2s are 6. 6 minus 6, 0. So multiply this by 2 and multiply by what? 3. 2 3s are 6. 2 1s are 2. 2 3s are 6. 2 2 minus 2 minus 4. Be careful about the signs. 3 2s are 6. 3 3s are 9. Minus 3 and minus 3. Again, R3 minus 2R3 minus 3R1. Fine. So this will be again now 2, 3, minus 1 as it is. Then minus 1, minus 2, 1 sorry, it is minus 1, right? Okay. Minus 1, then minus 2, minus 4 also as it is. Now see, this one example, now I will show you everything detail. 6 minus 6, 2 minus 9, 6 minus 3, minus 4 minus 3. Okay, that means 6 minus 6, 0. 2 minus 9, minus 7. 6 minus here, 6 minus bracket minus 3, minus 3 minus plus. 6 plus 3 is 9. Minus 4 minus 1 plus 3 is minus 1. And 0 minus 6, 3 minus 4 as it is. Now again, we need to make this 1, 0 make use of 2. Again, 1 and 2. 2 minus 2, 0. So multiply whole row by 2. See, so it becomes 2 1s are 2, minus 2, minus 4, minus 8. So R2, R2, minus R1. Always the below row, okay, not the top row. Fine. So 2, 3, minus 1, minus 1. It's a discipline, it's a step. Row transformation or converting to echelon form is a discipline, is a step. Don't, because I see many people, you know, when they hear the term rank, they are excited. Rank means what? CR2, 0, 0, 3 minus 3, 0. No, this step. First, make this and this 0 making use of this. Then make this and this making 0 of this. Then make this 0 making this 0 making of this. It's a process followed. Okay. So now, see, that's what I'm doing. So this all triple is 0. Now I have to make 1, 0 making use of 2. So multiply 2. So now 2 minus 2, 0. See here. Minus 2 minus 3 is what? Minus 5. Correct. Minus 4 minus plus 1. Minus 4. Operation is, I write it here. So write, in one example, you will get everything here. See, this minus this, this minus this, this minus this, this minus this. Okay. Now, 2 minus 2, 0, minus 2 minus 3, minus 5, minus 4, minus 7 plus 1 is minus 3. Minus 8, minus 7 plus 1 is minus 7. 0, minus 7, 9, minus 1 as it is, 0, minus 6, 3, minus 4 as it is. Now, the first husband is full happy. Done. So, below all 3 wives will go to all 0. Now, the second husband here is what? minus 5, making second column second person, below it make all 0. Second one is 2's. So make minus 6 0 making use of minus 5. How can I make minus 6 0 making use of minus 5? Take the LCM, 6 for the 30, 30 minus 30, 0. So 5 6 are 30, 30, 15 minus 20. Again, this was 6, 6 0 0, 6 5 are 30, 6 3 are 18, 6 7 are 40. So minus 42. So the operation here, 5 R4 minus 6 R2. Am I right? That means this will be now again this equal to 2, 3, minus 1 as it is. So again this will be as it is, 0 minus 5 minus 3, see 0 minus 5 minus 3 minus 7, then 0 minus 7, 9 and minus 1, and lastly again here this minus this, this minus this, this minus this. Practice using this method, you will not miss any rank, 100% full marks. Okay, now minus 30 minus plus 30, 0 0, 15 minus of minus plus 18, be careful of the sign here, 15 operation is minus of 6 R2, so minus plus 18, 15 plus 18 is 33, then minus 20 minus of minus plus 42 is 22. That's it. Now next I need to make minus 7 0 making use of minus 5. Again when two odd numbers, simply take LCM. That's it. 7 5 are 35. So multiply by 5 here, multiply by 7 here. Okay. So 5 0 0, 5 7 are 35, 5 9 are 45, 5 1 are 5. And here 7 5 are 35, 7 3 are 21, 7 7 are 49. Okay. So the operation is 5 R3 minus 7 R2. So this will be equal to, now see one more thing you can do here is, try to scan your eyes properly on the problem. Try to make things smaller. It is in the row transformation there's a property. If any whole row is divisible by same number, divide it, make it smaller. See here you see 33 22, I can divide this whole by 11, make it here divide by 11. So 11 3 is 11 2 is. So this will be again 2 3 minus 1 minus 1, 0 minus 5 minus 3 minus 7 as it is, 0 again minus 35 minus or minus plus 35, 0. That's what we need here. We need to make this, making the minus 5 makes 7 0. Okay. Lastly 45 minus plus 21 is what? 66. Again minus 5 minus or minus plus 49 is what? 44. Again 0 0. This is 11 3s are 11 2s are. Okay, done. Now again I can make this, see 66 44, 11 6 are 11 4s are. Okay, again I can rewrite this as is equal to now 2 3 minus 1 minus 1, 0 5 minus 3 minus 7, 0 0. See here, I'll do here it. 11 6 are 11 4s are. Again 2 3s are 2 2s are 4, 3 2. This is what I get. So this becomes now, or what I can simply do is I can divide this by 22 best. Correct? No? So what I'll do, I write it divide by 22. That makes sense. Correct. Okay. 66 and 44. Okay, divide by 22. So this becomes 3 2 0 0 3 2. Done. Now see below 2 all avoid 0 3 0. Below 5, second column second person is 5 0. Now below this 3 I have to make this 0. When I go to make that 0, I can see 3 and 3 both are same. So R4 minus R3. So operation is R4 minus R3. So that will imply A is equal to nothing but 2 3 minus 1, 0 5 minus 3 minus 7, 0 0 3 2, 0 0 0 0, because 0 minus 0 0, 3 minus 3 0, 2 minus 2 0 0. So the whole row here has become 0. So total number of rows is 4, full row 0. The meaning of rank is highest number of non-zero rows. Therefore you can write that implies right here, that implies rank of A, row of A equals what? 3. That's the answer. Finished. That's what you get. Okay? Done. 7 marks. 67 marks, whatever. Guaranteed in a hand. Practice what I do. You can practice same problems. No need to go for other problems. The second problem is find a rank of 0, 1, minus 3, minus 1, 1, 0, 1, 1, 3, 1, 0, 2, 1, 1, minus 2, 0. This problem I have already solved it. Please go refer the video. The link you can find in description. As I tell you, for all the modules I have given the questions and the link in the description below. Please do refer that. Okay, if you are serious. Otherwise, again you can leave now. Fine. Now, next one is again one more problem. Find the rank of. This also they are frequently asked the question. So find rank of A is equal to. So this is 1, 2, 3, 0, 2, 4, 3, 2, 3, 2, 1, 3, 6, 8, 7, 5. So if you are practicing along with me, again with this problem along with me, then 100% need not again practice for the finals. Just glance it and go. It will be retained because my words are designed to enter your brains. That's what I do. Things make simple. Make things simpler. Okay. Now we have the problem here. 1, 2, 3, 0, 2, 4, 3, 2, 3, 2, 1, 3 and 6, 7, 5. I rewrite it. So A is equal to 1, 2, 3, 0, 2, 4, 3, 2, 3, 2, 1, 3, 6, 8, 7, 5. Again, 4 rows. Tell me what? First person, first husband, 3 wives. I have to make all this below 2, 3, 6, 0 making use of 1. 6 and 6. What I do? Simply multiply by 6. 1 6 are 6, 2 6 are 12, 6 3 are 18 and 0. So this will be now R4 minus 6 R1 and that is equal to nothing but 1 2 3 0 2 4 3 2 3 2 1 3 6 minus 6 0. As you understood here, I will not do it again. 6 minus 6 0. 8 minus 12 minus 4. Be careful in a calculation, otherwise use calculator. Don't take any risks because the more you try to go, do it mentally, you become mental and you are not mental. Okay. Now 8 minus 12 minus 4, 7 minus 18 minus 11, 5 minus 0, 5. Done. Next, make 3 0, making use of 1 again. So multiply by what? I can multiply by here 2 because 3 right? Okay, 3. Fine. So now multiply by 3, it is 3 1s are 3, 3 2s are 6, 3 3s are 9, 0s are. Correct. So it will be R3 minus 3 R1. See, one more thing I want to tell, because in colleges and some textbook authors they say try to make the finding rank, try making the first element 1. See, in each and every problem is not possible because the question may be different. So here it was, I forgot it. So 2 1, I would have taken 1 here and done it. It will become little easier, but it doesn't make any change here. Okay, here it is C1. So I am simply multiplying by 6, 3 and 2 like that. But that doesn't matter. Okay, you will get the same answer. Fine. Now, here is already 1. Here it is 2 1. So if I take one top and do it, it will be same answer. The answer will not change at all. But little bit what will happen is if I take 1 here, no 2 here. So everything I have to multiply by 2, 3, 6, 1. Now, again, I don't think there is that much change here. Okay, same one. Fine. So now don't worry about that. Now here see, I have to make 3 0 making use of 1. So multiply by 3 whole thing. So this will be now again that is equal to 1 2 3. So what you can do is again, this is solid. Take 1 the row, because row transformation there is a rule. You can shift the rows. You can shift this row up, take this row down. That is, make first 1 as here first and try doing it. See the answer. Please do it. Okay, don't leave it. So this is again 2 4 3 2. 3 minus 3 0. 2 minus 6 minus 4. 1 minus 9 minus 8. correct? 3 minus 0, 3, 0 minus 4 minus 11 and 5 as it is. Am I done? Correct? Perfect. So, 2, okay, next. I have to make 2 0 making use of this one. So, directly multiply by 2. So, 2 1s are 2, 2 2s are 4, 2 3s are 6, 0. So, R2 minus 2 R1, and that will be equal to 1 2 3 0 as it is. 2 minus 2 0, 4 minus 4 0, 3 minus 6 minus 3 and 2, and this will be as 0 minus 4 minus 8 3, 0 minus 4 minus 11 and 5. Okay, but there is a problem here. Serious question. If they ask in the examination, you will get stuck here. Why? There is 0. Correct. And remember one very important thing. The main motive of solving this problem is, if you are watching it, lend your ears, listen carefully. Principal diagonal elements can never be equal to 0, because we are using this 0 to make this. If this is 0, then how can I make the below 0? If the husband is dead, what about 2 wives? Am I right? This element can never be equal to 0. So now again what to do? Very simple, don't worry about it. Again with this 0 again, see with this 0 and now everything is 0 here. First husband, 3 wives. Now with this element, the concept is what? Row transformation, echelon form. With this element, you have to make this below 0. If this is also not there, his dead husband, then where will the wives go? Simple logic. So simply what you do, shift this to this and this to here. That's all. Yeah, you can shift any two rows. Okay? But remember again, if such situation occurs, if the element is 0 along the principal diagonal, shift, interchange the rows. That's it. Okay, don't panic. Now what I'll do, I'll change the rows. Fine, I'll R2 to R3, and that will give 1 2 3 0, 0 minus 4 minus 8 3, 0 0 minus 3 2, and 0 minus 4 minus 11 and 5. Done. Okay, now below this 4 I have to make 0, and this is already 0. I have to make minus 4 0, making use of minus 4. So minus and minus obviously minus. So it will be R4 minus R2. So this will be now again 1 2 3 0, 0 minus 4 minus 8 3, 0 0 minus 3 2, 0 0. Alright? Minus 4 minus plus plus 0. Now here minus 11 minus a minus. See, this is minus 8. Okay. Minus 11 minus bracket minus 8. So minus 11 plus 8 is what? Minus 3. Again 5 minus 3 2. Done. That's it. Now everything over. Okay, now we need to make minus 3 0, making use of minus 3. Simple. R4 minus R3, and that implies A is equal to finally 1 2 3 0, 0 minus 4 minus 8 3, 0 0 minus 3 2, and 0 0 0 0, minus 3 minus 0, 2 minus 2 0. Full row is 0. My work is done. See, below this all, no, I made everything 0, and plus this whole row is 0. That means rank is the highest number of non-zero rows. So for this I can write rank of A, it is row of A again is equal to 3. That's the solution. Very very interesting question. That's why this problem has been repeated many times in the examination. So please follow these 3 problems and go perfectly. Okay, I hope you understood clear how to find a rank. If you understand, if you don't, again go back, again practice one more time. You'll 100% get it, my guarantee. That's all. Okay. Now the next problem is investigate the values of lambda and mu for x plus y plus z is equal to 6, x plus 2y plus 3z is equal to 10. X plus 2y plus lambda z is equal to mu may have no solution, unique solution, infinite solution. See, there are 2 problems like this. One more is both I have solved. Okay, so this problem number 2, investigate the values of lambda for x plus y plus z is 6 and x plus 2y plus 3z is equal to 10, and x plus 2y plus lambda z is equal to mu. I will solve it. Very very important problem. So when during my classes now, when revising for the final, I solve this problem first, because each and every paper this problem has to repeat. That means this time also I am giving you directly. This time also it will repeat. So 7 marks in your hand. Don't ever think of missing it. Please, very very high scoring areas. all this rank, this consistency, everything. This problem I solved, so please find the link in description below. One more problem is investigate the values of lambda and mu so that 2x plus 3y plus 5 that is equal to 9, 7x plus 3y minus 2 that is equal to 8, and 2x plus 3y plus lambda that is equal to mu. May have unique solution, infinite time solution. So this problem also is solid, so please watch it carefully and practice. Plus 3y plus 5z is equal to 9. Okay, and 7x plus 3y minus z is equal to, 2z is equal to 8, and 2x plus 3y plus lambda z is equal to mu. Verified? 2x plus 3y plus 5z is equal to 9, 7x plus 3y minus 2z is equal to 8, 2x plus 3y plus lambda z is equal to mu. May have no solution, unique solution and infinite solution. Very important question. Like this, one more questions I have solved for 1BMAT S101. That is very important. Please check that. So we have here first A argument B equals 2, 3, 5, 9, 7, 3 minus 2, 8, and 2, 3 lambda mu. So the concept of echelon form is we make this, making use of this 2, we make below all 0. So this is simple. You can write this as R3 minus R1 because I can make directly 2 minus 2 0. Okay. So we have A argument B equals 2, 3, 5, 9, 7, 3 minus 2, 8, 2 minus 2 0, 3 minus 3 0, and this will be lambda minus 5 and mu minus 9. Done. Now you need to make 7 0 making use of 2. So LCM is 14 multiplied by 7 and multiplied by 2. 2 7s are 14, 2 3s are 6, 2 2s are 4, 2 is are 16, 7 2s are 14, 7 3s are 21, 7 4s are 35, 7 9s are 63. So this will be now I write here. So what is that? 2R2 minus 7R1. This will be again 2 3 5 9, 2 3 5 9 as it is. 0, 6 minus 21 is minus 15, minus 4 minus 35 is minus 39, and 16 minus 63 is how much? See, 14 minus 14 0, 6 minus 21 is minus 15, minus 4 minus 35 is minus 39, and 16 minus 63 is minus 47, and this will be 0, 0, right, lambda minus 5 and mu minus 9. Okay. So I think we are done here. Now the next is the conditions. So what I am asking now, see, my main aim was here to make this all 0, correct? I made this all 0. Okay. So this for x, y and z. 3 variables. Now they are asking first no solution. The meaning of no solution means what? It means no solution means rank of A is not equal to rank of A argument B. Then only no solution. This is possible only when I want that both ranks are not equal. Okay, this thing is rank A and this whole thing is rank B. A going B. So now if lambda is equal to 5 and mu is not equal to 9, in that case if lambda becomes 5, this whole row becomes 0, then rank of A will be 2 and rank of A argument B will be what? 3. In this case not possible, therefore rank of A will not be equal to rank of A argument B. So inconsistent and no solution. Now the second case is what is that? Unique solution. So unique solution is possible only when there is no solution. Unique solution is possible only when rank of A equals to rank of A argument B equals to n, the number of elements. That is only possible when lambda is not equal to 5 and mu is equal to not equal to 9. Then only implies rank of A is equal to rank of A argument B is equal to 3, that is equal to number of variables n, x, y, z, n. In this case it is consistent and unique solution. You have to write a 3. Okay. And the last case is what? Infinite solutions. So infinite solution is possible when rank of A equals to rank of A argument B and that is lesser than n. That is only possible when lambda is equal to 5 and mu is equal to 9. If both are equal, then only rank of A equals to rank of A argument B, that equals to 2 lesser than 3n. So infinite solutions. That's all. Okay. Fine. This is how we solve it. So you have to underline this. No solution means lambda is equal to 5, mu not equal to 9. And here lambda is not equal to 5, mu is not equal to 9. And here lambda is equal to 5 and mu is equal to 9. Compulsory, underline it. Okay, so I hope you understood the solutions here. One more time, let's revise that when they ask such questions, we find A argument B, and if the rank of A argument B is equal to the rank of A, and that is equal to the number of the variables, x, y, z means 3 variables basically. They will give 3 variables only, okay, not 4 and 5. Then it's consistent and unique solution. But if the rank of A argument B is equal to rank of A lesser than number, says if the rank is 2 and the variables is 3, then it is unique, it is a consistent but infinite solution, many number solution. If both the ranks are not equal, that is the rank of A argument B is not equal to rank of A, then inconsistent, that is no solution at all. So please practice these 2 problems. Out of both, one may be asked in the examination. Please do it. Okay, now let's move to the next problem on Rayleigh's power method. So please, I am going to solve it now here. Please keep your calculator ready, and as I told you, I need you to only get FX991 ES plus or FX991 ES plus second edition. If you have FX991 MS or FX 85 MS, please throw it away. No need. So please get a calculator and get ready. Fine. Now, Rayleigh's power method to find the largest or the highest eigenvalue and the corresponding eigenvector. High scoring area, 150% guaranteed question. You can get full 7 marks here. Okay. Before watching this, I request you to please go to my playlist. You can check for this video. I have solved one question on Rayleigh's power method. It's a classical question. Please do that also. So next one is 6 minus 2, 2 and minus 2, 3 minus 1, 2 minus 1, 3. This same lines, and they given the eigen vectors, initial eigenvectors at 1, 1, 1 transpose. See, they will give the eigenvectors. If they don't give, take it as basically it's better to take 1, 1, 1. Okay, you will get fast answers. If you take 1, 0, 0, it may increase. Okay. If they given the question 1, 0, they take it obviously. Now, I want to practice that first question and then solve this question. I'll give the the solution here for that. For 6 minus 2, 2 and minus 2, 3 minus 1. You can check the solution here after after solving it. Check for the largest eigenvalue eigenvector. Now, coming back to the next question, I will solve it here. I'll tell you why I am solving it. Fine. So first, using Rayleigh's power method, power method, or simply we call it power method. Okay. Find largest eigenvalue and eigenvector, eigenvalues and eigenvector for A is equal to 2, or they are given directly for, it's a 3 by 3 matrix, 2, minus 1, 0, minus 1, 2, minus 1 and 0, minus 1, 2, and here they are given taking x naught is equal to 1, 0, 0 transpose, or sometimes if they don't give transpose, they will give dash, both are same. Transpose why they give? Because the eigen vector is the column vector. If you remove the transpose, it will stand. That's all. Finished. Now, they are given. This question they are given 1, 0, 0. Otherwise some question they'll give, if they don't give, better take 1 on 1. Okay. Now how to solve it? So first thing, they are given x0 is equal to. So I'll take this as a is equal to. See carefully how I am doing it, and please get your calculator ready and practice along with me. Please synchronize with me, so everything will be written here. Okay, guaranteed. So 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2. Take the signs correctly, and initial x0 is equal to, I will take it as, when I remove this transpose, it stands 1 0 0. They are given. Okay. Now first thing what you need to do is a into x0 is equal to 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2 into x0. Now watch carefully, because I am going to show you the fastest method of doing it. If you practice how I do it, you can easily solve this problem it not take more than 5 minutes to finish the problem. Okay, because I've seen in colleges and all, they take half an hour to solve a problem. I show you the most easiest way, because you have the scientific calculator with you. That is FX 992 S plus. The simulation I'll show it side by side. Please refer it. Okay. So first, always reset the memory. Let's start. I hope you are having calculator with you. Fine. Okay. Fine. On, then shift clear 3 all AC. So all memory clear. Calculator is not yours. Okay. Now you need to enter A and x0. So I'll take this as, simply I'll take this as, see for your simplicity, I'll take this as A and B. I'll take this as A and this as B initially. Okay. So for that, what I'll do, mode matrix is 6, number 6. Don't press 1 and all. Press AC. Now to get to the matrix mode, press, see here above 4 there is matrix written. That means above 4 something small means you have to press shift. So shift 4 matrix. So first dimension 1. Now matrix A. 3 by 3 matrix. So let's enter the dimension here. So what are they? 2 minus 1 0. Row wise 2 equals to minus 1 equals to 0 equals to minus 1 equals to 2 equals to minus 1 equals to 0 equals to minus 1 equals to 2. Okay, please verify it, because these fingers can make mistakes. So 2 minus 1 0 and minus 1 2 minus 1 0 minus 1 2. Done. Now stored. Press AC. Relax. Next enter this matrix B. Again shift matrix dimension number 2 matrix B 5. Shift matrix, it's what dimension matrix B, it's a 3 rows 1 column 3. So 1 equals 0 equals 0 is equal to everything stored. Now the operations. So once stored, don't follow perfectly. From practice everything gets perfect, otherwise in between you lose. So practice along. Shift again matrix. What are you doing here? Matrix A into B. So matrix A into again shift matrix B is 4 is equal to, see I'm getting 2 minus 1 0. 2 minus 1 0. The real operation starts here. Who is the highest number? 2. Eigenvalue is the highest value. So divide by 2. So the divide by take this to outside. Simply here only do. Here only divide by 2 is equal to. So what I get? 1 minus 0.5 and 0. Now this is the highest eigenvalue lambda 1 and highest eigenvector x1. Okay, eigenvalue and eigenvector. But when I press, the moment I press equal to, this whole thing gets stored wherein mat answer, the most important operation to be used here. That means you are not going to enter again, you are going to use the memory mat answer to multiply it. Now again press AC, I'll show you. Again shift matrix mat A into, we are going to do now what? Mat answer into, so I'll write here. So again this will be now A into x1 is equal to 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2 into, see 1 minus 0.5 and 0. Okay, so then what are we going to do now? Shift matrix A into shift mat answer is 6, number 6 is equal to, I am getting 2.5. So you can do directly, so highest number is 2.5 here. Okay, so what I will do is I will divide by 2.5. So when I divide by 2.5 here, see, so divide by 2.5 here, so is equal to, so what we do, divide by 2.5 is equal to, so when I divide I get 2.5 outside, and inside I do directly here, 1 minus 0.8 and 0.2. Okay, so now again this is the new eigenvalue and lambda 2 and x2. So again what you are going to do is, again simply multiply a into x2. So a into x2 will be again 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2 into, see, 1 minus 0.8 and 2. Okay, now again shift matrix A into shift matrix answer 6 is equal to, so we are getting again 2 minus 2.8 minus 2.8. Okay, the highest number again is 2.8, so divide by 2.8, so write 2.8 and divide here, divide by 2.8 is equal to 1 minus 1 and 0.4285. This is what we get. Again this is the new eigenvalue and new eigenvector x3. Fine. Again a into x3 will be 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2 into 1 minus 1 0.4285, and this will be again shift matrix, what's that, we have A into shift matrix answer 6 is equal to, so how much I am getting, 3.428. Now see here what happens. I am getting the answer as, I write for you, I am getting the answer here as, for you to show what happens here, 3 minus 3.428 and 1.8571. So I told you divide by the highest value. So what do you think now? You will think, who is the highest value? Minus 3 is the highest value. No, I am telling highest number irrespective of sign, because inside eigenvector can be positive, negative, eigenvalue will always take it positive. So who is the highest number here irrespective of sign? 3.42 is the highest number. Please understand it here. Okay, if you had taken 111, then you had got in 4 to 5 iterations, but here since they given an examination 100, I am getting little lengthy. Okay, so now who is the highest number now? 3.428. Now so divide by 3.428. I hope you got a concept here clear. Is equal to 0.8751 minus 1 and 0.5417. Now this is the new eigenvalue lambda 4 and new eigenvector x4. Perfect, that's all. Now again we will do it. A into x4, A into x4 is equal to 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2 into, the mat answer is 0.875 minus 1 and 0.5417. Again this is equal to same thing, shift matrix A into shift matrix answer 6 is equal to, now here again 2.7504, please verify it, minus 3.417 and 2.80. Again highest number irrespective of sign is 3.417, so divide by, I take here 3.417 and inside will be minus, because eigenvalue is always positive, eigenvector can be negative, so divided by 3.417 is equal to, it is 0.8045, 0.8045 minus 1 and 0.6097. So now this will be my new eigenvalue, that is lambda 5 and x5. So one more time, A into x5 is equal to 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2 into 0.8045 minus 1, 0.6097. See, so easy it becomes. Okay. Now this will be again shift matrix A into shift matrix answer. That is equal to again 2.6099 minus 3.414 and 2.2196. Highest number irrespective of sign is 3.414. 3.414. So divide by 3.414 is equal to 0.7544. I tell you where to stop. 0.6501. So my new eigenvalue and the corresponding eigenvector lambda 6 and x6. A little lengthy problem. Okay. A into x6 is equal to 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2 into 0.7544 minus 1 0. If you do it, practice it, it will be easy for you. Again, shift matrix A into shift matrix answer 6 is equal to again 3.415, 3.415. So divide by 3.415 is equal to 0.7405, 0.7405 minus 1, 0.6736. I will do it one more time. See, where you need to stop means the answer should approximately match. Okay, only 3 digits match. Here it's not matching again. I do one more time. So this is my new eigenvalue and new eigenvector x7. Okay. Next, A into x7 is equal to 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2 into 0.7405 minus 1 0.6706 6736. Okay, again this will be shift matrix A into shift matrix answer 6 is equal to 3.414 divided by 3.414 is equal to, so 3.4 is approximately nearing now, is equal to 0.7267 minus 1 and 0.6875. It's nearing, right? So but little bit nearing. So let's do one more time, lambda 8 and this is x8. Usually this problem is given like that, so I'm solving it here. But generally in the question, all question paper, they are given 1 1 1, but they have taken it as 1 0 0. Okay, so taking 1 1 1, it becomes very easy. So what I'll do for see, I'm doing this now, so don't panic. After getting the answer, I will solve this for your sake. I'll solve this again using 1 1 1 as given in textbook and other question papers. Fine, then let's see what happens. So here, so first it is again this much I get correct. Sentence again, you see shift matrix A into shift matrix answer 6 is equal to 3. It is 3 again, same thing. So I write here like this into 0.7267 and minus 1 0.6875. Okay, and that is equal to 3.414 divided by 3.414 is equal to approximately nearing now. So this is coming 3. See, eigenvalue is coming same approximately 3.414 and 0.7187 minus 1 and 0.6957 6957. So let's stop it here because it's approximately near C. See these values, see this almost same. See this 7172 minus 1 minus 1, this approximately 7. So same approximately. So I stop it here and I write therefore the eigenvalue is, that implies therefore eigenvalue is lambda is equal to 3.414 and largest eigenvector will be x is equal to, you can write if I'm not putting transpose, then write column wise, otherwise you write 0.72 say comma minus 1 comma 0.7. That's the answer. 0.72 I can approximate it. Okay, no issue. 0.787 means 0.72 minus 1 and 0.695 means 0.7. That's the answer. Finished. Now for your sake, okay, because I don't have to get confused, in the exam they given 100, so I got up to 8 iteration. Now what I'll do, as in the textbooks and previous other question papers, in your 18 scheme they are given like this 1 0 0. If we take 1 1 what will happen, I'll show you how fast it happens. Okay, so I'll rub it and show you now. Okay, now we solved that problem, right? Eigenvalue, eigenvector. I'll show the same here so that you don't get confused. Now see here, the same problem. Using Rayleigh's form method, find the largest eigenvalue and the eigenvector for 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2, taking x0 is equal to 1 1 and 1. Okay, earlier it was 1 0 0. Okay, again, so we have now a into x0 is equal to, right here, 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2 into 1 1 1. That's equal to. Now again, the first step, take the calculator, mode, that is, shift clear, 3 all equal to AC. Now again, go to mode, matrix, AC, shift, matrix, dimension, matrix A, 3 by 3, 2 equals to minus 1 equals to 0 equals to minus 1 equals to 2 equals to minus 1 equals to 0 equals to it's minus 1 equals to 2. Please verify it. Okay, 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2 AC, done. Now the second, shift matrix, dimension, matrix B, 3 rows 1 column, so 1 equals to 1 equals to 1 equals to, done. Now I have to multiply again, shift. So first, okay, I have to multiply now, shift matrix A into shift matrix B, shift matrix B is equal to, so I get 1 0 1. See this simple, 1 0 1. So again you can divide by 1 here, highest number is 1 1, leave it. I stored in math answer. So 1 outside, so 1 0 1. So now here again let's follow the process. This is the new eigenvalue, new eigenvector. Again a into x1, a into x1 is equal to 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2 into 1 0 1. Okay, so again this will be equal to, now again shift matrix, I divide by 1, so that is stored in the answer as we did earlier. Shift matrix A into shift matrix answer 6 is equal to 2 minus 2 2. So you get 2 minus 2 2. So again what I do, 2 is highest number, so all are same, I divide by 2, fine, 2. So 2 outside, 1 minus 1 1. Again this is the next eigenvalue and eigenvector x2. So next one, a into x2 is equal to 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2 into 1 minus 1 1. Again same thing, shift matrix A into shift matrix answer 6 is equal to. Now see here, 3 minus 4 3, that's what I am talking about. 4 highest number is what, you will tell 3, but no, irrespective of sign, eigenvalue, 4 is the highest number here. So what I do, divide by 4 is equal to, always positive outside and inside, this will be 0.75 0. See this 75 I am getting little early. Here in the previous, while taking 1 0 0, I was getting, I think, in the 5th iteration somewhat. Okay, now this is the new eigenvalue, that is lambda 3 and x3. Now again a into x3 is equal to 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2 into 0.75 minus 1 0.75. Again shift matrix A into shift matrix answer 6 is equal to 3.5 the highest number, it's coming minus 3.5, 3.5 highest, so divide by 3.5 is equal to 0.7145 minus 1 0.7142. Again lambda 4, I am getting the answer fast here, x4. So a into x4, so a into x4 is equal to 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2 into 0.7145 minus 1 0.7142, and that will be equal to, again now shift matrix A into shift matrix answer 6 is equal to, so again minus 3.48, so divide by 3.428 is equal to 3.428, and this is 0.7084 minus 1 and 0.7084 as it is. So again new set of eigenvalues, that is lambda phi and x phi. Okay, eigenvector again a into x phi is equal to 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2 into 0.7084 minus 1 0.7084. So that will be equal to again shift matrix A into shift we're getting matrix answer 6 is equal to, see, 3.417 divided by 3.417 is equal to 0.7073 minus 1 0.7073. It's approximately nearing now. So let's do one more iteration. So a into x6 is equal to again 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2 and 0.7073 minus 1 0.7073. That will be again shift matrix A into shift matrix answer 6 is equal to 3.414 divided by 3.414. So divide by 3.414 is equal to 0.7073 0.7073 minus 1 and 0.7073. So see, the values are same here, correct? See this value, this approximately same. So you can stop here now. Therefore here the largest eigenvalue lambda is equal to 3.414. I think previous also same answer, verified. And largest eigen vector x naught, x is equal to 0.7073 minus 1 0.7073. I think exact approximately same. Again, I think if that previous problem if you do 2 minute iterations, it will be the same exact answer, but it doesn't matter, it is correct answer. Okay, so that's what I showed you how it happens. So earlier I took 100, I got a little longer iteration. If it make 111, I am getting this iteration. So both out they may ask in examination. So please don't miss this problem at any cost. It's very, very easy. I showed you how to use a calculator. So if you use it properly, you will not lose it 100%. Okay, so that's the on Rayleigh method. So that's the Gauss-Seidel method. So this first problem 20x plus y. Here also there are two questions. I will solve one for you here. Okay. The problem is solved by Gauss-Seidel method. 20x plus y minus 2z is equal to 17, 3x plus 2y 20y minus z is equal to minus 18, and 2x minus 3y plus 20z is equal to 25. So this problem you can see the solution here. I solved it. So please solve it yourself and practice it. So second question I solve for you, solved by Gauss-Seidel method. Okay, let's solve this question. That is x plus y plus 54 z is equal to 110. 27x plus 6y minus z is equal to 85, and 6x plus 15y plus 2z is equal to 70. I'll solve it for you. Okay, so let's see the solution, how to get it. See, this is a very important question which I discussed in VTU papers. Okay, so the problem here is solved by Gauss-Seidel iterative method. X plus y plus 54 z is equal to 110, 27x plus 6y minus z is equal to 85, and 6x plus 15y plus 2z is equal to 72. So see, the condition for Gauss-Seidel method is all the elements around the principal diagonal of the given equations should be greater than the other elements. But here it's not. See, x plus 1y, 1 is, see 1 here, 54 plus 55, see 1 is lesser. Here see 6 should be greater than 27 minus 1, no. Last 2 should be greater than 15 plus 6, no. So what I'll do, I'll arrange it according to fit the Gauss-Seidel condition. So what's the condition? The first element should be greater than sum of this. So I can take the second row here. So you rewrite this as 27x plus 6y minus z is equal to 85. See, 27 greater than 6 minus 1. Next what I'll take, second element, I'll take this 6x plus 15y plus 2z is equal to 72. See, 15 is greater than 6 plus 2, 8. Lastly, first, x plus y plus 54z is equal to 110. Now, okay, 54 greater than this thing. See, all these elements are greater than the other elements. This. That is the condition of Gauss-Seidel. So, now from this, I'll make the equation that implies, see, from x is equal to 1 by 27. See, 27x is equal to 85 minus 6y plus z. So x is equal to 1 by 27, 85 minus 6y plus c. Y is equal to, similarly, see, 15y is equal to, right? So y is equal to 1 by 15. It's very simple way to make equation. So 15y is 72 minus 6x minus 2z. So y is equal to 1 by 15, 72 minus 6x minus 2z. Be careful about the signs here, plus and minus. And lastly, z is equal to here 1 by 54, 110 minus x minus y. That's it. Now this is the main set of equations you need to use while solving the whole iteration. Usually it will be around 4 to 5 iterations. Okay. Now see here, they are not given initial values of x, y, z. So when they are not given, take initial x is equal to 0, y is equal to 0 and z is equal to 0. So using that, I'll solve first iteration now. What's first iteration? X is equal to 1 by 27, 85 minus 0 minus 0, because x is y is 0, z is 0. So let's use the calculator here. So 85 divided by 27, 85 divided by 27 is equal to 3.14815. Minimum take 5 decimal places to get an exact answer. Okay. So y is equal to, now second, 1 by again 15. What's the y formula? 1 by 15, 72 minus 6 into, right, 6 into. So what value of x I found, that will become the value for the next variable. So I found x is equal to 3.14815. So here 70 minus 6x will become 3.14815 minus 0, because that is 0. We are not found z yet. So again this will be 72 minus this will be 6 in, this will be 6 into answer, student answer here, this value is equal to, divided by 15 is equal to, I am getting 3.54074. So next z is equal to, what is that formula? 1 by 54, 110 minus x minus y. So new x is 3.14815 and new y is 3. I hope you are getting it clear now. 4. Okay. So that will be now 110 minus 3.14815 minus answer is equal to, divided by 54. So it's 1.91317. Okay. So the second iteration now. Similarly, so x is equal to 1 by 15, 27 into 85. What's the formula? 85 minus 6 into y. So 85 minus 6 into, what's new y? 3.54074 plus new z is 1.91317. So that will be now 85 minus 6 into 3.54074 plus 1.91317 is equal to, divided by 27 is equal to 2.432175. Similarly, y is equal to now 1 by 54, 1 by 15, sorry, 1 by 15, right? 1 by 15 from the formula into 72 minus 6 into, what's new x? 2.432175 minus 2 into z. What is z? Z is, new z is 1.91317 is equal to, so that will be 72 minus 6 into 2.432175 bracket close minus bracket 2 into 1 point, make proper use of brackets here, 1.91317 bracket close is equal to, divided by 15 equal to 3.5720, 3.57204, and lastly here z is equal to 1 by 54, right? 54 and 110 minus, now the new x was 2.432175 minus nu I is 3.57204. So that will be equal to 110 minus 2.432175 minus answer is equal to divided by 54. It will be 1.925845. Okay, fine. Now the third iteration will be again x is equal to, this becomes the new values for the next variables. X is equal to 1/27 85 minus 6 into what is new y, 3.57204, correct, plus z, what is new z, 1.92585. So again this will be 85 minus bracket 6 into 3.57204 plus 1.92585 is equal to, divided by 27 is equal to 2.4242569. Now y is equal to 1/15. 72 minus 6 into new x is 2.42569 minus 2 into new z is 1.9. I am finding for y, right? Okay, new 1.9285 is equal to now. So 72 minus 6 into 2.42. Please practice along with me. 42569 close and verify answers. 2 into 1.92585 is equal to, divided by 15 is equal to 3.5729. Then z is equal to again 1/54. Z is 110 minus x minus y, 2.42569 minus y is 3.5729 equals 110 minus 2.42569 minus 3.5729 is equal to, divided by 54 be equal to okay, this is 110 minus 2.42569 minus 3.5729 is equal to, divided by 54 is equal to 1.9259. So fourth iteration will be again x is equal to, so the value should match approximately. It's nearing but not matching. So I'll do one more time. At minimum 4 to 5 iterations required to get the full 7 marks. Okay, so I'll show you how to verify it also. So fourth iteration is x is equal to 1/27 and 85 minus 6 into y. What is y? New y was 3.5729 plus z. The new z is 1.92595. Okay, so it will be 85 minus bracket 6 into 3.5729 plus bracket 1.92595. Correct now? 1.92595 is equal to, divided by 27 is equal to 2.4255. 2.4255. And y is equal to, nearing right, 2.42. Yes, I think now this is the last iteration, 1/15 and 72 minus 6x minus 2z. So 6 into new x is 2.4255 minus 2z. So minus 2 into new z is 1.92595. And that will be equal to 72 minus bracket 6, put a bracket 2. Otherwise you will get wrong answers. 4255 minus bracket 2 into 1.92595 is equal to, divided by 15 is equal to 3.573 3 0 1. Okay, and lastly z is equal to 1 by 54, 1 by 1 over 54, 110 minus x minus y, so 110 minus x is 2.4255 minus 3.57301. Okay, last one. So 1110 minus 2.4255 minus 3.57301 equals to, divided by 54 is equal to 1.92595. I think, see the values here, they are approximately same, correct? See, we are getting this as 2.4, 3.57, 3.57. Yeah, so you can stop here. When the values are approximately same, you can stop. So minimum 4 to 5 iterations required, okay, to get a full marks. Don't end in 2, 3 iterations. Minimum do 4 to 5. That's compulsory condition. So where to stop, I'll show here also. Very fast. See, take the calculator, go to mode, go to equation. X was at 3, no? So take number 2. Ax plus by plus cz plus dl. Put the values. 1 equals to 1 equals to 54 equals to 1110 equals to 27 equals to 6 equals to minus 1 equals to 85 equals to 6 equals to 15 equals to 2 equals to 72 equals to. Now see, I will verify 1. It is 154, 27, 6 minus 1, 6, 15, 2, and d values are 110, 85, okay, plus equal to. See, 2.42. So I can write, therefore we can stop here. See, same answer, exact answer I am getting. We can stop. Therefore x is equal to 2.4255. Y is equals to 3.5730. 100% correct answer. After this you do 100,000 million times, you get the same answers. 3.57301 and z is equal to 1.92595. That's it. That's the solution. Easy, right? So please underline it. This is how we get it. It is Gauss-Seidel method. Very simple method, but needs practice and verify the answer to make it accurate. That's all. This is how we solve the Gauss-Seidel method. So same problem, please practice it along with me using calculator. I am 100% sure that you will get it perfect. You can solve any problem, but remember the condition what I showed. This should be greater than this 2, second row, again third row. So if the condition is satisfied, find x, y, z and find the values. I hope you clearly understood. That's it. Now moving to the next problem, here is problem on diagonalization of square matrix. It's a very high scoring area and a compulsory question. Please don't think of missing a single marks here. And for VTU, you have diagonalization of only 2 by 2 matrix, and there are some hardly 3 or 4 problems. One problem is I have already solved. You can check my playlist. Refer the channel, check the playlist. I solved a problem. I think it's diagonalized 1, 2, 3, 4. Very important. One more problem is which I will be solving here. Minus 19, 7, minus 42, 16. Frequently repeated problem, and one more is minus 1, 3, minus 2, 4. This I leave it to you to solve it. Obviously, I give the solution, so you can solve and then refer the solution. Okay, and this all questions are there in the description as PDF form of the most important questions. And also for each and every question I give the link, so please do refer that. Fine. So very important problem here, as matrices is very important topic for scoring. You need to score full 20 marks. There will be choices, so choices up to you what to select. And this is very easy one. Okay, this is 2 by 2 matrix. The problem here is diagonalize the square matrix A is equal to minus 19, 7, minus 42 and 16. So first to diagonalize, we need to first see, let's go step by step in this very simple way. We need to first find the eigenvalues. For the eigenvalues, we need to find eigenvectors, then we get a model matrix and we diagonalize it using the formula D is equal to P inverse AP. Okay, we will see that later, step by step. First we find the eigenvalues. To find that, we need characteristic equation. As this simple 2 by 2 matrix, characteristic equation is given by A minus lambda, determinant of A minus lambda is equal to 0. Okay, now Let's apply determinant here. So we have minus 19. See, simply along the principal diagonal apply minus lambda, that's all. Minus lambda 7 minus 42, 16 minus lambda is equal to what? 0. Okay. See, there is one traditional way of solving it. What's that? Multiply this minus 19 minus lambda into 16 minus lambda minus 7 into minus 42 is equal to 0. Solve the equation. But we'll apply a simple shortcut here. Check it, how you do it. See, basically what I'll do here is, the shortcut is to find the lambdas. See, it's a two mathematics, right? Please pay close attention here, and I hope you are practicing along with me. Okay. Lambda square minus sum of diagonal into lambda plus determinant of A. Simple, is equal to 0. So this will be a easy shortcut here. So let's apply it here. See, very simple. Lambda square, that implies lambda square minus, what is sum of diagonals? Minus 19 plus 16 is minus 3. So minus of minus plus 3 lambda plus determinant of, what is determinant here? Say I'll use the calculator here, better. It will be, I'll solve directly. See, this is minus 19 into 16. So minus 19, it's minus 19 into 16 equals, plus it will be 7 into 42, correct? No, minus plus 42, so it's minus 10. So get this as what? Minus 10. So we have this as plus into minus, so minus 10. So shortcut. So first, now again to find the value of lambda. See, lambda square means there are two values. We'll solve the equation here again in calculators. We have mode equation 3 ax square plus bx plus c is 0. So 1 equals 3 equals minus 10 equals 2 and minus 5. So we get lambda is equal to 2 and minus 5. These are called as what? Eigenvalues. Please underline, since the examiner will have this in the key answer sheet. Underline. Okay, these are called eigenvalues. Now, for each eigenvalue, there is a corresponding eigenvector. Okay, how to find that? See, very simple. I'll show it here. See, this is for x. If we, the whole determinant of the matrix is nothing but equation, simultaneous equation. This is the system of equations, x, and this is what? Y. Okay, this whole column for x, this for y. Now, if you make the equation out of this, we have minus 19 minus lambda into x plus 7y is equal to 0, and minus 42x plus 16 minus lambda into y is equal to 0. So what I'll simply do, I'll take only the first one. There's no need to the second one. I'll take only the first one here. That's enough. Okay, it's your wish. You can take any one of this. I'll take the first set of equations. Now, for these equations, I'll put first for lambda is equal to 2. When I put this in lambda is equal to 2 here in the equation, okay, what I get, that implies minus 19 minus 2 into lambda plus 7y is equal to 0, or minus 21 lambda plus 7y is equal to 0, or minus 21 lambda is equal to minus 7y, sorry, minus 21 x it is, this is x, my bad, minus lambda is 2, right, into x. Okay, so minus 21x is equal to minus 7y, that is 7 1s are 7 3s are 3x is equal to y. See what I simply do here, the value which comes, see, very simple way for this, don't get confused. Whatever value, the ratio, whatever value comes down below that x in the denominator is the eigenvector. That's it. So I'll rewrite 3x is equal to y as x by 1 equals to y by 3. See, I take 3 down, from here I took 1. So what's the ratio here? Below denominator for x is 1, for y is 3. Therefore, that implies the eigenvector is, I take x1 is equal to 1, 3 transpose. Because eigenvector is always a column vector. If I remove the transpose, it will become column 1, 3. That's all. Okay. So I will see it later. So first, we found for lambda is equal to the eigenvectors. Second, now, for lambda is equal to, we have 5. It's 5 or minus 5? I'll check, wait. Yeah, it's minus 5. Sorry, it's minus 5. So lambda is equal to 2 and minus 5 are the eigen values. So minus 5. So for lambda is equal to minus 5, again put here minus 19 minus plus 5. 5 into x plus 7y is equal to 0. That implies minus 14x plus 7y is equal to 0, or minus 14x is equal to minus 7y. 7 is the 7 to the, that implies 2x is equal to y. 7 is the 7 to the. Now what I told, whatever comes to below. So what I can take this, that implies I can take x by 1 is equal to y by 2. So the eigenvectors are, that implies x1 is equal to 1, 2 transpose. So I found both now. I found one is x1, other is x2. Okay, this is x2. Sorry. So I found both x1 and x2 here, the eigenvectors. Now using these eigenvectors, I need to diagonalize. So the matrix of the eigenvector is called as modal matrix. So we have modal matrix is P is equal to, see what I told, eigenvectors are always a column vector. So 1, 3, see 1, 3 and 1, 2, right, like this. That's all. This is a modal matrix. So once you have the modal matrix, the diagonalization is given as D equals P inverse AP. Okay, when I get the result, I'll show you what's the diagonalization. Okay, so first we need to find P inverse AP. So first we need to find P inverse. So P inverse formula is 1 by determinant of P into adjoint of P. See, there is one technique, the traditional way. The one more way is using the calculator. So what I can simply do, go to matrix. Why simply waste time? Go to matrix. Then matrix mode, shift matrix. Then we have dimension. So matrix A is 2 by 2 matrix, that is 5. Enter the elements, that is we have, here. For this now, 1 equals 1 equals 3 equals 2 equals. So we have this matrix A. Then inverse means shift, we have, what is that? Shift matrix A, inverse is here. Inverse is equal to, see, we have minus 2, 1, 3, minus 1. So P inverse is equal to now how much? Minus 2, 1, 3 and minus 1. This is P inverse. Okay. Second, but to show the examiner, please write the formula. 1 upon determinant P into adjoint of P. We get 2, 1, 3, minus 1 using the calculator. Very simple way. See, one more thing I'll tell you now, the simple way of doing it. So I'll write here first. Okay. So when I take D is equal to P inverse AP. Okay. So I'll do everything using calculator. See, I have just now I showed you, I have taken this as A. Correct. I have taken this as AC. A. P as A. Then for P we found P inverse. What's P inverse? When I find P inverse, that is minus 2, 1, 3, minus 1. Obviously, when I press equal to in calculator, that gets stored in what? Matrix answer. So what I simply do is, I take this A as in the calculator as matrix B. So what you need to do, matrix answer into B into A. That's it. Getting the point? Okay. So I'll show it here. See. So what we did, once again I show you. In the calculator, what we did, mode, matrix 6, AC, shift matrix. What I did was, I took this as, for solution for finding inverse, I entered P matrix as A. Okay, that is dimension, I took matrix A. You can take matrix B, whatever you wish. Okay, matrix A. Now that is, matrix A is, it is for P, modal matrix, 2 by 2 matrix, that is 5. So I had it as, 1, 1, 3, 2. 1, 1, so 1 is equal to 1 is equal to 3 is equal to 2. Right, done, AC. Now for this A, that is P, I found P inverse. Correct, that is shift matrix A, inverse is here, inverse is equal to. I got answer minus 2, 3, 1, minus 1. correct? Now I have to multiply it. That means I have to write here as, so D is equal to P inverse AP, that is P inverse is minus 2, 1, 3, minus 1 inverse A is minus 19, 7, minus 42 and 16 into P. P is what? 1132. Okay, I hope we're getting now. Now this is what? Matrix A. This is mat answer, and what I'll choose this as a matrix B. So I'll enter the matrix B here. Again AC, shift matrix, dimension matrix B. It is again 2 by 2 matrix. I'll take matrix B as minus 19 equals to 7 equals to minus 42 equals to 16 equals to store. Now let's multiply it. So everything is in the calculator, no need for manual. That's what I meant to say. Getting it? So if you are using the calculator along with me, there is no need to again worry about, and this whole process will get written here 150%. But not means, again please watch the video and practice it. So let's do the diagonalize the matrix now. So what we have? Mat answer. So always go with the flow, because A into B is not equal to B into A. That's why D formula is only P inverse AP. Okay. So shift matrix answer 6 into, what is this? B, shift matrix B 4 into A, shift matrix test B is equal to, see the answer. So getting the answer as, therefore the answer is, we have, this is equal to what? We are getting it as, just a second, I kept a pen. Okay, fine. The answer is equal to 2 0 2 0 0 minus 5. That's it. And this is the diagonalized matrix. Why diagonal matrix? The meaning of diagonal matrix is elements only along the principal diagonal exist, rest all is 0. See, all is 0, only 2. Therefore it implies the diagonalized matrix D is equal to what? 2 0 0 minus 5. Such a simple solution in which you can easily score the full 7 marks guaranteed. That's all. Okay. So I hope you clearly understood how to diagonalize the matrix. Compulsory question. Next is test for consistency and solve. Consistency of linear equation. I solve this problem here. The first problem is test for consistency. And the first one is, see the question is given. I take this as say A is equal to, or I write a question here first. Test for consistency. The question is x plus y plus z is equal to 6, x minus y plus 2z is equal to 5, and 3x plus y plus z is equal to 8. So watch carefully, don't make any mistake. So for testing the consistency also we find the augment matrix. So we have A augment B equals 1 1 1 6, 1 minus 1 2 and 5, 3 1 1 and 8. Okay. After finding the augment matrix, we apply the row transformation, elementary row transformation. Okay, that's what we do in the Rhine as we solved in previous problems. So simple. What? Making use of this 1, we make this 3 and 1 0. So multiply this whole by 3. So 3 3 3. See, the concept of finding rank or the elementary row transformation is very important, as it will it occurs in the question, which can fetch easily some 14 marks. Okay, so now making use of this 1, I make this 3 0 and 1 0. First 3. So multiply by 3, 3 minus 3 0. So 3 3 3 3 6 are 18. So what's that? R3 minus 3 R1. So that will be equal to now 1 1 1 6 as it is. 1 minus 1. Then I have 1 minus 1 and this is 2. And 5 as it is. 0 minus 2. See, what 3 minus 3 is 0. 1 minus 3 minus 2. 1 minus 3 minus 2. And 8 minus 18 minus 10. Correct? 8 minus 18 minus 10. Now again what can I do? I want to make this 1 0 making it this one. So again R2 minus R1. So very simple problem. So that will be, this has been asked in the examination 4 to 5 times. Again 1 1 1 6. 1 minus 1 0. Minus 1 minus 1 minus 2. 2 minus 1 1. Am I right? Minus 1, see 1 minus 1 0. Minus 1 minus 1 minus 2. 2 minus 1 1. 5 minus 6 is minus 1. So I can also reduce this stuff. See this last row, because any row or column in a matrix according to row transformation can be divided by scalar, but the same scalar. Okay, so I can divide by 2 now. If you divide by 2, what I get? 2 1s are 2, 2 1s are 2, 2 5s are 10. That makes simple. Okay, now what we will do is making use of okay, or what I'll do, I'll keep as it is, because this is minus 2, right? Again you have to multiply, so let's keep as it is. Fine. So this is what I have now. Now what we can do here is, see I had minus 1 2, correct, minus 2 minus 2. I'll keep as it is, because the next concept is what? I need to make minus 2 0 making use of this minus 2. It will be easy. Getting it? So I need to make first column first, second column second. By making use of minus 2, I need to make minus 2 0. So what's that? R3 minus R2. So that implies we have 1 1 1 6, 0 minus 2 1 and minus 1 0, minus 2 minus 2 0, minus 2 minus 1 minus 3, and 10 minus 1 is nothing but how much? Sorry, I think this is minus 10, right? Okay, I forgot here, minus 10. Okay, so minus 10 minus 1 plus 10 is minus 9. This is what we get here. Okay, so we have done the row transformation here. Now as you know, this is for x, y and z. Now see, the test for consistency, the conditions are, if rank of A argument B is equal to rank of A equal to number of the variables. Here it is x, y, z, then it's consistent and unique solution. Let's check here. So here rank of A argument B is equal to what? See, what's the rank? It's nothing but 3. Correct? No? Full, all row exist. Also rank of A equals to what? See, rank of A is this whole part. Which part? This part is rank of A. This whole is A argument B. This, only this is A. Okay, that is rank of A is equal to nothing but again 3 only. So that implies rank of A argument B is equal to rank of A is equal to 3, that is equal to n, that is 3. Number of variables x, y, z. Therefore consistent and unique solution. Very important, you have to write it. Consistent and unique solution. So same as a Gauss elimination, unique solution means, so the solution is, as I told, is for x, y and z. So if last row, see, minus 3z is equal to minus 9. So minus 3z is equal to minus 9. So z is equal to what? 3. Then put here second row, minus 2i plus z is equal to minus 1. So minus 2i is equal to minus 1 minus z, minus 3. So minus 4. That implies y is equal to 2. Correct? No? So minus 2 is equal to minus 4, y is equal to 2. Now the first row is, see, x plus y plus z is equal to 6. So we have x plus y plus z is equal to 6. So x is equal to 6 minus y minus z. 6 minus 2 minus 3, that is equal to 1. Therefore the system is consistent and it has unique solution. The solutions are x is equal to 1, y is equal to 2 and z is equal to 3. That's the final answer. Please write it and underline it. That's all. This is how it is solved. Okay, fine. Now easy question. There is one more question here. It says, let's say here, it is test for consistency and solve. X plus 2y plus 3z is equal to 14 and 4x plus 5y plus 7z is equal to 35 and 3x plus 3y plus 4z is equal to 21. So take the question properly. It's x plus 2y plus 3z is 14, 4x plus 5y plus 7x is equal to 35, 7z is equal to 35, and 3x plus 3y plus 4z is equal to 21. One more very important repeat question. They may repeat this question this time. Okay, you can expect this question. Fine. So first we write a argument b equals 1, 2, 3, 14, 4, 5, 7, 35, 3, 3, 4 and 21. Now, okay, this first element 1, no issue. I need to make this 4 and 3 0 making it of 1, so multiply by 3 here. So 3, 2 is 6, 9, 42. R3 minus 3 R1. And that will be again now, correct? Now 3 in the 3, 3 to the 6, 3, 3 is 9, 3, 4 is 12, 42. 1, 2, 3 and 14 as it is. 4, 5, 7, 35 as it is. 0, minus 3, 3 minus 3, 0, 3 minus 6, minus 3, 4 minus 9, minus 5, 21 minus 42 is minus 21. Done. Agreed? Next, I need to make 4 0 making use of 1. It is 1 4 is of 4. 4, 4 2 is 8, 4 3 is 12, 4 14 is 56. Okay, so this will be now R2 minus 4 R1. This will be 1, 2, 3, 14, 0, minus 3, 7 minus 12 is minus 5, and 35 minus 56 will be, I think it's minus 21, correct? No? Yeah, minus 20. Clearly. So this is minus 5 and this is minus 21, and this is 0, minus 3, minus 5, minus 21 as it is. Now if you see, both the rows are same. So what I'll do, R3 minus R2. So we have that implies A argument B is equal to 1, 2, 3, 14, 0, minus 3, minus 5, minus 21, 0, minus 3, minus 5, sorry, 0, and when I subtract this, we get 0, 0 and 0. Full row is 0. Now as I discussed earlier also, this whole, is A argument B. Fine. And only this part is for A. That means here rank of A argument B is equal to what? 2. Also rank of A is equal to what? 2 only. That implies rank of A argument B equals to rank of A equals to 2, that is lesser than 3. That is n. Why? Because number of variable x was at 3. Therefore, it's what? Consistent. If the rank is, if both ranks are same, consistent unique solution. If the rank is lesser, both are same and lesser the number of elements, then consistent and infinite solution. If the ranks are not equal, then obviously inconsistent. Okay, so consistent and infinite solution. Please underline it. Now we will find the infinite solutions here. See, there is one free variable. I cannot, because x, y, z, as this is, this is x, y and z. I cannot find this. So I simply assume let z is equal to k. A free variable, let z is equal to say k. Because infinite solution, millions, trillions, how much you want? Z is equal to k. Taking z is equal to k, I will find x and y in terms of z. That's the solutions. So I take z is equal to k now. Put in second row. That implies we have minus 3y minus 5z is equal to minus 21. Correct? So that implies minus 3y is equal to minus 21 plus 5z. That is minus 21 plus 5k. So that also implies now therefore y is equal to divided by 3, minus 21 by minus 3 is 7, and 5 minus 5 by 3k. This is what we get for y. Lastly, put in the first row, we have x plus 2y plus 3z is equal to 14. X is equal to 14 minus 2y minus 3z, that is equal to 14 minus 2 into what's y? 7 minus 5 by 3k minus z is again k, because the taken z is k here. So let's take the LCM here. That will be equal to, LCM is 3, is 3 14s of 42 minus 3 6 7s of 42, correct? No, because see LCM is 3, 2 into 3 6 6 7s of 42 plus 10k minus 9k, and this side is calculate. This will be, this will 42 minus 42 cancels, so 10 minus 9k is k by 3. That's all. Therefore that implies infinite solutions are x is equal to k by 3 comma y is equal to 7 minus 5k by 3 and z is equal to k. So these are the all infinite solutions which we obtain. Both problems are very, very important. Okay, they can ask in the examination. So out of this, mostly one will be asked. So very, very high scoring area and high probability question for consistency. Okay, so I hope you clearly understood it. If you are solving along with me, then definitely you have got it till now. That's all. Okay, so now let's move to the next problem. Now the last part remaining is Gauss elimination and the Gauss-Jordan method, a very, very high scoring area in linear algebra or matrices. So we'll finish with that now. There are apply Gauss elimination method and Gauss-Jordan method. I given some 4 problems. I'll be solving 2 for you now here. Rest all you can try yourself. So before moving ahead, listen carefully. As the final touch or the finishing touch to completely prepare you and make you fully confident, I'll be publishing the set of model question papers designed by me. Okay, these are strategically designed question papers. So I want you to solve this properly, and when you solve this properly, something interesting will happen. That is, your fear reduces, your confidence will increase, and that's exactly the shift what we need now. So all those papers I'll be uploading before the examination or a week early on my YouTube channel or my Facebook or Instagram account or pages. So please stay updated, okay, and stay subscribed. So moving on to this problem now, apply Gauss elimination method. Gauss elimination, see both are same. Gauss elimination, Gauss-Jordan. So Gauss elimination, I'll solve one question here. The problem here which we will solve is, let's say this problem, x plus y plus z is equal to 9, x minus y plus 2z is equal to x minus 2y, sorry, x plus y plus z is equal to 9, and this will be x minus 2y plus 3z is equal to 8, and 2x plus y minus z is equal to 3. Okay, x plus y plus z is equal to 9, x minus 2y plus 3z is equal to 8, and 2x plus y minus z is equal to 3. Let's solve this. So as we solved, previously some problems on consistency, the same method. We first find argument matrix. We have A argument B equals 1 1 1 9, 1 minus 2 3 8, 2 1 minus 1 and 3. So the simple concept is, we make below this first column first person 1, below this 1 we make 1 and 2 0. So first we'll make 2 then 1. Okay, multiply by 2, 2 minus 2 0, 1 2 are 2, 2 is 2, 2 is 2, 9 is 18. This is R3 minus 2 R1. So that will give 1 1 1 9 as it is, 1 minus 2 3 and 8 as it is, 2 minus 2 0, 1 minus 2 minus 1, minus 1 minus 2 minus 3, and 3 minus 18 is minus 15. Next thing is, I will make this 1 0 making this 1. So direct 1 minus 1 0, R2 minus R1. So that will be now 1 1 1 9, 0 minus 1 0, minus 2 minus 1 is minus 3, and 3 minus 1 is 2, and 8 minus 9 is minus 1, 0 minus 1 minus 3 and minus 15 as it is. Done. Lastly, we need to make, see, first column over below this 2 0, second column minus 3, below this minus 3 I need to make minus 1 0. So again simple. So how can I make minus 1 0 making use of 3? Minus 3 minus 1 plus 3 0, multiply by 3. Minus 3 minus 9 and minus 45. Am I right? That is 3R3 minus R2. So that will be now 1 1 1 9, 0 minus 3 2 and minus 1 0. See, minus 3 minus 1 minus plus 3 0. Then we have minus 9 minus 2 minus 11, and minus 45 minus 1 plus 1 is minus 44. That's it. As you know, the values here are for this for x, this for y, and this for z. Now we have made all this below 0 by using the row transformation method. Very simple. So start from down. 0x plus 0y minus 11z is equal to, so minus 11. So this method is called as Gauss elimination. Okay, making denominator this below the principal diagonal all 0 is called as what? Gauss elimination. Okay, now let's find the value of x, y, z. So we have from below minus 11, that is minus 44. So z is equal to 11 4s are 44. Then put in the second row, we have minus 3y, c0x plus 2z is equal to minus 1. Minus 3y is equal to minus 1 minus 2z. So minus 1 minus, it is 2 4s are 8. Am I right? Because that is 4. So y is equal to minus 9, that is minus 9. So y is equal to 3. And lastly, x plus y plus z is equal to 9. So x is equal to 9 minus y minus z. So 9 minus 3 minus 4, 9 minus 3, 6, that is 2. That is x is equal to 2. Therefore, by Gauss elimination, you can write x is equal to 2, y is equal to 3, and z is equal to 4. That's it. That's all. Such a simple solution. Underline it for the examiner to give you the full 6 to 7 marks. As is just that. Now if you want to verify again, you can use a calculator. I'm using here again FX 991 ES plus second edition here. So on mode, go to equation 5, then it is what x, y, z, no. So go to second number, A, B, C, D, second. So put the values 1 equal to 1 equal to 1 equals to 9 equals to 1 equals to minus 2 equals to 3 equals to 8 equals to 2 equals to 1 equals to minus 1 equals to 3 equals to, so it is 2, x is 2, perfect, y is 3, and z is 4. That's the answer. Done. Okay, so let's move ahead with, don't you know, again one more is left, Gauss-Jordan method. I'll solve an example. Again the PDF is given in the description for this all important questions, so please check it. So I solved this Gauss in one question. There is one more question. I want you to practice it. Okay, I'll give the solution here. So you just verify the solution. So next one is apply Gauss-Jordan. Gauss-Jordan. Again, after Gauss elimination comes Gauss-Jordan. Okay, we'll see that. So let's solve this question. Okay, this question. 2x plus y plus 3z is equal to 1. Then 4x plus 4y plus 7z is equal to 1, and 2x plus 5y plus 9z is equal to 3. Okay. So this is a problem now. It says 2x plus 5y, 2x plus y plus 3z is equal to 1, 4x plus 4y plus 7z is equal to 1, and 2x plus 5y plus 9z is equal to 3. Okay, so verify the question correctly. 2 1 3 1 4 4 7 1 and 2 5 9 3 5. The same steps here. We first find A argument B, that is 2 1 3 1 4 4 7 1 2 5 9 3. Okay, 2 1 3 1 4 4 7 1 2 5 9. Okay, easy problem, and obviously the question papers of the VTU will be very easy. Okay, only where you lack is discipline and practice. If you are disciplined and practice, then obviously no one is going to stop you from clearing this subject. Fine, believe me. Now again this is a direct question, so what I can do is I can make this below this 2, I have to make 4 and 2 0. So directly I can write R3 minus R1. So So that will be equal to now 2, 1, 3, 1, 4. Do step by step. Okay. 2 minus 2, 0. Directly 5 minus 1, 4. 9 minus 3, 6. 3 minus 1, 2. Again I need to make this 4, 0, making it 2, multiply by 2. 2 to the 4, 2 to the 2, 2 to the 6, and 2 to the 2. R2 minus 2, R1. And that will be equal to now 2, 1, 3, 1 as it is. 4 minus 4, 0. 4 minus 2, 2. 7 minus 6, 1. And 1 minus 2, minus 1. Am I right? Okay. Then 0. What I can do here is, I know I told you, right? We can, what you can do is, if the whole row is divisible by scalar, you can divide it. Make it smaller. I can divide this by 2. 2 to the 4, 2, 3 the 6, 2 the 2. Okay. Now it becomes easy. Again, this work is over. Below 2 I made 0. Now second column, second 2. Below this 2 I have to make 2, 0. So directly R3 minus R2. So you can write A argument B now is equal to 2, 1, 3, 1, 0, 2, 1, minus 1, 0, 2 minus 2, 0, 2, and see, 2 minus 2, 0, 3 minus 1, 2, 1 minus 1 plus 1, 2. Done. Up till here, we call it Gauss elimination, sorry. Below, from below, all this eliminated, we call it what? Gas elimination or Gauss elimination. Okay? Now, Gauss-Jordan means same technique, same circus. Making use of this, make this 2, 0, make this. Same way to do ulta, inward. Making use of 2, I have to make 1 and 3, 0. Making 2, I have to make 1, 0. That means, apart from this, you have to make this also 0, 1, 3 and 1 also 0. Applying the row transformation technique oppositely. Okay, let's solve that. Fine. After here's Gauss elimination. Now let's go to Gauss-Jordan. So how will you do it? See, first I need to make this 3, 0 making use of this one. Sorry, this 3 and 1 I have to make 0 making use of 2. Getting it? So I'll write it once again here. That is equal to now 2, 1, 3, 1, 0, 2, 1, minus 1, then 0, 0. So again let's divide it. Make it simple. Okay, 1 and 1. 2 and the 2, 2 and the 2. Try to make things simple here. It will be easy for you. Now, what I told, making use of this one, I need to make this go ulta. Like how? Making use of this 2, I made this 4 and 2, 0. Then making use of 4, I made 5, 0. Here ulta. Making use of this 1, I have to make this 1 and 3, 0. So how? Multiply by 3. 0, 0, 3, 3. So what's that? R1 minus, see this should be 0. Okay, this and this. R1 minus 3, R3. And that will be equal to now 2 minus 0, 2. 1 minus 0, 1. 3 minus 3, 0. 1 minus 3, minus 2. Alright? See, 1 minus 3, minus 2. 3 minus 0. Okay? Rest all as it is. 0, 2, 1, minus 1. 0, 0, 1, 1 as it is. Now tell me what? Again, this is very simple. Making use of this one, again make this one 0. So obviously this will be R2 minus R3. And that will be equal to 2. See, I have to make this 0, right? 2, 1, 0. Minus 2 as it is. 0 minus 0, 0. 2 minus 0, 0. 1 minus 1, 2 minus 0, 2. 1 minus 1, 0. Then minus 1 minus 1 is minus 2. Correct? Done. See, I made this 0, now I made 1 minus 1 minus 1 minus 2, 0. That's, and this will be as it is. 0, 0, 1. Lastly, I need to make this 1, 0 making use of this 2. So what? See, I need to make this 1, 0 making use of this 2. So multiply by 2 here. 2 to the 4, 2, 0, minus 4. So this will be how much? 2 R1 minus R2, because there is 2 here. 2 minus 2, 0. So this will be now nothing but it implies A argument B is equal to 4 minus 0, 4. 2 minus 2, 0. 0. Then see, 4 minus 0, 4. 2 minus 2, 0. 0 minus 0. Minus 4. Minus 1 minus plus minus 2. Correct? So minus 4 minus 1 minus 2 will be minus 4 plus 2. So minus 2. And this will be 0, 2, 0, minus 2. 0, 0, 1 and 1. That's all. Now here we have made this also 0 and this also 0. This is called what? Together we call it what? Gauss-Jordan. So directly all the principal diagonal will associate with the solution here. So this is x, this is y, and this is z. So directly you can write 4x is equal to what? 2. So that implies 4x is equal to minus 2. So x is equal to minus 1 by 2. Am I right? X is equal to how much? Minus 1 by 2. Then 2y is equal to minus 2. That implies y is equal to minus 1. X, y. And lastly, see, z is equal to 1. That's all. So all the principal diagonal elements gives the answer from the constants. So 4x is equal to minus 2, so x is equal to minus 1 by 2. So y is equal to minus 2y is equal to minus 2, so y is equal to minus 1 and z is equal to 1. So the answer here is by Gauss-Jordan, x is equal to minus 0.5, y is equal to minus 1 and z is equal to 1. That's the solution. That's all. Very, very easy. Let's verify if our solution is correct or not. Again mode, go to equation 5, 2, we have 2 equals to 1 is equal to 3 is equal to 1 is equal to 4 is equal to 4 is equal to 7 is equal to 1 is equal to 2 is equal to 5 is equal to 9 is equal to 3 is equal to, so we get, yeah, perfect. X is minus 1 by 2, that is minus 0.5, y is minus 1 and z is equal to 1. 100% right. This is the way to verify using calculator and to get the full 7 marks guaranteed. That's all. So one more problem is there. So I'll give the solution, you can just verify it. So that's all now. So that's the end of the movie. I think it is a very long picture. As I told you again, please, everything is what you will do here is your discipline and constant practice, nothing else. The more your pen moves, the more you get confident. Nothing I can say, because everything is connected from here to here to here. That's very important. Please don't simply watch the videos, practice them again and again. Again also you can refer my YouTube channel. I have the dedicated playlist over there. Please solve those problems also along with this. These are very important things. I have taken a lot of pain to find the questions, to solve this whole long video for you. It's up to you now what to do. Fine. But this time you have to clear M1. Make your mind. Okay. And the model paper, I'll be sharing it. So please don't attempt immediately. First solve all these problems, practice it, and then create an exam time environment, create a certain alarm, put a time. Okay, and then take the model papers and give your time 3 hours and solve it how much you can. Then you can verify your answers. So when you do it, your confidence increases, and that's exactly what we want you to do. Okay, then when you solving all this videos, watching the videos, practicing them and solving the model question paper, your confidence increases so much that when you go to the exam paper, there is no room for telling that the question paper is long or short, I have forgotten. No, you will see yourself. And because I tell you, in my experience, around 10 years back, I had a student. He was from civil engineering. He was a distinction student. He had cleared everything, only one subject empty head back. That's all. That's because he had got some typhoid from illness. He could not attend the internals, and he was not able to clear it. He was desperate, he was not able to clear it, and he was about to give engineering because only one paper. Then he came to me. I told him the same thing. I made him practice the question, everything. He was so confident, he practiced. He put his whole heart and mind, everything into it. It was only one paper he had. Then he was getting, say, first class distinction marks, but this paper, which was failing, he had only 0 marks in internals. He has not attended the internals at all due to some issues. He got, 85% marks. And that made him so confident. He still calls me now. And see, only because of maths his confidence increased so much that he was able to understand that he was confident to do anything in life, and now he is in a very big position in a big company. Okay, that's what happened. Thing changes. So I hope this same happens with you. So I hope you clear the maths 1-1 paper, 18 math 1 paper, because it's too late now. 18 and now this is year 26. Too late. Please clear it now itself. Again for 18 math. I think 2 and the Engineering Mathematics 2 paper, I'll be, if my health permits, I'll try to do one more video like this. So please do it. So that's all. And please don't forget to stay updated on my Facebook page, my Instagram page and my YouTube channel for the further updates of model question paper and any other things. If you have anything else to discuss with me, please do drop a comment below. I'll be glad to hear. Also my email is given here, or my mobile number also given. You can communicate with me. So that's all for today. We are done with this very long video. I hope this will be beneficial to you. So that's all. Stay confident, stay practicing. Happy engineering. Okay. So what are your results? Please do comment or message me. So that's all, students. Best of luck once again. Bye.